Okay, we're on. So, welcome everybody. Welcome to my third annual Maths Marathon live stream where we'll be solving 24 maths exams in 24 hours. This year, I'm raising money for Mind. Please donate if you're able. It all goes to a fantastic cause. Mind support individuals suffering with mental health issues. Thank you so much to everyone who has donated. As I mentioned in my last video, this is an area that's really close to my heart, so please do consider supporting. Welcome to everybody joining in the live chat. I'll try and respond to your comments and questions as we go. I can't promise I'll respond to everything because I do have quite a lot of exams to get through. If you want to send a super chat, we'll prioritize those, and every bit of money I earn from those will go straight to my to Mind. Excuse me. So please consider sending those in. Joining me will be a few of my closest mathematical and scientific friends who will keep me company. They're going to keep one eye on the chat and keep one eye on my work to make sure I'm not totally wrong on any of my questions. With me this afternoon is my good friend Ollie. You want to take a couple of seconds to introduce yourself there, Ollie?
Hi, I'm Ollie. I like maths. I like Gilbert and Sullivan. And yeah, this should be a fun afternoon.
All right, perfect. So we were at university, didn't we? Quite early on as well in first year, and we're still friends all the way in 2023. I'll get the year right this time, Ollie. So all I can say is thank you for having the patience to remain my friend all these years. I know it's not easy. So shall we get straight into it? So before I start the first paper, I just want to clarify a couple of rules because I always get these sorts of comments. So the score that I'm aiming to achieve on these papers will be approximately 100%, but some mistakes will absolutely happen. So if you do spot any, feel free to point them out, but I'm not going to like clinically labor over every question to make sure everything's 100% correct because I do have a lot to get through. So I'm happy to accept that there'll be a couple of blunders on the way. Ollie and the others are going to be checking my answers on some of the more challenging papers. Having said that, if these papers were going to be marked formally, I wouldn't get 100% anyway because I'm not planning to show absolutely every step of my working because I'm trying to do these quickly. If you are a student, do not do what I'm about to do, which is the worst way of answering an exam paper, which is to try and rush through it and get through it as quickly as possible. That is not the way that you should be doing it. So I just want to make that really, really clear. So I'm going for speed as well as precision. So don't get mad at me for not showing every step. I'll try to at least verbalize every step so that you can follow my working and what's going on. So in terms of the agenda, so I've got 24 exams here. I'm going to start with a round of GCSE papers. So that's the 3 standard papers of the maths exams sat by 15 to 16-year-olds here in the UK. That's at the end of what we call high school. If you're from the US, that's the end of, I think that's middle school. So I think they'll take me about 30 to 40 minutes each. And then we're going to do my favorite part, which is a journey through mathematics. We're going to start with an exam intended for infants, so quite easy, but always very interesting to see the sort of questions that come up on those papers these days. And then we're going to do one exam at each level, all the way up to a degree level paper, because I always find it really fascinating to see how the mathematics develops in sophistication over the years. I reckon that'll take us to somewhere around, I don't know, 9, 10 p.m. After that, I've got a few other types of paper. I've got some IGCSE papers. I've got some A-level papers. The A-level being the exam sat by 18-year-olds. So again, that's at the end of what we call college. And in the US, that's at the end of what you call high school, I believe. And then it'll be around midnight. And at that point, I'll probably be very tired. So a few GCSE, a few more of the standard sort of A-level papers. I've got some challenging further maths papers to do towards the end. And then I've got a special challenge paper to end on, which I'm really excited to do. So that's sort of a rough guide. We'll see how I feel. I might switch things around later. Who knows? I'll be honest, I didn't really get a good night's sleep last night, so I'm already feeling not great. So we'll see how it goes. So are we ready? I think I need to let's get started, shall we? I'm very nervous, actually, I'll be honest, because the past few times that I've done this, I've not had much of an audience at all. I can see that there's a lot of people joining, which is perfect. It's exactly what I want. But it does make me quite nervous. So I think I need to get my hands dirty with some mathematics because I think unlike most people, I feel at my most comfortable and most relaxed when I'm answering exam papers. So that's just the kind of person I am, I guess.
Aren't we all?
Aren't we all? Yes, of course. If only. So I noticed that that thing on my camera is coming up. That's really annoying because I thought I'd fix that last night. So let me just get rid of that. I think if I press that button there. Now that thing there, that will disappear in just a couple of seconds. So let's get started. So we've got the GCSE paper here. Now the first paper is a non-calculated paper, so I can't use the calculator here. So let me just get that positioning. Let's make sure that's all fine. It needs to come just a little bit that way. So it's a very janky setup I've got here, but hopefully that is visible. Right, so let's get into it. All right, so we got some mixed numbers to start with, and we need to add them. So let's do, that's 15 sevenths, and this one is 5 quarters. So then common denominator, so that'll be 60 plus 35 over 28, which is 95 on 28. And that's as simple as you can make it, I think, because that's 5 times 19 and that's 4 times 7. There's no common factors there. So now for division. So 6/5 times 4/3. So 24 on 15. And that one does actually simplify because we can divide by 3. All right, bit of the old fractions to get us started. Not bad. Could be worse, couldn't it? It could be worse. It could be ratio, which the exam boards really love ratio at the moment. So the number of houses to flats is in the ratio 7:4, and then the number of flats to bungalows is in the ratio 8:5. 50 bungalows in the village. That means that we're in a ratio here of so if we convert that top one to 14:8 and then times that by yeah, so it looks like 140 there. So let's say 140. That'll do. All right. Okay. Renee buys 5 kilograms of sweets to sell. 10 pounds for 5 kilos. Renee puts all the sweets into bags. She puts 250 grams. Okay, so that's 4 times 5 is 20 bags. Each bag gets sold for 65p, so that means she's made a 13 pounds. And then she sells them all, so that means she's made 3 pounds, which means that's 30% profit. God, that was you love those sorts of questions that are just like those like multi-step, you know, just awkward. A cycle race across America is 3,069.25 miles in length. Juan knows his average speed for the previous races is that. For the next race, he will cycle 8 hours per day. Estimate how many days. Okay, so if we are estimating, let's just do 3,000 divided by, now estimation, I would divide this by 15 because that looks like an easy number to divide by. However, in the GCSE, the standard is actually usually to round to one significant figure, so we should technically be dividing this by 20. I reckon the mark scheme is generous here and it will allow both. So this is obviously 200. So what is that? That's 200 hours. The next, how many days? So how many days is that? So we need to divide this by 8, which is 25. So 25 for that. So yeah, so I noticed a comment about the fractions for yeah, the GCSE it spans quite a broad range actually. It does get quite challenging later on, so you can be sure of that. The average speed he can cycle increases. It is now 60 miles per hour. How does this affect your answer? Well, if he's going faster, it'll take a lower amount of days. However, if I round this to 16. Yes, it will be lower. I think what this question is getting at is because if we had rounded this to one significant figure, that would round to 20. This would still round to 20, and actually the answer wouldn't change. So because I've rounded it to the two significant figures there, my answer actually does change. So that's what that question was getting at, I think. Okay, so the base of a pyramid here, draw an accurate front elevation. Now, look at this for a sharpened pencil. There's a bit of a running joke in these live streams. I always forget to sharpen my pencils. So my friend Ross, if you're watching this, check that out. Look at how sharp that is. In fact, it's so sharp I should probably lock it away and never use it. It's too dangerous. But so front elevation. So we want 6 centimeters across. 1, 2, 3, 4, 5, 6. Let's draw a nice bold line there so you can see it. And then we're going to go 4 centimeters up. So up to there. That looks like an accurate front elevation to me. I mean, it definitely isn't because I've scribbled it, but who cares? Alright, that was a weirdly easy question. Oh, we're not done. Work out the total surface area of the pyramid. So what I'll try and do is I'll try and make sure both views are on there. Yeah, I know. Tell me about it. I have a bad history with pencil sharpeners, actually. I don't know. I don't understand how you're actually supposed to use them without breaking the breaking the tip of it. So surface area. So we need 6 squared for the area of the square at the bottom, and then the area of each triangle is going to be 6 by 5 over 2, which is 3 times 5, which is 15 times 4 is 60. So 96 overall centimeters squared. Let's put the units on there because anyone that I've ever taught would be very angry at me for not showing the units. So that's that one, and then we're over to this. Oh, now this is an interesting point actually. So some people always ask this, and that question is, have I seen these exam papers before? The answer is no, because I try to. I think I'd genuinely get bored if I was answering the papers that I'd kind of done before. And I definitely wouldn't be able to sit there and do it for 24 hours if it's questions I'd already seen. However, I've done a lot of tutoring with students from different exam boards. Most of the students I teach are from the AQA and the OCR exam boards. I don't actually teach many people who've done EdXL, which is the paper that we're doing here. But I have actually seen this question before, and that's bound to happen, particularly at the GCSE. So this does look familiar. So this one is one of these more problem-solving-y sort of questions that have come up in recent years. We've got 4 squares here. We want to find the coordinates of C. So we're taking 4 steps from 6 to 38. That's 32 in 4 steps is 8, which means the squares are 8 by 8, which means we're going to go 16 to the right to get to C, which means its x coordinate will be 16 plus 6 is 22. And then we're going to go 2 steps down from 36. So 16, that's 20. But that can be quite I remember that the first time I saw that, it actually did take me a minute to try and figure out what's going on there, because there's actually more bits and pieces to it than what it might look like. Right, okay, so transformations now. So shape T is reflected in the line x equals minus 1. So x equals minus 1 looks like that to give shape R. Let's just sketch that in, I think. So it's going to be something like that. That is going to be R. Oh no, I sharpened this pencil and everything. Look at that. That's why you never make them too sharp, I guess. Absolutely heartbreaking. So the shape, shape T is, and then shape R is reflected in the line y equals minus 2. So 1, 2, 3, down to there. Okay, and now it's asking, what is the single transformation that will map T onto shape S? Well, its orientation has been preserved because we've reflected it twice. That's a bit of the old, well, I don't even know what you would call it. I was going to say group theory, but I think group theory is valid, but I think other areas of, I think we first learned that in a geometry course, didn't we? That Yeah, there are only two orientations, and that goes for higher dimensions as well, which is I found a little bit. I don't know if I found it counterintuitive or not. But anyway, we've got this line. I'm going to try and rotate this. I need to find the center of rotate. Yeah, so we can see there. If you imagine that is your axle, and then you take your shape and you spin it round 180 degrees. So I'll say 180 degrees. Don't need to state the direction, of course, because it's making a full half turn. And about, that's how we say it, -1, -2. I think there's another way of doing that. We could have said this is an enlargement of scale factor -1 around the same center of enlargement. That is another acceptable answer I think we could have given for that. Yeah, chirality. So you might have a better intuition of this than I do, but I found it surprising that even if you go up to like 20 dimensions, there's not like other configurations, that kind of arise. I remember finding it quite surprising actually. Okay, so the lengths of the sides are, so this is a classic, I'm going to put 3, 4, 5, because they are not the actual sides, but we do know that 3 plus 4 plus 5 is 12. Now, if the perimeter is 6, that means we need to times them all by 6. So it's actually 30, 18, and 24, which means we've got an 18 by 24 triangle, which means the area of this is 9 times 24, which is 216. One of my favorite numbers, actually. So, hooray! Okay. So,
one of your favorite numbers?
Yeah, it is actually. Yeah, it's I like it because it's 6 cubed, but it's also 3 cubed plus 4 cubed plus 5 cubed. So that's just very satisfying, isn't it? But also, students, like kids, love to ask you what your favorite number is, and there's no good answer because like no mathematician really has one favorite number. But that's a good one because that's something that they can understand, and also it's a good bridge into talking about, it's easy to find two squares that add up to another square. We could find 3 cubes that add up to another cube. Can you find 2 cubes that add up to another cube? And obviously no, because that's Fermat's last theorem, but it's not obvious, and it's a good way into actually, these are some questions that mathematicians, it took a very long time to answer. So, because I think sometimes kids get very wrapped up in the idea that maths is somehow complete. Oh, we know everything that there is to know, I just need to learn it all in math class. It's like, no, there's still like lots of really undiscovered things.
Yeah,
So
solved already.
yeah, exactly. So just some indices here. I think that's because the cube root of 27 is 3, and then square it, you get 9, and then make its reciprocal. That's fine. Here we go with the statistics. James, you're in the chat, aren't you? I bet you're jumping for joy at this. I, on the other hand, am not particularly pleased. Although this is, every student I've ever taught, this is like their favorite question because it is ridiculously easy to draw a box plot. So let's have 133 for the minimum. Let's have 170 for the maximum. And then we've got 145 for the lower quartile, the median at 151, and the upper quartile at 157. It's a pretty symmetric distribution, actually. Work out an estimate for the number of these girls with a height between 133 and 157. Right, so where are we? We are at 133 and 157. Oh, right. So it's just 75% of the. So it's 60. Oh, that was easier than I thought it was going to be. I thought it involved a little bit of linear interpolation or something like that. Never mind. That's interesting, Erin. Yeah, thanks for your comment there. So I've also just had a donation from Anonymous, so thank you to whomever that was. I really appreciate it, and thank you, Andy. I saw you in the chat earlier. Thanks very much for joining. I like the. I think I agree with you that stats. I hated it as GCSE, but I disagree with you. I never started to love it at university, unfortunately. Okay, this looks like it's going to be a circle theorems question, my absolute favorite topic of the GCSE. So we want the angle ACB. That's what we're interested in there. Let's call that theta. We know that ABO, so let's fill that in. That's obviously tangent meets radius at 90, and we are given that this is x. And then find ACB. So then we can go ahead and just start filling in. That there is x, which means this angle here is 180 subtract 2x, which means this angle here is 180 subtract 180 minus 2x, which is 2x, which means we have the property that 90 plus 2x is equal to theta. Oh, no, sorry, plus theta equals 180. What on earth am I doing? And then 90 minus 2x is equal to theta. That's how we say it in the UK, by the way. Don't get mad at me. It's not theta over here. We say theta. I've got so many comments on my latest video about omega. I knew that would happen. That's just how we say it. Prove that the square of an odd number is always one more than a multiple of 4. I will gladly. So let n, an integer, be odd. Therefore, n is 2k plus 1 for some k integer. Then 2k plus 1 squared is equal to 4k squared plus 4k, which is 2 of 2k squared plus 2k plus 1. This is an integer, which means this is an even integer. I'm going to borrow the ring theory notation there. And therefore, this is odd. Done. Okay, some surds now. So, surd, that's a funny word, that, isn't it? Like, we use that a lot at GCSE, but I don't think I've ever heard the word surd outside of a GCSE spec. It's weird, isn't it? You just call it I guess it's the representation that makes it a surd, but I think the more you go through mathematics, the less you care about the representation, and the more you care about the number itself, independent of how it's represented. It's the actual quantity that matters. So this is going to be root 40 plus root 90, and then we play the game of, this is 16 times 5, which means it's 4 root 5, and this one is, well, I want to say 3 root 10, but actually that isn't what we want. So that's interesting, actually, which means I think I shouldn't have fully simplified that one. So that is 4 times 10. So rooted, we get 2 root 10. Yes. So 5 root 10. Yeah, that was made me pause to think there, actually. Okay, so y is inversely proportional to d squared. This is a funny bit of notation as well. You never see that anywhere else. It looks a bit like an alpha, and then d is directly proportional to x squared. Find a formula for y in terms of x. Right, okay, so we've got some initial conditions, if you will. Well, I guess these might be boundary conditions, I don't know. So y d squared is equal to, let's call this k, and then we know that d is equal to, let's call it L times x squared. And then when d is 10 and y is 4, so 4 times 100 is equal to k, so k is equal to 100. And then when x is 2, we get 24, so we know that L must therefore be 6. So y is equal to 100 over d squared. D is equal to 6x squared. So this is equal to 100 over 36x to the fourth. And then we can do a bit of simplifying, actually divide by 4 there. So 9x to the 4. I think that'll do. Factorize, so that's the old difference of two squares. And then hence or otherwise fully simplify. Okay, so hence or otherwise, because this is a difference of two squares, so we can write this as x squared. Yeah, this is in the form a squared minus b squared. So we can write this as x squared plus 4 minus x squared minus 2. And then x squared plus 4 plus x squared minus 2. Doesn't really feel like it's going to be much easier, but I suppose the x squareds are going to die here, which makes it a bit easier. So this is 6 of, in fact, 2x squared plus 2, which is 12x squared plus 12.
We've had a couple of people ask about k in the previous question.
Oh, really? Oh, really? Oh, yeah. Terrible. Well, I did say it was going to happen. So that looks a bit better, doesn't it? Yeah. 4 times 100 equals 100. Well done, Alex. You consider yourself a mathematician. It's not going to be the first time, honestly. Yeah, good point. Thanks for correcting me on that, because that was a little bit embarrassing. Usually the mistakes are like the kind of algebraic simplification. Um, so, so yeah. Oh yeah, so someone correcting me on the proof question. Yeah, absolutely. It was supposed to prove that it was one more than a multiple of 4. So I should have actually written this. Yeah, I got so used to the idea. So this is the multiple of 4, and this is one more than it. Yeah, okay, good correction again there. Wow, really making a hash of this, which does not bode well. So there are only red, blue, and purple counters in a bag. The ratio of red counters to blue counters is 3 to 17. Sam takes a random counter from the bag. The probability that the counter is purple is 0.2. Okay. Find the probability that Sam takes a red counter. Okay, so let's say that number there is x. And then x over 20 plus x is equal to a fifth. So that means 5x is equal to 20 plus x. So that means x is equal to 5. So they're in the ratio 3 to 17 to 5. That makes sense? Yeah, I think that's fine. And then, therefore, 3 over 25 will be the probability that Sam takes a red counter. Yeah. Yeah, let's go with that. All right, simplify fully. So let's factorize the hell out of it. That's what we always do here. Or again, in the States, I think you just say factor, don't you? I don't know why we say factorize, but that's just how we say it. So actually, we can pull 2x out of that, and we get x minus 3 there, and then 3x plus 1 over 2x. That's about as simple as we can make it. Here's the graph of y equals sine x from minus 180 to 180. And I'll tell you what's funny about that is, so recently on my Patreon Discord, we had what I called the Purge, which was our way of getting out all of our arguments for the whole pi versus tau debate. Because it's always an extraordinarily pointless debate, but it does have the tendency to take over maths servers. So we purged our thoughts. And this was the best argument I made for pi, actually. I think the right way to think about angles is to run from minus pi to pi rather than from 0 to 2 pi, which is tau, obviously. And this just reminded me of that. Okay, so sketch on the graph y equals sine x minus 2. So we're just going to bump it down 2 spaces. So I'm just going to sketch in the key points here just so that I don't make a complete mess of things. And then let's... All right, pretty good actually. At my last school, I had the reputation for being good at drawing graphs on the board. If you can get good at drawing graphs, it's something that really does impress kids. Okay, and question 19. So P has those coordinates, Q has those coordinates. A line perpendicular to PQ is given by that equation. Find an expression for B in terms of A. Right. So, let me just do a little bit of the old rearrange there. Just to get my head around it, because I'm going to just draw a quick sketch. So we've got 3, 4. That's P. We've got a negative gradient that's going through 3.5, which looks like that, which means I think Q must be somewhere on this line. Any point Q on this line will be such that the line PQ will be perpendicular to this equation, to this line for which we have its equation. And what's the equation of this line? Well, it has gradient. One way to express the gradient is as the change in y over the change in x. And we know that this, in fact, must be equal to the negative reciprocal of that. I think that's what this question is getting at. So 3b minus 12 is equal to 2a minus 6. So if we want b in terms of a, we can just do b is equal to 2a plus 6, all divided by 3. Yeah, because that the reason we get an equation is we have we have an infinite number of possibilities here. So I think that was what that question was doing. Okay, and the final question of the paper. So if n is an integer with these properties, find all possible values of n. Right. Okay. I think we can do that, can't we? So 3n plus 2 is less than or equal to 14 is just another way of saying that n must be less than or equal to 4. That's fine. Now this one, 6n is greater than n squared plus 5. Now we've always got to be very careful when we are just had maybe a little correction on that last one, or maybe I'm maybe I'm a question behind it, I don't know. Yeah, we're always going to be careful on inequalities. If that denominator was negative, we would have to reverse the direction of the inequality symbol. However, because n squared is always positive, n squared plus 5 is always positive, we don't really need to worry about in this case. So we have n squared plus 5, no, let's do n squared subtract 6n plus 5 is less than 0. So the old quadratic inequality, which, given that it's a non-calculator paper, will surely factorize. Yep, minus 1, minus 5. So n equals 1, n equals 5. Although that is not true, because it's an inequality, which means I'm just going to draw a quick sketch of this. Goes through at 1, goes through at 5. So something like that. And we want the values of n for which this is less than 0. So it's these values of n between 1 and 5, strictly between, which means, because it's an integer, is it an integer? Yes. It can only be 2, 3, and 4. And that makes me worried, actually, because it means that this condition actually doesn't introduce any constraint. So let me just think about that. Certainly, something I don't like about this, because if I do 2 subtract 1, that's minus 1. If I do 2 subtract 5, that's minus 3, which don't times to make a negative number. So what have I done wrong here? Have I got the inequalities the wrong way around or something? Oh wait, 2 subtract 1 is positive 1. What am I on about? Yeah, so I agree that these multiply to give a negative number. I got this one wrong.
Can it not be the 3 options anyway?
Yeah. It has to be 2, 3, or 4. It's just interesting that this actually doesn't do anything. you know, 12 is greater than or equal to 3n, divide it by 3. Definitely get that n is less than or equal to 4. What a weird question. N squared, subtract. Certainly seems correct, doesn't it?
I think it looks good.
Yeah. All right, and that's the end of the first paper. So, all right, a little bit more shaky and more mistakes than I would have liked there. Yeah, tuned rockets and Jeffrey, I think I do agree there because that does happen actually when especially when I'm teaching. You know, the my students will be like, you know, well, surely the question wouldn't be written in that way. I'm like, well, sometimes it is, so I should have that attitude with myself as well. Okay, paper 2. So this we're going to carry on, push through and do some GCSE papers. That's actually quite easy because usually I'm quite surprised at the level of difficulty that the GCSE these days. It can contain some pretty fiendish questions, especially.
Thanks. Don't forget to increment your counter.
Oh, absolutely, absolutely. Yes, thank you for reminding me. I definitely I will forget to do that many times. So we are on exam 2 of 24. How long did that take? About half an hour. I think that's about par, I think. Yeah, so this is the same level. However, it is calculator time. And then yes. Okay, so let's just get straight into it because I think I need to get stuck in here because I'm making a lot of unforced errors. Let me just get my setup correct. How did I do it? I had it laid out in this kind of arrangement. And I've tried to do it this year where you can actually see my calculator display. That there is my lamp that keeps sneaking over because you will not believe how janky this whole setup is. You'd think that... well, I was going to say a professional YouTuber, which is absolutely not true, but someone who makes YouTube videos as part of his living would know how to set up this sort of thing by now. But I really don't. Thanks for joining, Andrew, and thanks again for all of your support. So, yeah, as important as this is, make sure you look after your kids as well. All right, so let's get into it. So this is a calculator paper, but obviously not every question will involve the calculator. That's a lot like they say at university, isn't it? Where it's like, yeah, you can use a calculator if you want to, but it won't help. I think that's all fine. Yep. Yeah, that's a good question. I mean, it's going to sound like I'm bragging, but I obviously at this level they're all kind of the same difficulty for me. But students, generally speaking, find the non-calculator paper harder. That's been my experience.
And thank you very much for the new donations from Anonymous and Dyson. Thank you very much.
Thank you so much. Yeah, £50 from Dyson. That's absolutely fantastic. Yeah, thank you very much. And Anonymous. I never know how to thank the anonymous donors, but thank you very much, whoever you are. If you are watching, we really do appreciate it. Thanks so much. Okay, so lowest common multiple. Well, I'm going to do this the old prime factorization method. So if we do, what is 40? That's 2 cubed times 5. And what is 56? I think that's 2 cubed times 7, I think. Is that right? Yeah. So then the lowest common multiple will be 2 cubed times 5 times 7, which I think we should probably put into 280. Okay. Oh, and yeah, so this is the method that's kind of suggesting here. So 2 squared times 3 times 5, which is, of course, 60. Yes. 60 is the smallest number that's divisible by all the numbers from 1 to 6. And you'll like this, Ollie, because I always used to think, wouldn't it be cool if you had a D60? Because then whatever number of players you have for your board game, you can roll the D60 to figure out who goes first. because you just do your 0, 1, 2, 3 up to 5 modulo 6. You roll it, and there you go. But it has to be 60 sides because that's the smallest integer that's divisible by all 6 of those numbers.
Yep.
So y equals 3x minus 6. What an absolutely bizarre question. I think so. Students generally struggle with the intuition between the equation and the actual graph. But if you just look at that, it's clearly you got gradient 3, or slope if you're from the US, and it's going through at minus 6. So that's all it's going to be. All right. Raya buys a van for £8,500 plus VAT. Pays a deposit for the van. She then pays the rest of the cost in 12 equal payments of that. Find the ratio of the deposit to the total of the 12 payments. Right, so the cost is actually that. So that's how much they actually have to pay. And then the monthly, that is actually 531.25 times 12, which means the deposit must have been that. Which means 3825.6375 is the answer. And now let's just simplify that. I'm going to just use the calculator here and cheat, because if you do it like a fraction, the calculator will simplify it for you anyway. So this is actually just 3 to 5. All right. Yeah, I hate these questions, to be honest. I hate these just I don't know, where you just get a whole, you get someone's life story and you have to yeah. Okay, so 1 take 1 take 6 is minus 6. 4 take 2 take 6 is minus 4. 9 take 3 take 6 is 0. And because a parabola is symmetric, we actually can infer that this is going to be minus 4, 0, and 6 as well. So on the grid, sketch the parabola. Actually, not sketch, plot, which is different. So it goes through at minus 3, 6. This often catches students out as well, because notice the x scale is different to the y scale. They always jump in and start counting the squares. It's like, no, look at the axes. Minus 1, minus 4. And then we go down to minus 6, 6, minus 4, and 0. Just noticed Emily in the chat there. Welcome, thanks for joining. I hope you're feeling better. And yeah, the chicken nuggets always help. It's a friend that I know all the way back from our college days. Okay, should we sketch it in pencil? Should we do it properly? So it's gonna look something. Let's see how good this one is. It's gonna dip down a little bit and then up. A little bit pointy at the bottom. I usually like to get that nice and smooth, but I'll settle for that. That's pretty good. I do like a good graph, actually. I find it really, really satisfying when when you just nail it, you sketch it. Okay. Oh, we're not done with question 5, actually. So use your graph to find estimates for the solutions to this equation. Oh, well, surely it's just 3 and minus 2. Oh, equals minus 2. Apologies. So we basically want, where does it equal minus 2? It's going to be there. So minus 1 point, what are we saying there? 1.5, minus 1.6, and 2.6. Yeah, it is only an estimate. So, okay, a force of 70 newtons acts on an area of 20. The force is increased by 20 newtons. The area is increased by 10. The pressure decreases by less than 20%. Is Helen correct? All right, well, pressure is force over area. We know that much. Oh, in fact, it tells us. So the original pressure, let's call it P1, is 70 on 20, which is 3.5. And then the new pressure is going to be 80 on 30, which is 2.6 recurring. I'm going to do that on the calculator, actually. Let's just make sure that's right. Yeah. Okay, has the pressure decreased by less than 20? So, if we do 3.5 times 0.8, so if we decrease by 20%, then we get 2.8. So in fact, it is being decreased by more. So no, Helen is not correct. Okay, enlarge shape A by scale factor 1/3, center 0, 1. Well, if it's a third, that's 3 on the diagonal there, so there. And then 1, 2, 3, 4, 5, 6. So it's going to have height 2, and it's going to have width. So it's going to look like that, isn't it? That's fine. Yeah, easy. Okay. Question 8. 60 people were asked if they prefer to go on holiday in Britain or Spain or Italy. 32 of the people were male. 11 of the 32 people said, oh, right, okay. What are we thinking? Venn diagram? Or are we thinking, no, I think we do this like a Sudoku. Okay, let's have Britain, Spain, Italy, male, female, total. Let's do it this way. It's probably a more elegant way to do this, but who cares? Okay, so 32 are male. 11 of the 32 people who said Britain, of the 32 people, 11 of them were female, which means we've got 21 British males. 8 males said Italy, which means 21 plus, that's 3 Spanish males. And then 12 people said Spain, which means we get 9, which means, ooh, how are we going to get, 60 in total, which means 28 is there, which means 11 plus 9 is 20, that's 8 people, 16 people. Do these add up to 60? 44 plus 16 is 60, I'm happy with that. Yeah, so what is the actual question, what is the probability, one of the females is chosen at random. What is the probability that they said Spain? 9 over 28. That was a fun question, wasn't it? It reminds you of Sudoku.
Yeah.
It's got that sort of Sudoku sort of vibe.
Yes.
So yeah, like once you unlock one of them, you yeah, it kind of unlocks the rest of the question. Unless you, like I did, forget to read the whole question. Yeah, thanks, James, for responding to that. So, something that I've always wanted to do, just on the actual selection of the papers, something I've always really wanted to do is do 24 maths exams from 24 different countries to see how the kind of, because there's a kind of myth that's on the internet, which is like, oh, 5-year-old Indian students are expected to solve this, or 6-year-old Chinese students are, or Singapore. Like, actually, I don't think that's true, and a lot of the specifications are broadly the same, and they're just kind of clickbaity sort of titles. And so I've always wanted to try and dispel that and do like 24 from 24 different countries. I think that'd be a really, really interesting thing to do. However, it's hard to find papers from different countries. There's like all sorts of permission issues, and finding them in English is also really difficult as well. So if anyone thinks they can help with that, then feel free to get in touch, because that is something that I would really like to do. I think that'd be a really interesting exercise, and it'll mix it up one year. So, okay, Jean invests 12 grand in an account paying compound interest for 2 years. The first year, the rate of interest is X%. Right. At the end of the first year, okay, so that means £12,000 increased by X% is that. So we can work out what X is from that. In second year, the rate is half X%. What is the value of Jean's investment at the end of the 2 years? Now, funnily enough, I actually like this question because look at how it combines fractions with percentages in a counterintuitive way. Now, no mathematician in their right mind would ever do this. However, you've got to design. There's so much to ask students on the exam. You've got to think how you've got 60 questions to ask them everything that they've learned in the last 5 years. So you've got to combine the topics together in clever ways, and I think this is a quite interesting way of doing it. Interleaving, we call that in the education world. So this must be 2.8%, which means we're increasing by 1.4%. And it's compound, which means we need to do the end of year 1 total multiplied by 1.014. And it's 12,508 pounds 70. Don't forget the pound sign. And there we have it.
And can we just say thank you to Alex for your donation?
Well, you're welcome, guys. Don't worry about it. No, but in all seriousness, thank you very much, Alex. Wherever you are, that's very much appreciated. Thank you so much. Yeah, I was really confused at where you were going with that. You just said, and let's just thank Alex. I'm like, for what? Okay. So, a bit of the old vectors now. The dreaded vectors. Students really hate these. So, let's do minus 2a like that. Minus 2a. Work out a plus 2b as a column vector. So a looks like that, and b looks like 1 minus 3. So 1 plus 2 ones is 3. 2 subtract 2 of minus 3 is 2 subtract 6 is minus 4. Does that make sense? If we go along a, and then we go along b, and then we go along b, then we've actually gone 3 across and 4 down. Yep, I agree with that.
It's just been pointed out, it still says it's a non-calculator paper on the overlay.
Oh, yeah, I saw some people having a bit of confusion about that. So that is 100% my bad. That'll change momentarily. You'd think the third time having done this, I would actually know what I'm doing, but I really don't. I think people need to understand that. So some functions now. So f of minus 5. That's 2 over 25. And then fg of 1. Well, g of 1 is 4. And then stick 4 in there. We get 2 over 16 is an eighth. All right. Oh, I like these. These are good. So y is directly proportional to x. That's your straight line graph passing through 0. Y is directly proportional to x squared. This is a quadratic relationship. So d. Y is inversely proportional. Y is proportional to root x, which is this kind of. Well, it's not quite logarithmic, isn't it? But it kind of is it logarithmic? I think it is logarithmic actually, because it's the inverse of an exponential. And then we've got the reciprocal graph. That one. Oh, here we go. Now we're talking. I actually adore circle theorems. Genuinely, unabashedly love them. So A, B, C, D are points on the circumference of a circle. I agree. Show that y subtract x is equal to 90. Oh, you know what I mean? It's just so good. I love these questions. Right then. Well, let's just start to fill this in. We've got a right angle there. We have got the alternating segment theorem tells us that this here is actually y. Oh, and that does it. Oh, that was, yeah, that was not very satisfying. I thought we were going to have to bring them all in here. I thought we were going to have to use like cyclic quadrilateral and everything. Dylan was asked to give some possible values for x and y. Y could be 200 and x could be 110. Absolutely not, Dylan. Sorry, mate. Y must be, well, let's think about this. What is the maximum that y could be? I think y has to be less than 180. Certainly, there might even be a more. No, I think 180, because you can imagine 3 points that are very, very close to each other on the circle. That's basically 180. I think 180 is the limit of the angles, so let's say that. So it certainly can't be 200. It can't be a reflex angle. So stay in school, Dylan. A distance time graph shows information about part of a car journey. Use the graph to estimate the speed at time 5. Right, so speed on a distance time graph is given by the gradient. So, because this is GCSE, which is pre-calculus, we don't have the, we're just going to have to sketch the tangent in there. And this goes through, let's call that 3, 0. And it also goes through 8. Let's call that 60. What are we going up in? We're going up to 20 in 5, so that's in 4s. So 64, 68, 72. So it goes through 8, 72. So 72 over 5, which if we want that as a decimal, is going to be 14.4 meters per second. Yeah, meters per second. Is that right? 72 divided by 5? Yeah. All right. Here we go with the probability. I actually do like a tree diagram. So, yeah, people might know this already, but I'm rubbish at probability, and the only way I can really understand it is in this kind of the mental model that I have in my head, or a schema, as we teachers call it, it's just a whole collection of tree diagrams. That's the only real way I can get my head around probability questions. A darts team is going to play a match. Sorry, Ollie, what were you going to say?
I think we just need to say thank you to the 2 new donations.
Oh, absolutely. Yeah, thanks for pointing those out, by the way, because yeah, it's not like I'm staring at these exam papers and not glancing up at the screen particularly often. So please do point them out. So Nico the Pro and Mizard XYT. I hope I'm saying that right. Thank you very much for your very generous donations there. Thank you so much. Yeah, thanks, Ollie. I mean, really do just jump in and if it's bit and thank, because I think it's really important to thank people. But also I get very in the maths zone, so I often overlook them, but I do think it's important. So thank you.
Good.
All right, so darts Saturday. Winning on Saturday 0.45, so 0.55 lose, and then if they win on Saturday, the probability they win on Sunday, so if they win, it's that. If they do not win, the probability that they will win on Sunday is 0.35. So I guess they have a very streaky performance, where if they win once, they're more likely to win again. I don't know how accurate that is. I think that's common in the sports world, isn't it? Where, you know, if you get on a good run of victories, not that I know a single thing about sports, but there we go. Find the probability that the team will win on exactly one of the 2 matches. So it's either win, lose. I shouldn't use dots for multiplication while I've got decimals in play. And then, or it could be lose, win. And strictly speaking, I shouldn't be saying lose here, because not winning isn't the same as losing, because you could draw. And I like that actually this question has made that distinction. Although, can you draw a darts match? I don't know enough about darts.
Score exactly the same score as the other person in darts.
Yeah, because it's like, it's to get from 501 to 0. So if both teams do it in exactly the same number of darts, I guess that's a draw? I don't know. Snooker is the only sport that I follow, and you can't draw in snooker ever, which I think is a good aspect of how that game is constructed. Like, it's impossible to draw a frame, and it's impossible to draw a match, which I like. It makes it a bit cleaner, I think, the way you allocate victories and things. Okay, so we've got a circle here. So r squared is 12.25. That means that the radius is the square root of 12.25, which I think is going to be... Oh, I think I'm going to kick myself when I see... What number is that? I've seen 12.25 before. 3.5, maybe? Yes, 3.5. I I can't remember how I know that. Draw the graph. So we need a circle of radius 3.5 centered at the origin. So let's get the compass out here. So 3.5 and something like that. That's a very faint pencil. I apologize. I'll go through that a couple more times. Hopefully you can see that. Doesn't look right, but it is. Okay, hence find estimates for the solutions to this simultaneous equation. Well, this is y equals minus 2 x plus 1. So we need to gradient of minus 2, and it's going through at 1. So 2 down like that, which means our solutions will be xy equals either this or this. So minus 1.3, and then the y 3.2, and then the x solutions looks like 2 actually, and then that looks like, I don't know, 2.9, minus 2.9 I should say. Yeah, that looks about right. I wonder if the next question is going to ask me to solve them. No, because it says the total there, because sometimes they ask you to estimate and then to solve. Oh, well, James, here's another one for you. Oh, thanks very much, Abby. I've just seen your message. Thanks so much for joining. Great to have you here. Paul, thanks so much for joining. So, Australian time there, I guess. And I genuinely had no idea that that was your actual name, but now it really makes sense in retrospect based on your username. But yeah, thanks very much for joining. I guess I'll see you a little bit later. It's so weird that you're going to go to bed now and then come back later. But that's how time zones work, I guess. So, histogram, James's favorite. So 5 by, yeah, okay, complete the, yeah, so it's the area of the histogram that tells you the frequency. So 10 times 0.4 is 4, 10 times 0.6 is 6, 5 times 1 is 5, and then 20 times 0.2 is 4. Please tell me that's all we're going to do. No, there's more histogram. There's more histogram. So find an estimate for the lower quartile of the times taken to finish the puzzle. So it's a bit awkward how I'm going to have to position this. What have we got? We've got 4, 4, 6, 5, 4, 23. 23. What an awkward number. Is that right? Five. Yeah, I think that's fine. So if we divide that by 4, then approximately the 5.75th entry will be the lower quartile, which means we want this value here, 1.75 of the way along. So using linear interpolation, we're going to go about 43% of the way through this region, which has width 10, and then add that onto 5, we get 9.375. Histograms, honestly, who needs them? Neptune, I've just seen your comment. That's funny. I guess you know you get so engrossed in the maths. It's hard to turn away, isn't it? Okay, so say again. Sorry.
Always has been.
Always has been. Absolutely. So AB is 7.3. CH is 8.1. So let's put, obviously it's a cuboid, so I can put that 7.3 there, no problem. And angle BCA. Right, this is awkward. So let's just make sure the diagram, the quality of the diagram usually dictates how easy the question is. So I'm just going to make sure the diagram looks nice. Let's call that, well, let's not call it theta because we actually know what it is. Let's call it 48 degrees. Find the angle between AH and the plane. So basically between that and the base, which is the angle between, it's there. Right. So obviously it's a right angle in there. And right. Okay then. So we've got that. VCA. Okay, so if we find AC, so basically I'm just gonna sketch down here. We've got ADC, which is 7.3. Now that angle there is 48, which means this angle here is 42 degrees. So this, if you imagine, we're stripping this triangle out of the base of the cuboid. The reason being, I want to find out what this is. So let's call that X. And now let's do, so the cosine of 42 is equal to 7.3 over X. So if we give it the old switcheroo and do 7.3 divided by cos 42, we get minus 18. That is because my calculator is in radians. So let's just change that. 9.82. That looks a little bit more sensible. And now we've essentially got this triangle, which is AHC. So I'm kind of, that triangle that's cutting into the cuboid there, I'm pulling that out because we've just worked out that AC is 9.82. We want theta, and we know that this is 8.1. So therefore, the arctan of 8.1 over 9.82 will yield the solution. So arctan of 8.1 over 9.82 equals 39.5 to 1 decimal place degrees. I think that's yeah, that's fine. I always like to. It's always good practice to double check whether your answer actually makes sense. 39. It's a little bit smaller than I expected, maybe, but I think that's fine. Yes. Yeah, mad lad. That's a good point. I should really be putting degrees there, but yeah. Luckily, I mean, usually the radians, the answer is so wrong that it's obvious that the calculator doesn't have the right setting. But I have been caught out by it before. Oh, this one looks cool. So shape S is 1/4 of a solid sphere. That's a cool, like, watermelon wedge, I guess. The volume of S is that. Find the surface area of S. Okay. Oh, and it's given us the formula. That's no fun. The expectation is that students memorize these days. Although in recent years, they have been given a formula sheet to make up for education time lost during the pandemic. Give the answer to correct to 3 significant figures. Oh, right. Okay. So volume is 4 pi r cubed over 3, and that's equal to 576 pi. Get rid of the pi's. So if we take the cube root of 576 multiplied by 3 divided by 4, that will give us the radius, which is 7 point. Now we want our final answer to 3 sig figs, so I'm going to write this down to plenty more. Let's do 5, just so I don't want to introduce a rounding error. And now the surface area of the sphere is going to be 1/4 of the shell of the sphere. So 4 pi times 7.5595 squared, because we are taking the whole sphere and we are just quartering it. And then we need to add on these faces here, which are both half circles. So that's actually just pi r squared, 7.55 5 squared.
Yeah.
Because if you take a half circle and a half circle, that's a full circle.
Just to double check, you've got the shape S's volume itself is 576.
Oh, yes. Yes. Very good point. So, actually, this is that, isn't it? Yeah, okay. Very good point, actually, because that's going to ruin the rest of the calculation. So, actually, that should be 4.7622, and we'll change those. Okay, so quarter and 4, they are going to die there. So actually, this is interesting. This is just 2 pi times the radius squared. Yeah, as long as I've not made another mistake. I think this is fine. So 2 pi times 2 pi times that squared is 142 centimeters squared. Why am I having doubts about that? 2 pi r squared. Can't see any reason why it's wrong. I'm just I suppose it's interesting actually what's happened here because the whole surface area of the sphere is 4 pi r squared. So that's interesting. By quartering the sphere, you get half of the surface area. Okay, so someone else still saying I'm wrong here. It should be 4 times. I'm not following. I think I'm happy with this. What do you think, Ollie?
I'd have to do it again from scratch to be sure, but
Yeah.
I got lost.
Um. Yeah. A quarter. There's someone saying about the. It should be 4 times 576. No, I was right the first time. Oh no, I wasn't. No. It's sorry. Yes, it's not that this. So I misread it. Yeah, so I thought the volume of the sphere was that, which means the volume of this shape is that divided by 4. In fact, that is the volume. So that has volume. So that means the quarter. Right. Okay. Let's start again. Yeah, my gut was telling me something was fishy about this. So um, 4 pi r cubed over 3 divided by 4 is the volume of S. Okay, and that is 576 pi. So the 4's die. So now, and the pi's obviously cancel as well. So R is equal to the cube root of just 576 times 3. 12. Well, that's a nice answer, isn't it? We should have
more reasonable.
We should have known. Although non-calculator paper. So 4 pi times 12 cubed over 3. That's the volume of an entire sphere. So if we quarter it, we get to 576 pi. I'm now convinced that this is the right way to do it. We have this stage is still correct, I think. So now, no, let's just do it. So for the surface area of the sphere, it's 4 pi times 12 squared. That would be the surface area of an entire sphere. But then we quarter it, and then we take a half circle. So that's pi r squared over 2 plus pi r squared over 2, which is pi r squared. So that's pi times 12 squared. I'm still convinced that this is correct, which means they die, and it means we get 2 pi times 12 squared. So 288 pi, which is let's just not. I've made so many mistakes on this one. Let's just do that. Yeah, 288 pi. So that's 905 to 3 significant figures. Okay, I think I have a little bit more faith in this answer now. The fact that we got 12 was a nice answer. But it is interesting what's going on here. So if you take the quarter of a sphere, the resulting shape has overall half the surface area. And I didn't know that. It's interesting. I suppose it's not entirely surprising in retrospect because you're creating these two, which is pi r squared plus pi r squared, which is the 2 pi r squared that you get from that like bottom half of the sphere there, because it's overall 4 circles to cover a sphere. But it is still kind of interesting. Right, let's put that one behind us. Thanks for everyone who commented on that. That was a bad. Well, it was a genuine mistake that I made, but also a misread as well, which led to the second mistake. Okay. Oh, they love these questions these days. So Martin did this question. So he's going to rationalize the denominator. So that's the correct technique. And then let's check his expansion. 2 times 2. Oh, no, that should be negative 3. Because root 3 times minus root 3 is equal to negative 3. Sorry, Martin. Okay, and then Shan did this question. So again, correct technique. We've ended up with 12. That bottom bit is right. What's gone on here? So 5. Well, root 12. That is root 4 by 3, which is 2 root 3. So it's that, not 3 root 2. That's classic. That's genuinely a mistake that a lot of students make, actually. And I suppose the first one as well, because sign errors always happen. Right. And then final question of this paper. Jackson is trying to find the density of a block of wood. I suppose he has nothing better to do with his time. The block of wood is in the shape of a cuboid. So we've got something like that. The length is 13.2. The width is 16, and the height is 21.7 in my terrible diagram. He measures the mass as that, corrects to the nearest 5. Okay, this is a bounds question. So by considering bounds, work out the density of the wood, giving your answer to a suitable degree of accuracy. Right, so the upper bound for the density is given by, so density is mass over volume. Interesting that it didn't give us that formula. So if we do the upper mass divided by the lower bound for the volume, that will maximize the density, dividing big divided by small. So the mass, how big could the mass possibly get? If it's correct to the nearest 5 grams, then the upper bound, let's do mass upper and mass lower. The upper bound is going to be 1972.5. If it was any higher, it would be rounded to 1975. And the lower bound, just while we're at it, is this, 67.5. So this is 1972.5. And the lower bound for the volume is going to be when all of these are as small as we can possibly make them. So volume lower is, right, these are correct to the nearest millimeter. So 13.195. No. Yes. No. Yes. No. That's millimeters, isn't it? So it's actually just 13.15. that would be correct to the nearest millimeter. Yeah.
Yeah.
Okay, yeah, happy with that. Yeah, I was thinking meters, and so and then we times by 16 point. No, we don't. We times by 15.95, and then we times by 21.65. Okay, so 1972.5 divided by 13.15 times 15.95 times 21.65 is 0.43438285. Okay, and then the lower bound for the density is the lower mass divided by the upper volumes. I'll just do this on the calculator. So 1967.5. Now the upper bounds for all of these will be 13.25. Yep, that's on the cusp of being rounded up. And then 16.05 times 21.75. Very fiddly question, this, I have to say. So that's volume upper, which is 0.42536775. Right, so to a suitable degree of accuracy, so if we round to 3 decimal places, the answers will be different. If we round to 2 significant figures, so I'm going to say this is 0.43 is the answer, grams per cubic centimeter. That's quite small, isn't it? Shouldn't wood? Oh, I suppose wood does float, so it should be. Yeah, okay, I can believe that. And then to 2 significant figures. That was quite a fiddly question. You can see where all of the mistakes might be in that question.
Yeah.
Tricky. Students hate bounds. Always catches them out, big divided by small equals the biggest, that sort of thing. Right, okay, so
Or if our case says it weighs as much as a duck, yes.
Yeah, and Google says 0.3 to 0.9, which yeah, I can believe that because there's some very dense wood, isn't there, like mahogany and whatever. I'm assuming is dense. Right, let's crack on, because that one took me longer than I wanted it to. That took like 45 minutes. That's very slow for a GCSE paper. So let's just push forwards. We've got the next GCSE paper, which is also calculated. Let me just update the exam counter here. And thank you so much, Demasias, is that how you say it? For your donation. Thank you very much. Really appreciate it. So, exam 3. Okay, write down the type of correlation. Negative. Hopefully all the questions are that easy. How do I have this? Yeah, that's my discard pile. Here's my draw pile. Christina is 11 years old. Her best time to run 100 meters is 12 seconds. The point representing this information is an outlier on the graph. Explain why. So where is she? She's 11. So that's Christina. Doesn't match trend. Let's say that. Sufficient. I mean, obviously you'd use the standard deviation and things like that if you're a grown up. But at this stage, yeah, I think I don't know what else to say other than it doesn't really match the rest of the data. Debbie is 15. She says the scattergram shows that I should take less than 12 seconds. No, outside range. So extrapolation, which is not reliable. That's fine. Let's just stay that. Okay, and then expand and simplify. So we've got 9p, 15 take 2 is 13.
Someone just wanted to check how many questions are there in total.
How many questions? There's about 20 in each GCSE paper. Depending on the exam board, AQA tend to have more questions because the questions are generally a little bit easier, I think, although there's not really much to it. This EdXL tend to have some of the quite deeper questions, so it's fewer but harder questions, although they're not really that much harder. Right, draw a triangle equal in area to this trapezium, or trapezoid as they say over the pond. 1, 2, 3, 4, 5, 6, 7. 1, 2. 1, 2, 3, 4. So 7 plus 2 times 4 over 2 is 18. So we want a triangle of area 18, which means we want a square of area 36, and then we cut it in half. So let's do it that way. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And there we go. That'll do. Another tree diagram. When a biased six-sided dice, you would never dare use a biased dice, would you, Ollie?
Whatever.
Never. The probability it will land on 4 is 0.65. That is very biased. That is extremely biased. That's like a lead plated on one face, and the rest of it is made out of low-density wood. The biased dice is thrown twice. The diagram is not correct. Yep, wrong. Should be 0.35 for, yeah, well, whatever. I'm not going to write it down. And then what else do we get? Yeah, these are also the wrong way around there, so that's bad as well. Okay, right angled triangle. The size of angle ABC is what we want to find. Let's call it theta. This is an unusual question to get on the GCSE paper these days because they don't like to ask these straightforward, just deploy some maths. They like to usually have a bit more problem solving involved. 7 by 11, which is 50.5 degrees. The length of AB is reduced by 1 centimeter. The length of BC is still 7 centimeters, and it's still a right angled triangle. Wow. Now this is interesting. Does the value of cos ABC increase or decrease? How could you possibly make that shorter, preserve its right angle? Oh, I see. It actually must be the case that we're making the line like that. We're kind of bringing it down. That's the only way to preserve that and preserve the length of the base. So actually, the new angle looks like that. So, in fact, the cos of the angle goes from 7 over 11 to 7 on 10, which is bigger. Increase. Yeah, 7 divided by, I'm not making a stupid error there, am I? No, yeah, that's definitely bigger. That was interesting. I had to think about that. It wasn't clear how you'd transform that triangle in such a way. Okay. There are some counters in a bag. Oh yeah, just to respond. Yeah, so these are past papers, yeah. The counters are red, white, blue, yellow. Bob is going to take a random counter from the bag. The table shows each of the probabilities that the counter will be blue or will be yellow. There are 18 blue counters in the bag, so we can use that to actually calculate the total number of counters. The probability that the counter Bob takes will be red is twice the probability that it will be white. So let's call this X. Let's call this 2X. Work out the number of red counters in the bag. Okay, well, we can do that. So 3X plus the sum of those two, which is 0.7, is equal to 1, which implies that X is equal to 0.1. So probability of red is 0.2, probability of white is 0.1. Now, because there's 18 blue, so blue divided by the total is equal to 0.45. So if we do 18 divided by 0.45, what's that going to be? Let's see if I can just... I'm slower than I used to be at working out these sorts of things. No, forget it. 40. Yeah, it felt like it was going to be nice. Yeah, of course it is, because there's four 0.5s in 1.8 and then 10 further. So 40, there's 40 in total. The probability of red is 0.2, so 0.2 times 40 is 8. Now a marble is going to be taken from random from a box of marbles. The probability that the marble will be silver is 0.5. There must be an even number of marbles in the box. So if we say number of silver is S and the total is T, then S divided by T is equal to 0.5. Therefore, the total is equal to 2S, which is even. I'll do. Solve that. Okay, well, we've got 5 minus x is equal to 4x minus 14. So rearranging that, we get the x is 19 over 5, I believe. Yeah, that's fine. I suppose do we want it as a decimal? No, that's fine. Okay, ABCDE is a pentagon. BCD is twice ABC. So if we call that theta, then this is 2 theta. Work out the size of BCD. So that is what the one we want to find. So all the internals in a pentagon plus 3 theta, what do they add up to? 540 or something? So 3 times 180, yeah, 540. So if we do 540, subtract 90, subtract 115, subtract 125, divide the whole thing by 3, we get that theta equals 70, which means 140 is the answer that we are after. T is equal to that. Oh, this is a standard form question. Work out the value of T. I hate these questions where it's just basically, I talked before about you've got 60 questions to ask everything that kids need to know. This question is basically, can you use the calculator? There's nothing really going on here. And watch me get it wrong now. That's it's bound to happen. So 5.6 times 10 to the minus 5 divided, I'm going to get the cubed in there, otherwise I'll forget to put it in later, divided by 1.4 times 10 to the power of minus 4. And it is 4,520 to 3 sig figs. W is increased by 10%. D is increased by 5%. Lottie says T will increase because W and D are increased. Ooh, absolutely not. Well, not necessarily. Lottie is wrong. I agree. Explain why. Well, if we do an increase of W, we get that. And then we increase D 1.05 times D cubed, so 1.05 cubed is that. So we've got 1.1 W over 1.16 D cubed, and then 1.1 divided by that is 0.95 of W on D cubed, which is going to pull down the answer. That's going to decrease the OG W on D cubed. It doesn't matter that we're rooting it, because if the thing that you're rooting is smaller, then the root will be smaller.
Bagley, thank you very much for the £1,000 donation.
Holy moly. Are you kidding?
No.
Oh my god. Well, thank you so much for that. That is genuinely unbelievable. I genuinely cannot believe that. Um, if you've made a typo, and you're supposed to donate £100, then obviously we'll sort that out. But hopefully not, because that is absolutely incredible. Thank you from the bottom of my heart. Thank you so much. That is absolutely incredible. As I not a typo. Okay, thanks very much. Honestly, I'm kind of I've almost got a tear in my eye here. I'm really touched by that, because this is a cause, as I've mentioned, is very very close to my heart. It's something that I really do care about. And while it's just a bit of fun, we're just doing some maths papers. That is, I am doing it for a cause I really believe in. So thank you so much for that. I don't know what to say. That's incredible. Thank you so much.
Now a bad time to mention that the previous question should have been in standard form.
Oh, right. So there was a little bit more to this question rather than can you just use the question? Can you just use the calculator? What did I say? Didn't I say I was going to get this wrong? So 4.52 times 10. What is it? 3? Yeah. So that's the answer. Oh my god. I should never comment on how easy a question is going to be, um, because I will absolutely get it incorrect. So Douglas, yeah, you're right. 1.05. Oh, and thanks for your support, by the way. I recognise you as someone who's recently just joined my Patreon. So thanks very much. Yeah, 1.05 squared, but we're talking about cubed here. I don't know if you're responding to like maybe correcting what I'm doing, but yeah, we're cubing it, and it is greater. And if the denominator is greater than the numerator, it'll drag down the total anyway. I don't know if you were providing like an alternate explanation. I think that's what you might have been doing. But yeah, I just wanted to kind of clarify that. Yeah, but I actually can't get over that donation, Bagley. That is incredible. Thank you so much. I'm really quite finding it hard to concentrate now, because I'm really quite amazed by that. Oh, I think I'm going to enjoy this question. So lamp A flashes every 20 seconds, every 45 and every 120 seconds. The 3 lamps start flashing at the same time. How many times in 1 hour will the 3 lamps flash at the same time? What a fantastic question. I love this. This is great. So we want the lowest common multiple of those, which my brain is telling me is 480, because that's odd, which means we need to take 90. So 120, 240. Oh, it could be 360 actually. Yeah. So there's no 9 in here, so we need to introduce 9, which means we need to introduce an extra 3. So it's got to be 360. 20 is just along for the ride. That's gonna catch up with 120 because it's already a factor of 120. So 360. So flash every. That's the worst word ever written down in my whole life. Apologies. They flash in simultaneity every 360 seconds. That's every 6 minutes, which means 10 times over the course of 60 minutes. Good question. Big fan of that. In 2003, Jerry bought a house. Well, good for Jerry. We can't all buy a house. 2007, Jerry sold the house to Mia. He made a profit of 20%. Then she sold it for that and made a loss of 10%. Unlucky Mia. Work out how much Jerry paid for the house. Okay, interesting. So, let's say he paid X. No, let's not do it that way. Let's work backwards. So if she sold it for 162,000, then she must have bought it for 162,000 plus something. And X is 10% of 162,000. I think this is right. So in other words, X is equal to 162,000, 16,000. Is that right? Yeah, because if she loses 10%, it must be that she bought it for 162,000 plus 162,000 is that. So it must be that she bought it for this much because it goes down. No, it doesn't. No, no. This is yeah. I thought I had a feeling that this was wrong. It's that X, the loss that she made, divided by what she paid for, is 10%. So that means if we rearrange, we get 0.9x is equal to, so it's I'm slightly off there, 1620 divided by 0.9, 1800, 18,000 even. Now, does that make more sense? So what did she pay for it? So she got 162,000. Sorry, that's really in the light there, isn't it? I need to be careful about that. So 180,000. So 180,000. We're saying that she lost 10%, which is 18,000. And yes, we land on 162,000. Okay, so I'm happy with that. So she paid 180,000. So get rid of that rubbish. 180,000. Okay, now Jerry bought the place for 180k minus something because he bought it cheaper than that, and that's what he paid, and the amount of money that he made is that. So 0.8y is equal to 36,000. So 36,000 divided by 0.8 equals 45. So I'm saying he bought it for that much. So let's just check this. So if he bought it for that and sold it for that, then that means he made that amount of profit divided by his investment. This should come out to be 20%, 25%. I think I've made the same mistake again here. The amount of money, quite tricky actually. Yep. I'm having a bit of a brain fart here. It's because of the way profit is calculated. It's never stuck right in my brain. So 180,000, and then he bought the house for 180,000 minus something. That's what he paid. His profit is Y. And that is 20%. 20% of 180,000 minus Y. It's that. It's that. So, because it's subtract Y, that's 1 point. That's it. That's it. 36,000 divided by. Well, that's what you get for trying to rearrange everything in your head. 30,000. So 150,000 is what he paid for it. Let's just check it because I've made a hash of this. That's not a 5. That's a 5, by the way. So if we're saying that he made 30,000 divided by his investment, we get 20%. Okay, so Jerry paid 150,000. I don't know if there's an easier way of doing that because I think I made I think I made a meal of it, to be honest.
I liked Mizzard's solving, which was 162 100,000 divided by 0.9 and then divided again by 1.2 in order to get 150,000.
Yeah, yeah. That makes a lot of sense. I don't have it's one of the things actually that profit and loss, I don't know, I just don't have a good intuition for it actually. I don't know what it is about it. Okay, so we're gonna find the here's what I've got a bit of intuition for. So a gradient. So for every 4 we go along, we go up by 6. So 6 over 4, which is 3 over 2, which is 1.5 if you prefer that. Does that make sense? For every 1 we go along, we go up by, yeah. Explain what this gradient represents. The increase in volume per second. Because once we get to the A level, it's dV by dt, change in volume over time. So the graph intersects the volume axis at L equals 4. That's the initial volume. What? There's no question.
Just to double check, it looks like the overlay in the top right-hand corner might have frozen. Is there a way to refresh it?
Oh yeah, that's a really good point because Bagley really does deserve to be up there. I will refresh it at the end of it. Let me get to the end of this paper. I think we had this problem last year actually, where it doesn't always update.
Works for a while, then gets stuck.
Yeah, it can get a little bit stuck. I don't really know the protocol for how it actually works, because it is just like reading from a Tiltify kind of browser page. Right, so we've got some chess pieces here. Surface area of shape A to shape B is 3 to 4. Volume of shape B is 10. Okay. So if we take 3 and multiply it by the scale factor squared, we get 4, which means R is 2 over root 3, or 2 root 3 over 3. Now the volume of shape B is 10, so 10, so that means the volume of shape A times R cubed is equal to 10. So if we do 10 divided by that cubed, so if I do 2 root 3 divided by 3, that gets R into the calculator, and then if I do 10 divided by that cubed, I get 6.50 to 3 sig figs centimeters cubed. Yeah, there's a bit of janky printing here. It should be double-sided, but I guess something just went wrong there. Seems to be all right from now. Okay, so there are 16 hockey teams in a league. Each team played 2 matches against the other teams. Work out the total number of matches played. Each team played 2 matches against each of the other 2 teams. So if you're a team, you're going to play every team. Is it saying each team played 2 matches? So if you're this team, you're going to play, there's 15 choices for the number of teams, and then you times by 2. So every team is going to play 30 matches. However, it's a symmetric thing that's going on here. So I think it's 30 for each of those, and then divide by 2. That's what my gut is telling me. Or we could do it the grown-up way. This is the number of pairings, and then we times that by 2. Let's do it that way.
Thank you, Havard, for the £20 donation.
Thank you very much, Havard. Really, really appreciate it. Any don't be intimidated by some of the high ones. Literally every level of donation is incredibly helpful. So thank you so much for the donation. Really, really appreciate it. That gives us 240, which is the same as my less adept way of doing it there, but it's good to know that both of those methods are correct. Yeah, Havad, thank you so much. I really do appreciate that. The graph shows the speed of a car in meters per second during the first 20 seconds of the journey. Work out an estimate for the distance of the car traveled in the first 20 seconds. Use 4 strips of equal width. Oh, this is basically trapezium rule light, and we all know how much I hate the trapezium rule. Oh, this is so boring. My fullest apologies to everybody watching, because what an absolutely tedious exercise this is. So we've got they're all 5 in base, and then so we've got a 5 by 22 over 2 for that first triangle. For this, we've got 22 plus 28 times 5 over 2. Then we've got 28 plus 32 times 5 over 2. And then we've got 28 plus 35 times 5 over 2. And then when we add all of these together, we get 5 over 2, lots of all the numbers just added together. So let's just bring all of these over here in that big sum, and then we'll add on this 55 at the end.
I think it might be the 32 plus 35
Yeah.
for the fourth one. Yeah.
Well spotted. Well spotted. I was looking at that number there for some reason, where it's it should be, yeah, that would have ruined the whole calculation. So nice one. We'll do 22 plus 28 plus 28 plus 32 plus 32 plus 35, and then add that 55 on, and we get 497.5 meters. Ugh. Yeah. Disgraceful question. And it hasn't ended yet. In your answer to part A, is it an underestimate or an overestimate? Well, it looks like an underestimate to me, and the reason for that is if we just draw a couple of these, so for those who don't know, what we're basically doing is we're finding the area of these trapezia, or trapezoids as you call them, and if we find the area of all of this stuff here, it's actually a little bit less than the full area beneath the curve. So it is an underestimate. Okay, nth term of a sequence is that. The first term is that. The fourth term is that. Find the sixth term. Right, so this is a quadratic sequence. So that means that 4a minus 2b is equal to... Oh no, sorry, plus is equal to minus 2. I was substituting in minus 2 into that. So the second term, that's when n equals 2, is minus 2. And the fourth term, which tells us that 16a plus 4b, that's equal to 12. So if we solve these simultaneously, so if we double the top one and then subtract, we'll get 16a minus 8a, the b's die, and we get 12. Subtract negative 4 is 16, which means a is 2, which means b is minus 5, I think. That's 8. Minus 2 subtract 8 is minus 10. Divided by 2 is minus 5. So we've got the actual, 2n squared minus 5n, the actual nth term. Now we want to find the sixth term. So that's 72. Subtract 5 sixes, which is 30, so that's 42. All right, happy with that. Here are the first 5 terms of a different quadratic sequence. Find an expression for the nth term of that. Now, funnily enough, we're not getting that many marks here, so I wonder if this is one that we can actually... There's a trick to it. So let's just write the square numbers up here. So 9, 16, 25. Oh yeah, we can see it's actually just n squared subtract n. Yeah, 1 subtract 2 subtract 3. Yeah.
Sorry. 0 squared? Oh, no,
You're starting from n equals 0.
I am indeed.
Yeah, which is that's your programming brain kicking in there. But yeah, I don't know whether it's natural to start from n equals 0 or 1. I'm sure there'll be plenty of people who have opinions about that in the comments. Okay, a big fat trigonometry question. So we want to find the length of AD. Let's call that x. And the goal here, we always want to find the bridging side here. So looks like the sine rule for that y. So if we do y over sine 34 is equal to 12.5, so I'll stick the sine 34 up there, over sine 109, that'll tell us that. So 12.5 sine 34, 4. Sine 109, just pressing all the wrong buttons there. We want 3 significant figures, so we'll give ourselves some breathing room. Let's do 5 significant figures there. And then for x, it looks like the cosine rule. So a squared equals b squared plus c squared minus 2bc cos a. So that is 11.4 squared plus that y squared we just calculated plus 2 of 11.4 y cos 86, and then we're going to root that whole sucker, and we get this. So 11.4 squared plus that squared, subtract 2 of 11.4 times that times the cosine of 86. 13.1. So x equals 13.1. Now, do we believe that that could possibly be the answer? Always good to check, because it can go wrong here, and if you get an answer like, 3 centimeters or 20 centimeters, it's probably not right. This looks good to me, because it should... This is a tight, acute angle, creating a small side. That's a big angle, creating a larger side. The biggest side is always opposite the biggest angle. The smallest side is always opposite the smallest angle. And obviously the middle in the middle, which is a nice fact about triangles, which you can use to check your answers sometimes. Erin,
thank you very much, Joris, for your donation as well.
Joris, yes, thank you very much. We're actually inching towards the target here. I was worried that we weren't going to meet it, but Bagley's actually made up a lot of the difference there. So thank you, everybody. Keep those donations coming. It all goes to an incredibly good cause. Erin, totally agree with your comment there. You shouldn't trust a diagram. That is absolutely true. But I think as a sanity check is what I call it. It's good to just as a little check. So I'm going to do it like this. We want to show that there's a solution between. So a solution to this implies a root of this. So if we put in, well, 1 plus 1 takes 7 is, so this is equal to -5 when x is equal to 1. And the second one I'll do on the calculator, but it is 3, so maybe not. When x is equal to 2, so change in sign implies there exists a root let's say between 1 and 2. Let's phrase it like that. Show that the equation can be rearranged to give that, because if we subtract x, this is a weird question, and then cube root it, we get x is equal to the cube root of 7 minus x. Next question will be iteration, starting with x naught equals 2, and use that iteration formula to find 3 times to estimate a solution. So x naught is equal to 2. We're going to iterate thrice, which will take us down to that. So trick on the calculator, program in 2 as the answer, and then you can do cube root of 7 subtract ans. So that's x1, that's x2, that's x3. So we're estimating, so 1.7388 is an estimate for the solution. And if we take that and cube it and add itself, we should get something very close to 7. 6.99. Pretty close. Jan, thanks very much for joining. Glad you like the posters. Hope they scratch the itch in your graphical brain. I absolutely adore those posters. Those films are just so perfect. Okay. We've got two right-angled triangles here. Tan E is equal to tan F. Find the value of X. Another good question, actually. I'm a fan of this because, again, you've just got to think what questions are you going to set to make sure you've interrogated the entirety of the student's knowledge. This is an algebraic fractions and solve question with a bit of a quadratic is going to emerge from this, I suspect, but with just a little bit of extra, you know, just a little bit extra. So you've got to know that the tan is x over 4x minus 1, which is equal to 6x plus 5 over 12x plus 31. So 12x squared plus 31x is equal to, let's actually just take a bit of time here. So that's 24x squared plus 20x minus 6x minus 5. So when all is said and done, we're going to get 12x squared on that side when we whip that over. 20 subtract 6 subtract 31, I think is something like minus 17, which is horrible, but let me just double check that. Yeah, minus 17x minus 5. Absolutely disgusting. So, might factorize. I can't quite see it. There's a lot of different possibilities for, because 12 is a highly divisible number. So when you break it up into your two brackets, it could be 12x and x, it could be 3x and 4x, it could be 2x and 6x. Let's just use the formula for this one. So, negative b is 17 plus the square root of 17 squared, subtract 4 lots of minus 5 lots of 12, all over 2 of a. So that gives us 5/3. Yeah, so it would have factorized, actually. I should have, yeah, so we're getting 3x minus 5, and then the other one must be 4x plus 1. So the other solution is going to be negative 1/4. There we go. So minus 1/4. However, we reject this one because we can't have negative length. So 5/3 is the answer, or 1.6 recurring if you prefer, which I don't. 20, 50 people if they were asked if they speak French or German and Spanish. Did we get a question on this like 2 papers ago? I'm getting deja vu already. Oh, that was English, Italian, and Spanish, I think. 31 speak French, 2 speak French, German, and Spanish. So there is only one category of data here. So I am actually going to draw a Venn diagram for this one. Let's draw a Venn diagram. And we'll box it off as well for our universal set. So we'll have, I don't know why they use Xi, French, German, Spanish. 31 people speak French, so there's 31 in the French circle. 2 speak all 3. 4 speak French and Spanish but not German. 7 speak German and Spanish. So that means there's 5 there. 8 do not speak any of the languages. That's me out here. Unfortunately, don't speak any of the languages. All 10 people who speak German speak at least one other language. So there's none that speak German and German alone. 5 plus 2 is 7, so the other 3 are out here. 4 plus 2 is 6, plus 3 is 9, and 31 subtract 9 is 22. And how do we know what goes there? Ah, the total. I always forget the total. So we've got 22 plus 3 plus 2 plus 4 plus 5 plus 8 is 44, so 6 people go there. Right, now what's the actual question? Work out the probability that 2 people are chosen at random. Work out the probability that they both speak only Spanish. So, you've got 6 out of 50 choices for your first one, and 5 out of 49 choices for your second one. So, 6 by 5 over 50 by 49. Okay. Something is just a little itch at the back of my mind that says this might not be actually correct. I think this is fine, isn't it? But what what I'm bothered about is have we overcounted the number of options here? Hmm. There are 50 choose two ways of selecting two people, and there are 6 choose two ways of taking two of the Spanish only. 6 choose. Am I overthinking this? Ah, we get the same answer. Yeah, so it's that one divided by that one. Yeah, we get the same. This is fine. This is fine. Yeah, Gabriel, that is a good point. If we're being incredibly pedantic about it, but contextual, I think. Okay, and the final question of the paper. So, ABCD is a parallelogram. Oh, I'm gonna like this question. I like these geometry type things. You know, angle ADP. Yeah, 90 degrees. So, prove that the triangle ADP is congruent to triangle CBQ. Right. So it's this one, and we want to prove that it is congruent. I'll do it in a different color, congruent to this one. Well, we are given that it's a parallelogram, but I don't want to use the fact that it's a parallelogram. I know how to do this. I'm just trying to think of like what's the most elegant way. Um, so, because you can use right angle hypotenuse side, which means all we need to do is show that BC is equal to AD, for example. Or we could do, obviously side is redundant, or side angle, that's showing that these two are equal. I think right angle hypotenuse side is the way to go, because we already know that the right angle is there, that's given. The hypotenuses are equal because it's a parallelogram. So let's do it, yeah, so QC is equal to AP as, wait, oh no, wait, hang on a minute. We're given that ABCD is a parallelogram. We're not given that APCQ is a right. So let me just think about this then. We're probably going to need to use some like angles in parallel lines and all of that kind of stuff. So let's call this yeah, let's call that X. Okay, and then we can use the fact that this here is also X because they are alternate. and then therefore this is x because they are corresponding. So using one pair of parallel lines and then using the other pair of parallel lines. So therefore angle QCB is equal to angle DAP. Trying to use the notation that's like in those triangles. That's fine. And then we know BC is equal to AD, as ABCD is a parallelogram. So it's a given fact that they must be of the same length. And now we just need to show another angle. And we know actually that QBC equals 90, which is equal to ADP as given. Therefore, by side angle side, they are congruent. A little bit trickier than I expected, actually. Okay, now prove that or explain why AQ is parallel to PC. Well, they are parallel if they create the same angle with whatever's going on down here. So let's call this angle Y, and let's call this angle Z. And then we will aim to show that Y is actually equal to Z. So, how are we going to do that? Or I'm wondering, actually, maybe it would be easier to do the other angle. Well, that there is 90 minus x, because it's stuck inside this triangle here, and that angle there is also 90 minus x, and then I think I'm making this way harder than it needs to be. If we extend that out, that is also x, which means that this here is 90 minus x. Which means that x plus that must add up to 180. That doesn't make sense, because that isn't 90, is it?
Thank you very much for the super chat, Marcella Silva. That's very generous. Thank you very much.
Yes, thanks very much, Marcel. Yeah, I really appreciate that. Yeah, don't forget you can super chat in to donate as well. All the proceeds will be going to Mind. So even if you donate on here, I'll make sure that all the funds get transferred over. I'm just having a bit of a brain fart here. I must be like one step away. I'm just not quite seeing it. And unfortunately, I've made a massive mess of this diagram as well. I'm finding it hard to see what's going on. I'm usually an absolute pro at these questions. I'm not seeing it. Because I don't want to introduce any erroneous assumptions. That's 90 at least. We know that. And then by symmetry, that is 90. This is 90 minus x. I think I found every angle in here apart from the actual ones that we care about. That's also 90. I want that. This is 2 marks. What am I not missing? What am I not getting? Um, that's 90. That there must be, so that there must also be x. So I'm slowly working my way around. Sorry guys, I'm not seeing this one. As soon as I see it, I'm really going to be kicking myself. Hmm. Oh, I've got it. So actually, yeah, we never used the fact that these triangles are congruent. So actually, we know BQ. Yeah, okay. Yeah, that's stupid because you nearly always have to use part A as part of part B. So we know that BQ is equal to DQ, DP, sorry, by the congruence of those triangles. And so by side, so by side, angle, side, AB and DC, these two triangles, AQB, is congruent to that triangle out there, DPC. So they are identical, which means AQ is equal in length to PC, and by congruence, the angle, that angle there, in fact, is equal to that angle there, and then by alternating, we can get that angle there. So angle QAB is equal to angle QCP, which is equal to angle, let's call that point over there, what letter haven't we used yet? E. That's equal to angle CPE. So they both have the same angle. God, I really just couldn't spot that one. I'm sure the comments are going crazy with like easier ways of doing that. But I'm moving on from that one because okay, it's the end of the paper. Let's go on. So what did I miss there? Yeah, so
Thank you very much, D Rose, for your donation.
yeah, huge thank you, D Rose. Really, really appreciate it. Thank you. Um, so you don't need to show that AQ and PC are congruent at all. No, I don't. I think I overdid it, but I just couldn't spot another way of doing it. Basically, um, it just it's one of those where like you don't want to accidentally make an erroneous assumption. I think I made a mess of it, but there we go. Those sorts of brain farts are always bound to happen. All right, so what? Oh my God, 2 hours and 20 minutes on those three papers. That is very slow. I'm actually a little bit anxious that I'm really really far behind time here. I thought they were going to take me about half an hour each. So, but we've had interruptions and things like that. So, I'll be back in just about 2 minutes, and then we're going to start our journey through mathematics, starting with like the infant level papers, and we're going to move all the way up through the GCSE, through A level, and then onto the degree level paper. Oh yeah, and Walter, thank you for reminding me. I'll do that when I get back as well.
Oh, and thank you very much to Dirishlet for the £50. Thank you very much.
Directionally, yeah, thank you very much. That's awesome. That's brilliant. Thank you so much. We're really getting them now, actually. So we're pretty close. And in fact, let me reset that top donation there just before I
Yep.
forget to do that, because I think it really does deserve to. Right, the question is, how the hell do you do it? Because Tiltify's UI is not very intuitive, as we discovered when we tested this out the other day.
Solution from behind the scenes to just reset the overlay. I'm not sure how one does that.
Yeah. So let's see. Campaigns, overlays. So doesn't look like it's changing. If I just delete it from OBS,
Hopefully you can find it again.
this is going to delete the four most recent donations, but I think it's worth it. So get rid of that, and then if I just add it back in. Sorry about this. It's a little bit janky actually. It really should update automatically, but I remember having these sorts of issues last time. There we go. Okay, all is well. And while I'm at it, we'll reset the exam counter. This is going to be a key stage 1 paper, so very, very easy. I genuinely find them incredibly fascinating. So it's going to be a pretty trivial paper. But yes, so just to respond to Adam, what we're going to do now, we're going to do some very easy papers. These are intended for age 6 years to 7 years sort of age, and then we're going to do ones that's kind of aimed at 10, aimed at 14, aimed at 16 to 18, and aimed at 16, and then aimed at 18, and then we're going to finish with a degree level paper. So we're going to move up, kind of explore how the mathematics develops over time, and I'm going to enjoy it because I really like the incremental growth of mathematics, the way we educate people, and I find it's always really interesting, like just how many like words we expect a 6-year-old to know. There's a lot of vocabulary questions which are really interesting. But I need the loo, so I'll be back in just a moment.
What's everyone's favourite film from the Cornetto trilogy? has always been my favourite. So many good jokes in there. Shaun of the Dead is superb as well. Yeah, I love that scene with the vinyls.
All right. So, shall we get into this one? So, as I said before, this is a Key Stage 1 paper. So the Key Stage 1, if you're not from the UK, that's what we call like the first stage of education, so like the first 3 years. From what you would call kindergarten, I think, up to like what we call, you have kindergarten year 1, year 2, so just the first 3 years of education. It's going to be very easy, like I said. Um, Johnny, thank you for that, as always. Um, yeah, it's gonna be very easy. But I don't know. I've got a real affinity for these sorts of questions that get asked at this level. Maybe it's just me, but I always I love exams. I love like just the whole idea behind it. So the first couple of questions are actually read out to the students, so we actually can't answer those. Might be the only questions that we are unable to answer in the whole paper. I think I can predict what that question is asking, and it's basically asking which expression matches the situation up here. And already, you know what I mean? How good of a question is that? You know, in the old days, it would be asking how many of them are here, and it'd be up for the student to either work out whether 5 times 3 is the shortcut or whether I'm just going to count them. These days, we really want to drill down on, you know, this is a representation of 5 times 3, and it's testing. Do you know what multiplication really means? So that's why I'm just really into these sorts of questions. This one will be like testing. Do you know the difference between up, down, left, and right? Okay, and now we're on to the written part. So apologies for that, because you do get like read some of the questions at this level. So now I've got a bad track record with this. I remember last year I got one of these put the numbers in order questions incorrect. So let's just make sure we get these right. So 63, 73. He says writing the wrong number, even though saying the right one. 73. Circle the shortest time. So again, do you know, this question is really asking, do you know how many minutes run an hour? Which I don't know. I just love these little clever ways of sneaking in all these like little bits of knowledge. He needs £6 more to buy the game. Again, that's interrogating. Do you know the relationship between subtraction and difference, or are you just counting up from 19 to get to 25? Do you know what an even number is? Always good to know. Um, what an even number is, I guess. Okay, and then a basic sort of bar chart. And again, so these questions, they're actually, if you imagine being 6 years old, you know, how many more children choose orange than apple? It's actually not the easiest sentence to pass. And actually, some GCSE level students still get caught out by this kind of thing, particularly if English is their second language. So there's a bit of a debate at the moment. Are the mathematics papers currently so wordy that if English is your second language, you actually are unfairly kind of biased against, because some of the questions, I mean, as we've seen, they're not this most straightforward to pass, and even if you're really good at maths, if you misinterpret the questions, you can get it totally wrong. So there's a debate about whether that's unfair. So 6 more choose orange than apple. Another boy joins the group. He chooses mango. Add this to the chart. So let's just do that. Okay. Now, big fan of this because it's increasingly common for children not to be able to read an analog clock, even though it is still on the curriculum. There's just many fewer of them in the world. Like it's rarer and rarer to actually find an analog clock, but I do think it's something that's worth preserving. So that's 8:30. Measure the longest line using a ruler. Don't tell me what to do. I'm going to use a set square, 9 centimeters. Write each number once to make these correct. So put in the biggest ones and the smallest ones there. 0 is an interesting one to include there. A lot of kids have a funny intuition about 0. 20 bananas are shared equally among 4 monkeys. And something else that's nice about these papers, I'm sure you agree, Ollie, is there's the number of like cute little pictures of animals that you get.
I love it. I want to be friends with these monkeys.
Yeah, they look pretty cool actually, pretty chill on there, and they get 5 bananas each. Um, and they do as well, don't they, monkeys? I think it's monkeys and like the kind of higher primates. They have a very strong sense of justice. You know,
And
where
fairness,
yeah,
yes.
they do. Like if they might not be able to do the sums, but they know if they've been mistreated, or if they've got one more than another or something like that. Fill in the missing numbers to make each pair total 17. Okay, so 11 and just merely making sure I'm not making a silly mistake, 'cause it's bound to happen at some point. Oh, now in the first year that I did this, I made a massive error on the coins thing, and I've never managed to live it down. I made the mistake of telling my students about it, and they sometimes used to bring it up to me. So what is the largest amount you can make using 3 of the coins? So if you're from outside of the UK, this is what our coins look like. Although these are the old style coins, they look a bit different now. They've got a very pleasing pattern to them now, where if you put them together, they form like a larger picture, which is pretty cool. So we want the 3 biggest coins, which are these, which are 80 pence, excuse me. Ben ate half a pizza. Which fraction shows the amount that he ate? Well, that one. So again, it's either testing, do you know what 2/4 actually means, or do you know that it's equivalent to a half? You can imagine it's a non-trivial question for a 6-year-old. Write 6 different numbers to make these sums correct. Well, I'm going to do this the mathematician's way, which is to do, these sorts of trivial sums like this. We could even do that one, couldn't we? Let's do that one. That's nice. An infinite number of solutions, obviously. You could do something like 28 plus e to the power of I pi. I wonder if any primary school kid has ever written that. Ben and Sita count the cars. Ben counts 38. Sita counts 23. How many cars do they count altogether? 61. Right numbers on this number line. Oh, sorry, they go up by the same amount each time. So 4 steps to go a distance of 20. So 5 each time, 25, 30, 35, 40. AJ, Sam, and Kimi have 4 conkers each. So
Conkers.
12 altogether. Yeah, some cute little conkers there. Yeah. Used to be. I wonder if kids still do that. You know, like collect conkers and smash them together in a very dangerous game. There's probably they probably just have an app
Probably
for that
frowned
now.
upon.
It probably is frowned upon. Yeah. So that's obviously the pentagon, which is 5 sides. Again, I like this question because all too often students are taught the regular pentagon is is the pentagon rather than just knowing the number of sides. So this is what this question is getting at. I've also done this wrong. I should have ticked and not circled the pentagon. Excuse me. Write the missing number to make this number sentence correct. Well, that's 4. And then tick the shade that is exactly 1/3 shaded. Now this is what we call a bar model. And if you so if you've been through education around the same time that I did, you might not have seen many of these bar models, but they're a really big thing now. It's something that they're really trying to push, which I agree that they're useful, but I don't agree with the extent by which they're pushing them. In general, I'm getting on my kind of education horse here, but so in general, it's better to have as many representations of the same thing as possible, up to a limit, I guess. So it's introducing more models is generally better, but they've got an infatuation with bar models, and it all comes from the Singapore. They love them in Singapore, so our kind of philosophy to education at the moment is generally Singapore do these few things, so therefore we should do some of them, and our education will be as good as it is in Singapore. However, the only reason it works in Singapore is because of how cohesive and comprehensive everything works together. So we cherry pick a few things and then wonder why our education doesn't improve. That's my opinion on that. Anyway, yeah, I get quite angry about it actually, because it's there's very clear things that we could be doing differently that we just don't really seem to want to do. Anyway, draw lines to divide the rectangle into quarters. Let's do it like that. Interesting though, because we could have done that. That would have been fine. I wonder if I suppose we could have gone like halfway down there as well. I suppose there's maybe a few different ones as well, but I think that's fine. Ben has 4 boxes of eggs. Now eggs always come up on these papers. I love an egg box question because again it really drills down. Well, not this question in particular actually, but usually you get an egg box question that's usually something to do with teaching people about commutativity without explicitly using the word commutativity. Do you know what I mean? Where how many ways it will say, is 4 times 2 the same as 2 times 4, for example? Making a complete mess of this, sorry, but these sorts of egg box questions is that's usually what they're getting at. In this case, well, I suppose this is what this is saying, kind of. Write a number sentence using, well, it's just 4 times 6 equals 24. I would have liked to have seen a question that said something like, write a number sentence involving times and equals to find the number of eggs in one box, which would be 2 times 3, and then for the whole number of eggs, which would be 4 times 2 times 3. That's the question I would have liked to have seen there. Just to teach.
I'd have liked with the egg boxes open, just to make sure that there's 6 in there.
Yeah. I mean, you never know, do you? You just to make sure. Yeah, it is a That's true actually. He has 4 boxes, and they all say 6 eggs on them. But how do we know that there are actually 6 eggs in there? That's a really good point. Now, this would look delicious. However, it's looking very grey. So that's like the grey goo that's there was a film theory episode about that, wasn't there? I don't know if you watch film theory about the grey goo that appears in Beauty and the Beast during what's the song, the really famous song, Be Our Guest. He holds up a tasty dessert that's got like just a grey mousse on it, and then film theory was actually like, what is this actually though? Why is it just grey goop? And I think there was actually an interesting thing of what it actually could be. Anyway, as unappetizing as this is, there are 55 cakes. 20 boys and 90 girls each take a cake. So we need to subtract 20 and then subtract 19. So if we subtract 40 and add 1, we'll get 16. Let's do it like that. And I'm not going to show my working. Don't tell me what to do. Okay. Now, 2 shapes have more than 8 edges. Tick them. Again, this is quite a sophisticated question. Again, just imagine if you're 6 years old. You know, you've got to mentally visualize what's going on here. Which for some people, I've got to admit, I'm one of these people. For some people, it comes incredibly naturally, and we are very, very lucky if we have it, because not everybody does. For me, I really, really lack intuition in a lot of places, but shapes and spatial kind of stuff is something that is quite natural for me. Now, what is going on here? Because this looks like a triangular prism which has 9, and this has 6. Oh yeah, that one. Sorry, 8. Yeah, sorry. For some reason I had a 10 in my head. Okay, 76 cars in the car park. 18 go in, 35 come out. How many cars are in the car park now? Well, if we add those together, then we get 94. And then if we subtract 35, should we do this the old-fashioned way? Let's do this. I bet I'll get a few comments on the methods that they did in their country, how they learned it. That's the standard one that we teach in the UK at the moment, which replaced the old borrow and pay back kind of technique that our parents probably learnt. The strawberry weighs 24 grams. Now, I can really get behind this question because I am a compulsive weigher. I weigh everything. I don't even make cereal without weighing the amount of cereal and milk that I put in there, because I just like it to be right. Probably an ASD thing. The strawberry and tomato together weigh that. How much does the tomato weigh? Well, what you do there is you put the strawberry on, you press 0, and then you put the tomato on. You don't do that. You also never write the number 69 in a maths exam, because it will make the kids giggle. Even though this is a primary level paper, they probably won't get that reference. This is 45 grams, I think, there. The ratio of milk to cereal that I use is 50 grams of cereal to 125 grams of milk, and that's because the cereal that I get comes in boxes of 400 grams, so that means I get 8 portions of cereal if I use 50 grams, and the milk that I buy comes in litres, so a litre comes in 125 portions, 8 portions of 125, which means it all lines up perfectly and it pleases me. So, that is the end of Key Stage 1. So, actually, I'll be honest, not as interesting as it was in previous years. Always good to look at some of the questions and ask, like, what is actually, what is actually going on? What is that question actually interrogating? But, I was hoping to see more of those sort of interesting questions, particularly like the egg box ones and things like that. Okay, so this isn't pushing anyone to donate, but I noticed that since I've refreshed the overlay, either it's not working or we haven't had any donations while I've been doing that paper. So I actually don't mind if we have or haven't. But yeah, and also to that point, yeah, a gram. I mean, I am assuming that a gram of milk is about a milliliter of milk. So 1 liter is about 1 kilogram. It might not be exactly that. I think. What do you think? Is milk more or less dense than water. Feels like, well, it's soy milk actually, so I actually don't know. It's mostly water anyway, isn't it? Milk. Most liquids are, I think, that you would be cooking with. What am I doing on here? So I need to just update that. So exam number 5, which is the Key Stage 2. Now, again, if you're from outside the UK, this is the um, exam taken at the end of year 6. That's at the end of primary school. If you're from the US, you would be calling that like elementary school. So this is the end of elementary exam. And you're aged 10 to 11 when you take this. And we've got the reasoning paper here. So let's see how much reasoning is actually involved. Oh, thank you. Thanks so much for those donations. Just to confirm that it is actually working. So, thank you for the anonymous £1. That was really good to check that that it is actually working. And thank you very much anyway, because it is all helpful. And Fellowship of the Tables, great name. Thanks very much for your donation as well. Really, really, really appreciate it. Yeah. So for us, Key Stage 2 is year 3 to year 6, which I think in the grade system is 2nd to 5th grade. I think you take our years subtract 1 is the US grade. And Adam is saying finish this exam in 15 minutes and he donates £30. Okay, Adam, you're on. So what is it now? 14:47. So that means I've got until 2 minutes past 3. Let's do it. Some questions have a box like this, show your method, blah, 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 or whatever. Okay, well, I'm going to go through it at a relaxed pace, and then I'll hurry up at the end if I really need to. So, in fact, if you've got a stopwatch, Ollie, could you start it for 15 minutes now? That would be really, really helpful, just so that, because the clock is a little bit inaccurate. There's uncertainty because the precision is only 1 minute. Okay, so, William asks the children in year 2, yes. Altogether, how many children don't walk to school? So that's 110 plus 90 is 200. How many more year 6 children than year 2 children walk to school? So how many more? It's from 70 to 120. That's 50. Again, with that, how many more? They love to ask that question. Sorry, I've just got my... I like to have my draw pile and my discard pile because I've got a very inky pen, so I don't like to rest the papers on top of each other because otherwise it bleeds. So, circle the number that is 10 times greater than 907. So that one. And it is circled, not tick this time, which is good. So, yeah, again, can you interpret in figures a number that is written in words? That's what that question is getting at. Write the numbers in here. So this is another kind of Sudoku style exercise. So I think that, and check that that is right. Yep, all good here.
Thank you, Nathan and Anonymous, for the £20 each.
Yes, absolutely. Thank you, whoever you are, Mr. Anonymous. I wonder if it is actually like, you know, the hacker group Anonymous. They're just really into this this challenge with the Guy Fawkes masks sending so many donations. I don't think it is. No, thank you to whoever you are, and thank you so much, Nathan. Really, really appreciate it. Okay, how much higher is Mount Everest than the combined height of the other two mountains? So I can't add 4 digits together in my head reliably, so let's add these. Ben Nevis being the tallest mountain in the UK. Is it UK, Ollie, or is it just England? I think it's both. Oh no, it's in Scotland. Is it in Scotland?
Yeah, it is. It is Scotland. Yeah.
I don't actually know what the tallest mountain in England is, and it's very generous to call it a mountain. So 1609. That's ridiculous, isn't it? You put Ben Nevis and Kilimanjaro on top of each other, and they're still 1.6 kilometers lower than Everest. It's a big boy. Okay, so take the number and add 1000, and do it in reverse. So 14 to 50. So good place value question. So write these exams in numbers in order of size. So it looks like 0.328. Again, these are the kind of questions that I historically have made errors on because I usually just bluster my way into them and totally make a hash of it. 60 months is 5 years, 72 hours is 3 days, 84 days is 7 weeks? No, 12 weeks. 12 times 7. So again, basic times table arithmetic with real world context because we do want kids to know how many somethings are in a something. At the start of June, there were that number of toy cars in the shop. During June, that many were delivered, that many were sold. Well, this is disappointing. This is basically just a repeat of the mountains question. So we need to do 1793 plus 8728. So that's 11, that's 12, that's 15, that's 10. And then we need to do that subtract this. I was obsessed with toy cars as a child, actually. I used to have a massive collection of them. I used to rank them all in terms of which ones were my favorite, because obviously I did that. And then let's do it like that. So 1,048 cars. Tick two shapes that have 3/4 shaded. Looks like that one, and it looks like that one, because if you put the empty ones up in that corner, that's 3/4. Yeah, again, good to have those kind of representations in mind. Okay, round to the nearest 8, 4, 5, 20. To the nearest 100 is 8, 4, 5, 100. To the nearest 1,000 is 85,000. Okay, here is a rule for the time it takes to cook a chicken. Cooking time is 20 minutes plus an extra 40 minutes per kilogram. I don't think I've ever roasted a chicken. Well, I have, but it's always been with like other people because I live on my own, so there's no point roasting like an entire chicken. Although I could probably eat a whole chicken. But yeah, this is actually a nice practical life skill, isn't it, here for all the 11-year-olds that are roasting chickens. So 20 minutes plus 3 of 40 minutes is what this one is. So 140 minutes. Yeah, that makes sense, doesn't it? 2 hours and 20 minutes. What is the mass of a chicken that takes 100 minutes to cook? Well, it must be 2 because it's 40 minutes shorter than the previous one. You ever roasted a chicken, Ollie? I bet you have.
Yeah, I think uni was probably the last time that I actually roasted a chicken.
Yeah, you roasted chickens at uni.
A whole chicken. I did
Full chicken.
A lemon chicken. Had to stuff the lemon.
Yeah, that's what we do. So yeah, when I go on holiday with my friends, we're cooking for about 20 people. So roasting whole chickens is like the easiest way to get like a massive amount of chicken. And yeah, we use the lemon technique as well. Have you ever spatchcocked a chicken? I've always wanted to try that. Apparently, it comes out really, really well.
I can't say that I have. I might need to check what spatchcocking is.
You turn it upside down and you slice out the spine, and then you can lay it flat. And apparently, it cooks like a lot more evenly, and you don't have to cook it quite as long, which means it's still quite tender. Because obviously chicken, if it gets to a certain temperature, it really dries out. Okay, so this is a really fascinating question because, again, imagine you're 10 years old. You've got to have the spatial reasoning to kind of visualize what's going on here, and also you need to know what a face is. You need to know what a vertex is. So 1, 2, 3, 4, 5. This one I think is true. This one I've got bad vibes about because it's usually an odd number of yeah. And then the tetrahedron 1, 2, 3, 4. 1, 2, 3, 4. Yes, that is true, isn't it? Because you get a D4 that has sometimes it has the faces are the numbers, but sometimes, which is my favorite, the corners are the numbers. You know what I mean? Have you seen those?
Yeah.
Where because if it's the faces, you have to roll it and say which is face down is the number, whereas if it's the actual vertex that's pointing up, I think that's a cooler way of doing it. Okay, Ali and Jack buy some stickers. A pack of 12 stickers costs that much. These are 12 stickers costing that much. How much more? So Jack is paying for these ones. Okay, so we need to do 12 times 99, which is 1200 subtract 12, which is just 1188, isn't it? So he pays an extra £1. And then what's the difference between 49 and 88? 29, 39, 39. So £1.39 more. So you should have bulk bought those stickers, Jack. Okay, Amina, or sometimes Amina. I've had students who like to pronounce it in different ways, actually. Planted some seeds. For every 3 seeds that Amina planted, only 2 seeds grew. Altogether, 2 seeds grew. So she must have planted 18. Yeah, that's right. So that is ratio without introducing the notation. That's what that question is. And at the end of a film, oh, I love this. Anyone who doesn't know, I'm a massive fan of film. The production number is often given in Roman numerals, which is obviously 2006 in this case. Again, it's a bit of a lost skill, Roman numerals, a bit like analog clock. Fewer and fewer kids are coming through knowing what Roman numerals are. So Layla completes 1.5 somersaults in a dive. How many degrees does Layla turn through a dive? So she goes 360 plus 180, so 540. That's a great question, isn't it? That is good. Angles are one of the most misunderstood concepts from primary school, I find. How much longer have I got, Ollie, on this 15 minutes, by the way? I'm quite conscious of that.
Just under 5 minutes.
Just under 5 minutes. Okay, so 1, 5, 5, 4, 1, -3, and -3, 4. So, like this. It doesn't say use a ruler there, just ignore that. So it looks like a kite, actually. A cat sleeps for 12 hours a day, and look at how cute that cat is. 50% of its life is spent asleep, just like you, Ollie. So a koala sleeps for 18. Oh, we've got a cute koala as well. Sleeps for 18 hours a day. Man. 75% of its life is spent asleep. Adorable. I love how they have those animals on there. Amina. Oh, here's Amina again. She posts 3 large letters. The postage costs the same for each letter. She pays with a £20 note. Her change is that. So it must have cost £5 and 4 pence. So if we divide that by 3, let's use the old bus stop method. So that's 6 and 8, 168. £1.68 for each letter. 0.5 is smaller than 2/5. Yes, as 0.25 is less than 0.4, which is 2/5. Let's explain it that way. Good work, Adam. Okay, getting towards the end here. Make sure I don't hit that 15-minute thing. 1 centimeter represents 20 kilometers. Okay, so that's 12.5 centimeters we would need for that, wouldn't it? Yeah? Divide that by 2, you get 12. Yeah. Yep. Here are 2 similar right-angled triangles. So again, similarity. And we are introducing the notation here. So this is 2, 1, 2, 3, 4, 5, 6, 7, 8. So it's in the ratio 1 to 4 in simplified form. Okay, last question. So in this circle, a quarter and 1/6 are shaded. What fraction is not shaded? Okay, well, we've got 6 plus 4 over 24 is equal to 10 over 24. So therefore, 14 out of 24, which is 7 over 12, not shaded. 7/12. And that's the end of the paper. because
You got it.
we have yeah, blank page, which as soon as they uh, as soon as you write blank page on it, it's no longer blank, which is a bit of a paradox, but there we go. All right, so I'll be honest, I'm
Hang on. You might have got that last one incorrect.
Oh, really? It's because I was rushing. So a quarter plus 1/6. That's definitely 6 plus 4 over 24. Quarter and a sixth are shaded. What fraction of the whole circle is not shaded?
Oh, okay. Yeah, sorry.
No, that's okay. Good
Yeah, it's good.
good to keep me honest. I think that's fine. So again, that is it's mixing a bit of representation, a bit of fraction work there. So there we go. Yeah, I'll be honest. Not as interesting as in previous years. I usually like to really dig in to the real, what is the question getting at? What are we trying to tease out of students by asking these sorts of questions? But I wasn't like I wasn't particularly fascinated by any of that. Um, I think they say blank page just to clarify that there wasn't like a misprint or like a question on there that wasn't printed and therefore is unfair on the student because they didn't get to see the question. If they accidentally didn't print the question, which I suppose doesn't really make sense because if they had made that kind of mistake, it wouldn't print the blank page either. But I think it's just to try and cover those sorts of things. Right, so we're going on to the Key Stage 3 now. Now, this is the paper that's actually not sat anymore. So this is old school. This is all the way back from 2009. I picked this one because I just randomly chose a year that I hadn't done. So not a paper that we do anymore, but and I kind of lament that because I think there's often some really interesting questions in here. So this is usually like 13, 14 when you would have sat this paper. So what do we expect to see on here? I think we will see the beginnings of some trigonometry. We will see a lot of algebra because we haven't really seen any algebra, even though the modern Key Stage 2, much to the chagrin of us high school teachers, they have started to introduce algebra in year 6, and this is something that we actually don't like. We actually prefer it when kids have never seen algebra before, so then we can teach it them from scratch. Because primary, it's so basic that they often they learn shortcuts which don't generalize, and it can be a real problem to kind of unpick. And that's not kind of disparaging against primary school teachers. They've got an incredibly challenging job, especially with the pressure of Key Stage 2 SATs and things like that. So I'm not trying to blame Key Stage 2. In fact, I'm kind of trying to support you in saying it shouldn't be the expectation that you teach that. I think you should teach less, but teach it better. Really, if a kid comes through into high school, what I really want is for them to understand place value and not really much else. And in 5 years, you can teach them, the whole everything that they need to know to GCSE. Maybe a little bit of fractions basics, as long as they know place value. So that's ordering of numbers and decimals, and some basic conversions between decimals and fractions, maybe. So yeah, that's my spiel on that. I also noticed I had a comment from Tash, and yeah, it's absolutely amazing to hear from you. Actually, I'm really glad that you messaged because so Tash worked at the school that I worked at about a year ago now when I left that school. And I kind of regret not keeping in touch with many of my former colleagues there, because it was a really great department that I used to work with. I used to love all of my colleagues in that place. We used to get along really well. So thanks very much for commenting there. I really appreciate that.
And thank you very much, Adam, for the £30.
Oh yes. Well, we had a deal, and thank you for honouring it. That's brilliant. And £30, really great donation as well. Thank you so much. Really appreciate that. So, Key Stage 3. Let's get into it. Let's get into this one. So that's yeah. So what else are we going to see on here? Do we think a little bit more advanced ratio, more trig, more algebra, and yeah, we'll be going for about 3 hours so far. So I'm getting ahead, but I've not really done any of the properly challenging papers yet. So I'm trying to bank some time. We are given some formulae here, and it is non-calculator still, and we don't need that because we know how to find the area of a trapezium. Right, so match each instruction on the left with an instruction on the right that has the same effect. Now, you see what I mean? How good are these questions? You know, I enjoy these sorts of things because it's really drilling down on what does it mean to add a negative. So the traditional question would be this. It would be what is the answer to that, and you would be expected to know that adding -5 is the same as subtracting 5. This question is much more general, and that's why to me it's more interesting. So adding 2 is the same as subtracting -2. Subtracting 2 is the same as adding -2. So there we go. Oh no! Again, I've not got things set up in the right order here. There's my draw pile. Oh, it's even given us the kind of the topic area. That's interesting. I've never really noticed that before. Matching. And oh, it's not the topic. It's just I think it's just the name of the question. That probably helps with the QLA that happens afterwards. Pupils are investigating oak leaves. They want to collect a sample of oak leaves. Here is the plan. Choose one oak tree. Take 10 leaves from the lowest branches of the tree. Give 2 reasons why this sample of leaves may not be representative of all oak leaves. So lower branches may be different to higher branches. What would you expect? Would you expect that higher branches have larger leaves because they're more likely to collect more light? Or would it be that lower branches need larger leaves because they are in dim light and therefore need to maximize their area? I actually don't know, but it is interesting. I reckon there is a difference. Second reason, if I was a tree, I'd make my top branches big leaves. Really capitalize on the fact that you're right in the sunlight there. That's what I would do. Okay, so second reason, one tree may not generalize to all trees because you might have picked an especially lush tree or an especially rubbish one. Look at the rectangle. Yeah, all right. Don't panic. Something really funny about that. I don't know. So the total area of the rectangle is 40. Work out the lengths of x and y. So that means 4x is 40. Therefore x is 4. Therefore y is 2.1. Easy peasy. So this is the kind of question that would come up on GCSE, but I reckon the GCSE version of this question would be something like find out the perimeter of the triangle. So it's just that little extra step that they would make you do. Bags A and B contain some counters. The number of counters in each bag is the same. So that means 2y equals 6, which means y equals 3. Bag C contains more counters than bag D. What is the smallest value of k? So that means 3k is greater than 12. K is greater than 4. So that means 5 is the smallest number that k could possibly be, because if it's strictly greater and k is in, presumably we've got an integer number of counters in here. All right. Gary took part in a quiz show and won £1 million. He spent 20 grand on a holiday. He then spent half the money left on a house. Okay, so if you do 1 million subtract 20,000, what does that give us? That gives us 980,000 left, and therefore 49,000 is the cost of his. No, sorry, 490,000 is the cost of the house. pretty expensive house. Although this day and age, 490,000 would probably buy you like, you know, a two-bedroom flat or something. Look at these two scatter graphs. They're both drawn using the same scale. Which scatter graph shows a positive correlation? Explain your answer. As one variable increases, so does the other. Which scatter graph shows a stronger correlation? That's A. How would you say this? Tighter distance to a line of best fit, if we were to draw a line of best fit, or if we say more consistent or something like that. I don't know. James probably knows the perfect way to phrase that question there, to phrase that answer.
You might want to check question 3 again.
Oh, really? Total area. 6.1 plus. Sorry, x is 10. So, yeah, that's bad, isn't it? Yeah, just completely blustered into that. So, what is y? We need to complement that, so it'll be 3.9. Yeah, well spotted. The problem was, I forgot to look at the rectangle. That's school by error there. Thank you to whoever pointed that out. So, some interesting shapes here. What is going on there? Rules connect N, B, H, and A. Right, so H is equal to N plus 1. A is equal to H times 2. And 2N plus 2, I think must be A again. Yeah. That's an interesting question, isn't it?
Yeah.
It's like one of those sort of IQ questions, but a little bit of generalization there. So I like these sorts of things. Just like it's kind of formalizing pattern recognition. Look at this information, and I'm not going to ignore the instructions this time. I'm going to look at that information. I'm looking at it. Got it. Use this information to write the missing decimals below. Ooh, interesting. Oh, see, this is why I like this sort of stuff. This is such a good question. So basically, we want to find the difference between these, which looks like it's going to be 0.5, because that gives us sorry, 0.05, because that gives us 2/40ths, because we want to add that on to 29/40ths to create 31/40ths. This is the kind of question that I really lament the fact that we don't do these papers anymore, because I think these are just wonderful questions.
Yeah.
So 0.1 is 4/40ths, which if we deduct from 27/40ths, that's 0.575. Don't tell me I've made another mistake.
Maybe. I think your 31/40 might be.
Oh no, not again. Oh yeah, yeah. That's funny. 'Cause in my head, I did genuinely think 7.5. I don't know why I put that.
You'd already written a 7. Probably put time to put the 5.
That's how maths works, isn't it? Whatever. Yeah, if you've already written 1.7. No, I mean, it probably is what went through my brain. In this question, n stands for any whole number. 2n must be even. Explain your answer. Well, what do you want me to say? That's literally what an even number is. It's multiple of 2. Therefore, even. For the expression 3n, 3n could be odd or even, e.g. 3 of 1 or 3 of 2 is 3 is 6, which is even, which is odd? Good question again. Good question again. Okay, this necklace, the ratio of black beads to white beads is 1 to 3. How many more black beads do you need to add to make the ratio of black to white 3 to 1? Awesome. So, it's going to be, we want that because we want to fix the number of white beads, which means we want 3 there, which means 9, which means we need to increase it from 1 to 9, which means 8. Here is the necklace again. Thank you. How many more black beads and white beads do you need to add to make the ratio of black to white 3 to 2? Well, another way of saying 3 to 2 is 6 to 9. Sorry, 9 to 6, I should say. And another way of saying the original ratio is that. So if I add how many more black beads? So we need to basically add 3 white, because that'll give us 6 white beads and 6 black. So 6 black and 3 white. Is that right?
Is it not 8?
Sorry. From 1 to from 1 to 9 is 8. Yeah, that's right. And then so these are all black. So if we've added we've added 8 there, then it's 9 to 6, which is 3 to 2. Yeah, that was a good question actually. For 1 mark, you got to think about that a little bit there. So show the difference between those. Well, 27, which is that, subtract 9, which is that, is 18. Done. Sophie. Hello, Sophie. If n represents a prime number, then 2n plus 1 will also represent... Ooh, I don't think so, Sophie. Use an example to explain why she is wrong. Well, I bet we have got to go up a few... Let's try 7. 2 of 7 plus 1. That is prime. However, that is 15, which is 3.5, which is composite. So, sorry, Sophie. If only it was that easy. We'd be generating primes all over the place. A game has 6 rounds. In each round of the game, the player gains points which are added to their total score. So a bit of cumulative frequency here. How many points did Sue gain on round 4? So she went from 45 all the way up to... this is a bit... 56. So 11. That's the difference between those. Yeah, 11. Derek plays the game. I wonder if it's Derek from Veritasium. The graph of his total score after each round is a straight line. What can you say about the number of points gained in each round? Same each round. Again, another really good question. It's like asking, you know, do you understand what a linear relationship is? You know, that's why the good questions. Instead of like asking you directly, it's getting at something which is not quite straightforward. Yeah. So the second necklace problem, I think you're right. There are an infinite number of solutions. How many more black beads and white beads do you need to add? So I think any example of a correct answer would be sufficient there. But I think most people would choose the minimum number of each type of bead that they would need to add. But yeah, I think you are right. There'll be an infinite number of solutions for that one. So inside the rectangle below is a shaded rhombus. Exciting. The vertices of the rhombus are the midpoints. What is the area of the shaded rhombus? Okay. So these are all 3x4 triangles, which means they've got an area of 6. This whole square has an area of 6 by 8, which is 48. So we need to subtract 4 lots of 6. So that's 24, 48, subtract 24, as I thought, is the answer. And interestingly, that's half of the total area, because I was just thinking to myself as I was writing that down, if you think about this like that, then in each quarter, you've shaded half of the space. So in total, you've got half of the the total area. So it's a nice kind of intuitive way of thinking about why it is indeed half. Did Veritasium exist in 2009? That's a very good question. I reckon he did, actually, because he's one of the old guard of the education YouTubers. Obviously, he's transitioned from his original format. That made me laugh, actually. I think Derek existed in 2009, but yeah. Well, Veritasium, I think he made quite a lot of videos before he got popular. Apparently, he did his PhD in making videos to communicate science effectively. That's why he used his original format of those kind of interviews and questioning before revealing the answer. Sad to see that he's kind of moved away from that, and he just makes. I don't know. I don't want to disparage him, because I'm actually still quite a huge fan of him, but I think lost some of the unique aspects of that he had in his channel. Oh, so it started in 2011. That's interesting, actually, because I was at university at that time, and I thought he already existed by the time that I found him. I think I found him pretty early. I think we found those number file and all the old school ones. Anyway,
Thank you very much, Philip and Gavin Marr, for your donations as well.
absolutely amazing. Thanks very much for highlighting that, Ollie, as always. Yeah, thank you, Philip. Thank you, Gavin. Really, really appreciate it. We're really inching close to that goal. I'd love to reach the goal and exceed it. That would be awesome. So I'm getting more comments about that bead question. Could we have added 1 white and 5 black? You know what? Yes, we could have done. Yeah. How did I miss that?
I think you did write down 6 and 4.
Yeah, yeah. No, well, no, I didn't. 'Cause it's 6 to 4. Yeah. So I didn't go for the minimum. If I went for a kind of a janky answer there, but it doesn't matter. As we've said, um, there's an infinite number of solutions. So Sandra, she's thinking of two numbers. Her two numbers have a negative sum, but a positive product. So if we have like -1 and -1, they're going to add to create something negative, but they're going to multiply to make positive. Now, Mark is also thinking of two numbers. His two numbers have a positive sum, but a negative product. So we need to have where something like that, I think. They have to be different signs, but with more positive than negative. This is kind of, we know what's going on here, don't we? We're kind of training students to factorize quadratics based on, because this is the kind of thing that goes on in your head while you're trying to factorize a quadratic. So the mean of 5 numbers is 10. If I add one more number, the mean is now 11. Now this is a type of question that they still love to ask on the GCSE, actually. So that means the total of the 5 is 50. I add one more number, the mean is now 11. So that means the total of the 6 is 55. So that means you must have added a 5. You've pulled the mean. $66.16. Yeah, the reason I knew that was wrong is because the number that you add has to be greater than the old mean, because you've pulled the mean up. So it had to have been greater. So that didn't make sense. That's why you always want to ask yourself, does my answer make sense? And in that case, it really didn't. Okay, so x is 5, and oh, well, let me just check that, because that doesn't give a nice answer for y. I mean, I guess, because what I'm doing is I'm subtracting, which means 2x is equal to 10, so x is 5. That means that 6y is 15, so y is 15 over 6, which is Divide by 3, 5 over 2. Is that right? 3 fives plus 6 of 5 over 2. Let's just check that. So cancel 3, so 15, but yeah, that's right. 5 over 2. Yeah, you don't always get a integer answer, but so it's just good to check. This shape is made of 4 congruent rectangles. Oh, I'm going to like this question. I like these sorts of things. Okay. So because they're congruent, this length here, that total length is 2a, that length is a, so this must be a. And so every rectangle contributes 4a. There's 4 of them, and that is 80. So that means a is 5. Oh, and then we want the area. So it's 5 by 10, which is 50, times 4 is 200. Good question. I like it. Ooh, wow. I think I'm going to like this question as well. What on earth is going on here? The diagram shows 3 congruent circles drawn on an isometric grid. So the area of this equilateral triangle is y. The area of this segment is w. Using the expressions y and w for area A and area B. Oh, so I love this. So y plus 3w, because we need all 3 of those segments there. And then b is going to be, it's going to,
Uh,
hmm. I think I've got it. If we draw another triangle in there, then we've got 2w that make up these parts, and then that little triangle with a bite taken out of it is y subtract w. So it's just w plus y, which is interesting. Yeah, so it's basically saying that that kind of ice cream cone has the same area. This also has area B, w plus y. Good question. Good question. I really had to think about that. That really caught me off guard. It was the fact that it's drawn on an isometric grid. Why are we giving it on an isometric grid? You always, if you get stuck on a question, always use or look back at the question and see what information that you haven't used. Well, this is what do we used to call this, Ollie? It's like the freshman's theorem, the freshman's dream, where it's like you can't just drop the power inside, unless you're in a field of characteristic 2, of course, which we might see later on that degree level paper, I don't know. But this is just j squared plus 2jk plus k squared. My upcoming video has a lot of field of characteristic 2 involved, actually. That's a little tease for you there. For all numbers j and k, this can never be equal. Nope, because if it's 0, then both are 0. Always 0. I have 2 fair 4-sided dice. So 2 d4s, and the numbers of that. I'm going to roll both dice and multiply the scores. What is the probability that the product is a multiple of 3? Right. So, how many ways can we get a multiple of 3? Well, we can do 3. So 3, 3, 3, 4, 3, 5, 3, 6. And then the same. So there's only one situation in which you can do that. There's 2 situations in which you can do that. And then 3, 6, 4, 6, 5. Again, 2 of those. I'm not doing 6, 3 because I've already counted it there. And 6, 6, of which there is 1. So there's 8 possible ways to get a multiple of 3. There's 2 choices.
Thank you very much to the Lucky Spades for your donation.
The Lucky Spades, thank you very much. That's great. One of my patrons there. Thanks very much. There's something fishy about. I don't like 8 there. I'm having a bad. Yeah, there's 2 choices for your first one. Oh yeah, sorry. There's 3 times 2, 2 times 2. So that's 6 options, 4 options, 1 option, 1 option. Yeah. I thought there was something fishy about that. Because if you do it, looking at this, you've basically got, you've got to either have 3, 3, 3 or 6, and then times anything, but then you double and divide by, yeah, well, I think this is right. So anyway, there's 12 possible ways of doing it, and then each of them have probability a quarter times a quarter times 12. So that's 3/4. I wonder if there was a better way of doing this. I'm just thinking, because how do you not get a multiple of the only ways of not getting a multiple of 3 is if you get these. They're the only 4 options. So I think it actually would have been easier to do that. And they are a quarter times a quarter, 4 of them, which equals a quarter, and then 1 minus that gives the 3/4. So that's another way of doing it. I think that's where actually is the more sensible way, because it's easier to visualize how you fail to get a multiple of 3. But anyway, that's fine. So we've got 15y minus 20 is equal to 14y. Therefore, y is equal to 20. And then here we have got, so this is x squared subtract 16 is equal to 9. Therefore, plus 5 and minus 5. Because you're going to whip that 9 over to create minus 5, difference of 2 squares. And there we have it. So that's fine. Why am I not liking this? Maybe I'll just take a second here. X squared. No, this is fine. This is fine. Yeah. Sometimes there's a little alarm that goes off in my head, but I think it's being a little bit too sensitive at the moment because it's just being wrong because I keep second guessing a lot of the things I'm getting right and completely missing the things that I'm getting wrong. Okay.
Thank you very much for the donation, HRH Ollie.
HRH Ollie, that's not you, is it?
Nope.
Just thanking yourself there, that would be. Yeah, thank you very much, Ollie. That's really, really appreciated. Thank you so much. So, cumulative frequency graph. Well, this is really old school. We don't have anything like this anymore. 9. Oh wait, yeah we do. It's just we don't usually read it from a bar chart. or well, a frequency diagram, I should say. It's not really a common thing that we've got anymore. So 9 plus 8 is 17, isn't it? So it goes up to there. And then we add on, so we're on 17, and we need to add 6, which takes us to 23. And then we add 3, which takes us to 26. And then we add that one guy at the end to take us to 27. So something that looks like that. It's usually a bit of an S-curve, isn't it? Cumulative frequency. Estimate the median distance. Yep, so 27 in total. Half that is 13.5. So if we find 12, 13.5, I should really use a ruler for this. So that line there, which my pen has failed to draw because it doesn't like going up against the ruler. And then what do we think that is? 1.35? It's an estimate. Who cares? Look at the graph. I am looking at the graph. Okay, I've looked. So, the points AB. Yeah. Right. So. Well, that must be -2 there, mustn't it? So A has coordinates -2. Sorry, 0, -2. But I think we do need to solve this. So x squared minus 2 is equal to x minus 2. So therefore x squared subtract x is equal to 0. So x minus 1 is equal to 0. So 1 minus 1. Yeah, definitely not drawn accurately because that isn't halfway up there, but that's fine. 1. Yep. And then, yep, fine. Okay, getting towards the end of this paper now. So, in the diagram, triangle BCD is mathematically similar to triangle ACE. Again, this could be a GCSE question, except it would be, they wouldn't tell you that it was similar. They would expect you to infer that because these are parallel, that these are in fact similar triangles. So that's like, this is sort of the middle sort of difficulty, because we saw similar triangles in the Key Stage 2 paper. Here we're given mathematically similar triangles in an arrangement that they are in fact similar, and you can do that. You can easily show that by showing that they all have the same angles. But here we're explicitly told, which I think just lightens the question a bit. It just makes it just that little bit easier. Right, so we want the length of BD anyway. So we know that 4 times the scale factor equals 10, so that is 5 halves. So if we do 7 halves divided by the scale factor, that will yield the length of BD. So this is 15 halves multiplied by, that's 3. So 3 is the answer. All right, good. Oh, and what on earth is going on here? So look at the graph. I'm looking at it. The x-axis, the y-axis, and those lines divide the graph into 8 regions. Write down the letters of the 4 regions where x is greater than or equal to 0. Oh, I love this. A, B, G, H. So it's on that side of the x-axis. Write down the letters of the 4 regions where y is greater than x. sorry, y equals x is there, and make it bigger, b, c, d, e. Write down the four letters where x, y is greater than or equal to 0. That's, again, such a good question. So how do you times to make a number that's positive, or at least non-negative? You have to do two positives, or you have to do two negatives, or both 0 for the 0 case. Great question. Absolutely love that. Okay, is this the last question? Yes. So, last question. A cyclist went 1 kilometers up a hill at 15 kilometers per hour, then went down 1 kilometer down the hill at 30 kilometers per hour. Show that her average speed for the 2 kilometer was 20 kilometers per hour. Well, actually, obviously this isn't the way that you would do it, but there's a really, really interesting property of speeds where if you take the harmonic mean, then you get the average speed. So let's try out this method here. So harmonic mean is basically the reciprocal of the sum of the reciprocals multiplied by the number of data points. So if we do the reciprocal of 15 plus the reciprocal of 30, reciprocal of times 2, this should give us the answer. So obviously you would never actually do it in this way, but I think it's interesting. So 2 over 15, another word for that is just 2 over 30. So 2 over 30 plus 3 over 30 is 3 over 30. 3 over 30, the reciprocal of that is 30 over 30. 30 over 3 times 2 is 2 times 10, which is 20, which is the answer that we expected. So that is obviously not the intended way. The intended way obviously is to basically you would use speed, distance, and time. So because speed equals distance over time, you know that time. I'll do it the proper way here. So distance over the speed is that, and then here the distance over the speed is that. You can see the relationship that's going to basically happen here. Then we add the total time spent is then 3 over 30, which is like 0.1. And then the average speed is the total distance divided by the total time, which is 20. So, I mean, and you can very much see where the connection between this and this. But it's like just really cool. I think that you can do it using the harmonic mean. I picked that up probably about 6 years ago, but don't really have that much opportunity to do it. It's not even easier. I just find it interesting. It would be great to to see a student in year 9, so like a 13-year-old kid busting out the harmonic mean. I don't think that's ever happened.
Styling.
Probably some
styling on the question.
Say it again, sorry.
Styling on the question.
Yeah, exactly. Yeah. An extra few marks for style there, absolutely. Okay, so I'll tell you what we'll do. We'll do one more paper, and then I'm going to take a quick break to just eat something. So we'll push through this GCSE paper, so similar to the ones that we started with. And after this, we're really getting into the more challenging stuff. So what's the difference between Key Stage 3 and GCSE? I think we're going to see more complicated algebra. We're going to be solving more quadratics and things like that. We're going to be doing more weird ratio-y sorts of things. We might see the sine rule and the cosine rule. GCSE is Key Stage 4, yes. So we're currently in the middle in the UK, actually, of kind of breaking down the key stage sort of barriers. So a lot of schools, like one of the previous schools that I worked at, they don't really have a difference between Key Stage 3 and Key Stage 4, particularly in maths, because there's no real separation between Key Stage 3 content and GCSE content anymore. You just basically have 5 years to teach the whole course. And mathematics is so, like, cumulative that the stuff that you learn along the way, it all gets used and is examinable. So there's no, like, obvious difference between where the GCSE content stops and starts. So I think the approach of, like, just condensing everything into, a 5-year course is more appropriate. So we're going to see all these sorts of bits and pieces. What else might we see at this level, Ollie? What do you think we've not seen yet?
Let's see. Oh, and by the way, Dan has just joined us.
Oh right, we've got
Hello, everybody.
Dan. So yeah, Dan, another friend from university. Again, I think I met you basically at the same time, and did my usual strategy of if I associate myself and be in the same presence of these two people for long enough, they'll start to call me their friend. Um,
Yeah,
so
we're getting there.
yeah, we're getting we're getting there. Yeah, it's only been
13 years.
it's been 13 years. All right. Okay. So, do you want to just quickly introduce yourself, Dan?
Yeah, so I also like maths, but I don't like Gilbert and Sullivan. For those people that, well, I'm not as into it as the other commentator Oliver is.
Yeah, I think I'm just going to adjust your volume. I'm going to be tweaking the volume a little bit as we go. I think that might be a little bit better. I think it's difficult to be as into Gilbert and Sullivan as Ollie is, isn't it? But there we go. Right, so we've got a SUVAC question, and actually just on yeah. So obviously we'll get to the degree level paper soon, but I think we're all algebraists. Would we describe ourselves as algebraists? We all basically did the same courses in year 3 and year 4 with slight variations. You ended up doing some rubbish, Dan. Some like what did you do? Like mathematical finance or something? Did you end up doing that?
Yeah, I did some finance stuff. Like, I would have been really helpful when you were struggling with those profitability questions.
Actually, we probably would have been. I'm calling it rubbish, but actually, yeah, I think I probably would have found that very useful.
Thank you very much to the Villas for the £20.
The Villas, thank you very much. Yeah, two of my friends from home there, that I've known. Well, I've known longer than you two, and I have been friends with them a little bit longer. But I've got a checkered history with Villas. We actually didn't like each other in school, but then we came thick as thieves. As I'm sure he'll love my use of that phrase. We enjoy those sorts of phrases. The real question is, where is my calculator? In fact, no. The real question is, can I use a calculator? No, I can't. So who cares where my calculator is? I can't. I can't use a calculator anyway, wherever it is. And how could I possibly have lost my calculator? It must have been right here a second ago. Anyway, we've got a SUVAT question here. So the expectation at this level is we can apply the SUVAT equations. You don't really need to know what they are. You don't need to know that this is actually about velocities and displacements and things. But there we go. So I need to actually do this the old-fashioned way. What is 2 times 3 times 18? I think it's 108. So 144 subtract 108 is, well, 36. So then therefore v equals 6. And then make s the subject of that. Well, if I do v squared subtract u squared and then divide by 2a, we would get that. Yeah, we all did a lot of algebra in our later years, didn't we? So the group theory, ring theory, Galois theory. That was a good course.
Yeah, it's very, very much so. I would have. I feel a little bit jealous of Oliver. Helping to mark the Key Stage 1 papers. I feel like that's a bit more my level these days. Not having been in sort of professional mathematics for for a very long time.
Yeah. Oh yeah, someone raised a point about could the velocity have been -6? Yeah, that is a good point, and I think not. Because we're assuming constant acceleration here. So if you're starting... Oh, no, I think could it have been?
I mean, it doesn't specify what this is exactly. It's in the abstract.
Could you have gone down over that distance? Could you have gone down from... We've gone down from 12 to 6. I don't think we could have gone down from 12 to -6. Is what my intuition is telling me there. Oh, well, here we go, Dan. Here's a finance question. So, a bonus of that is shared by 10 people who work for a company. 40% of the bonus is shared equally between 3 managers, of course. The rest of the bonus is shared equally between the 7 salesmen. One of the salesmen says, if the bonus is shared equally between all 10 people, I will get 25% more money. God, again, you just get someone's whole life story. So, 2100. If we want to take 40% of that, that is going to be what, 840? And that is what the managers get. So therefore, if we do that, subtract 840, we get, well, if we subtract 800, we'll be on 2300, and then we need to take 40, so 2260. Is that right? Add 40 on 23, add 8. Sorry. 260. So the managers, so the salesmen each get 7 divided by 1260. Right, so 0, 0, oh god, so basically not made it any easier there. So what's 126 divided by 7? Well, 15 times 7 is 105, so 102, 119, 126, so 15, 16, 17, 18. So they all get £180 each, is what I've worked out there. So that's how much money they actually get. Now, if the bonus was shared equally between 12, then they would have got 210. Is that 25% more money? No, because it's 30, which isn't, so 30 out of 180 is not 25%. So, you would have got more money, but you wouldn't have, yeah, you wouldn't have got 25% more. Right. God, I generally dislike those questions where it's just a whole faff of actually just going through the whole story of the question. It would take 120 minutes to fill a swimming pool using water from 5 taps. Okay, so that means 1 tap takes 600 minutes. So that means 3 taps takes 200 minutes. State one assumption, all taps equal. And as we know, all taps are equal, but some taps are more equal than others. A plane travels at that speed. Work out an estimate for the number of seconds for the plane to travel 1 mile. Okay, so speed equals distance over time. Time equals, so that's 1 over 200 as an estimate hours. Now 1 over 200, so if we need this in seconds, we need to times this by 60 and times it by 60, so it's 3,600 divided by 200. And I think what we do here is actually do 4,000 divided by 200, because this is the GCSE level where estimation you round to one significant figure. But let's be at least a little bit grown up about it and do 18 seconds. 18 seconds for 1 mile. That certainly doesn't seem right.
Thank you very much to Aidan for the £10.
Yes, Aidan, thank you so much, and thanks for highlighting that as well, Ollie. Thank you. Yeah, no, seriously, thanks for the donation. Sorry, I'm kind of splitting my attention between this question, but thanks very much for the donation. It's really, really appreciated. It seems very quick, doesn't it? But I suppose planes are pretty fast. I mean, 18 seconds for 1 mile. How many miles is that in 1 minute? That's basically 3 point a bit miles per minute, which means
That sounds so bad.
180 and change. Yeah, that 180 and change is like, if the change times 60 could be the difference. But yeah, I can believe that actually. I just said it seems very fast, doesn't it? 18 seconds for 1 mile. But I suppose it is a plane. Planes are fast.
Plane.
Yeah,
Yeah.
I know. Oh, guys, I've not updated my exam counter here, actually. Let me just quickly do that. I'm going to entirely blame Dan for that, for interrupting me and joining the call. How dare he?
Of course.
Paper 1, non-calc. No, my fault. I really should be on that. So this is paper 7. That should update in just a second. Is your answer to part A an underestimate or an overestimate? So we rounded the distance. Time is distance over speed. We decreased the we decreased the speed during rounding, which inflated the time. So it's a slight overestimate, I would say. Because in our rounding, that's what happened. Okay, solve these simultaneous equations. I will gladly solve a simultaneous equation. So let's times the top one. 3y equals 63. And then if we add them together, we get 16x is equal to 72. And therefore x, 2x is equal to 9. So x is equal to 9 over 2. And now let's do 9 subtract 6y is equal to 18. So therefore 6y is equal to minus 9. So y is equal to minus 9 over 6, which is minus 3 over 2. So x minus 3 is 9 over 2, minus 3 over 2 for y. And does that make sense? Is it true that 5 9s take 3 is equal to 42, timesing this one through by 2? 45 take 3, yeah, okay, fine. Just not a nice answer. Wow, this looks like one of those, viral. Do you watch like Mind Your Decisions? Do you watch that channel? This looks like one of those questions. So the diagram shows a square, side lengths 20. Also shows a semicircle, arc of a circle. Oh, this is a good question. This is a good question. So, blah, 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 blah. Show that the ratio of the area of the shaded region to the area of the square is that. So, A shaded is equal to A of that big quarter circle, subtract the area of that little semicircle, because we take that whole thing and then subtract that off. So the area of that quarter circle is pi times 20 squared over 4. Subtract the area of that one, which is pi half the radius squared divided by 2. So this is 100 pi. Subtract 50 pi, which is 50 pi. Now the area of the square is just 20 by 20, which is 400. So this ratio is 50 pi over 400, which does boil down to, if we divide by 50, pi on 8. Fantastic question. I very much approve. Okay, write down the exact value of tan 45. It's 1. Here is a right angled triangle. Cos 60 is a half. Work out the value of x. So that means a half is equal to 4 over x. So x is 8. Yeah, because this is the 1, 2, root 3 type triangle, isn't it? So it makes sense that that one is double that one. So 8 for that one. Okay. The times that 48 trains left a station on Monday were recorded. The cumulative frequency graph gives information about the number of minutes the trains were delayed. Well, trust me, if this is the UK, the graph would be way sharper than that. The shortest delay was 0 minutes. The longest delay was 42 minutes. Sorry, I'm having a bit of trouble just understanding this question because the delay of 42 minutes is there. So why are there more trains that take it up to 50? Yeah. That's 48. The longest delay was 42 minutes.
Look at the axes.
Yeah, but even that's where 42 is, isn't it? So why the graph has to be to scale in order to draw this box plot because we want the median and the. This is bizarre. Well, anyway, I think even there's something very fishy about this. Anyway, let's just do 0. We'll do in fact, I'll just do it like these half lines. It's a little bit neater. And then 42. Let's just put that on as the longest. What year is the paper? 20. It's November 2018, paper 1, James. I mean, there must be something to it because usually they're of quite a high standard, these papers. But anyway, we need the value at 24. So we can answer this question even with that, which is clearly 10. So that is the median. And then we need the value at 12. I'll just kind of read it off here, which is 4. That's for the lower quartile. And then the upper quartile is going to be at 36, which is there, which is at 20. So the box plot is going to look like that. Or box and whisker diagram, as they sometimes call it. 48 trains left the station on Tuesday. The box plot gives information about the delays on Tuesday. So we're going to get that classic follow-up question. You always get this question. You always say the same two things. So we have so compare the distributions. Which trains are more delayed on average? So Monday worse on average. That's because by comparing the medians. I'm not writing this in full like I would in an actual exam because I can't be bothered. And then Tuesday, more consistent because it has a smaller IQR, interquartile range. Okay, Mary says the longest delay on Tuesday was 33 minutes. And I agree with that. That means that there must have been some delays between 25 and 30 minutes. So she's interrogating this region here. No. So could be that 1 at 33 rest between so the rest of the 12 in that top quartile I should say, are between let's say 15, 16, 17, between 17 and 25. So I think that's right, because it's not necessarily the case that there exist values in that range. So, now that that's over with, simplify, we get 1 over 5x minus 5, just because that cancels with the squared. Factorize fully 2, 25 minus y squared, which is 2, 5 plus y, 5 minus y. Jack and Sadia work for a company that sells boxes of breakfast cereal. The company wants to have a special offer. Here is Jack's idea. Put 25% more cereal into each box and do not change the price. Sadia says reduce the price but do not change the amount of cereal in the box. Sadia wants her idea to give the same value for money as Jack's idea. Wow, this is quite an involved question. And this is interesting, isn't it? This is what do they call it? Shrinkflation, where it's inflation in disguise, where sometimes they keep the price the same but reduce the amount that you're getting. So in the UK, our chocolate, Cadbury's chocolate, they did that a few years ago where they announced we don't want to change the price, but the price is going to have to go up, so we're just going to reduce the amount of chocolate that you get in each bar. And then some companies do it very discreetly. For example, crispy M&Ms is notorious for that. Me and my friend that I go to the cinema with, we used to get the crispy M&Ms, and now you get a pouch of them and you get like 5 M&Ms in there. And yes, Toblerone, James. Yeah, we used to have the Toblerone like nice and laid out, all these Toblerone pieces, and now it's like a massive gap between each piece of Toblerone, and they have the audacity to charge the same price for it. So that's shrinkflation, they call that. Anyway, so quite technical this one. So the value for money. So that's cereal over cost. So how much grams do you get per pound? Or we could do cost over the amount of cereal. And that'll be like the grams, like that's like the how much does it cost for 100 grams, which I think is like usually the amount that. But I think either way should be fine. No, I'm gonna do it the other way. I think the other way is more natural. Cost over like mass of the cereal. How much do you pay for a unit of cereal? I think that makes more sense. So this is actually the opposite of shrinkflation here, because they're actually doing a special offer. So if they reduce 25% more cereal in the box, then we get cost over 1.25 lots of the original mass of the cereal. And Sadia says reduce the price, so she's going to do X times the cost over the original cereal. And we want these values to be such that the value is the same. So basically 1 over 1.25 equals what? I think that's how we will do it. And it's going to be 1 over 1.25 as a fraction is 5 quarters. Oh, definitely not written like that. That was really weird. I don't know why I did that. And then well, I could have just and then that's 0.8. Yeah. I think this makes sense, doesn't it? So yeah, got a little update about that question on the cumulative frequency diagram. So, did I do it correct or incorrect, James? Is that what we're saying here? Yeah, ends at 42, because that's where the maximum was. Yeah, so I think I did it right. But I'm still confused as to why the graph continued to increase. I still don't get that. I'm sure there is a reason for it. But anyway, yes, it's my favorite again. We've had a lot of these today. This is fantastic. So,
yeah, so can you just finish off the answer from the previous question?
Oh, have I not done... yes. So if we're doing 0.8 of the cost, that is a reduction of 20%. Yeah, well spotted, Dan. See, there's the mathematical finance coming in, isn't it? Yeah, very good point. Yeah, that's fair actually, because yeah, you do 20% off, don't you? You don't do 80% of price, which yeah.
That would be very strange, wouldn't it?
I think
% of original price.
I think I'd prefer that, to be honest. But I don't think the general public would. Okay, so CAO, that's what we're finding. So this is running around the circle. So what do we know? Well, we know that this is a right angle because tangents meet radius at 90, which means that is 34. These are both radii, which means this is isosceles, which means that is 34. This, therefore, is 180 minus 34 plus 34, which is 68. 180 minus 68 is 112. That is half of that, which means it's 56, which means because this whole thing is a triangle, we've got 69 up here, plus 56, plus 34, plus theta is equal to 180. So, what is that? That's 69 plus 56 plus 34 is 90. So this is 159, which means that little slither in there is 21. Love a good circle theorems question. Describe fully the single transformation. Well, it's obviously an enlargement. Oh wait, yeah, enlargement. I think we tend to use the term dilation, don't we, when we're grown-ups? But enlargement, I like enlargement because obviously if we're mapping A onto B, it actually gets smaller. So enlarge means to change the largeness, I guess. And then the center of enlargement here is obviously we've got that line, and then we've got that line. So looks like 2, 2. So center 2, 2, which should agree if we draw that one there as well. Maybe I'll draw that one in. It'll be a nice pleasing shape. That's cool, isn't it? And then we've gone down from a base 6 to a base 2. So scale factor negative, because we've flipped it, 3. All right, nice and straightforward. Okay, work out the value of 16 over 81 to the power of 3/4. Well, that's going to be 8 over 27. 3 to the a equals a ninth, so that means that a equals negative 2. Oh, okay, can't do this one in my head. So this is 3 squared times 3 to the half. So that means that b is equal to the sum of those, which is 5 over 2. And c is the reciprocal of a half. So let's do minus 4 over 2 plus 5 over 2, take 1 over 2, which is 0. Which makes sense, because 3 to the power of 0 is equal to 1, which means if we multiply these things together, we should get 1. Let's check it. A ninth times 9 root 3 times 1 over root 3 cancels, 1. So that's a good way of checking the answer. So 0 is the answer. That was a nice satisfying answer to get there. 3 solid shapes A, B, and C are similar. Surface area of shape A is 4. Surface area of shape B, right. Let's do a little chart for this. So A, B, C, length, surface area, volume. So surface area of shape A is 4. Surface area of shape B is 25. The ratio of volume B to the volume of C is 27 to 64. Might not actually be 27 and 64, but it doesn't matter. Work out the ratio of the height. Okay, so 4 lots of r squared gives 25, so r is 5 over 2. So that's the scale factor that we multiply by to get from A to B. And then 27, let's call it s cubed, is equal to 64. So therefore s is equal to cube root, oh, no, cube root is 4, excuse me. And then, so times 4 by 3 to get from B to C. So the length of A, let's call it 1. If we do 5 over 2 times 4 over 3, we get 20 over 6. So the ratio is 1 to 20 over 6, which in its simplest form is 6 to 20, which is 3 to 10. Prove algebraically that 0.256 recurring can be written as that. So we all know the trick here. X is equal to 0.256, and then if we want 5, 6 to line up again here, which means we'll get a 5, 6 and a 2, which means we need to multiply it by 1, 2, so multiply it by 10. So 10x is equal to that. Sorry, 100x, I believe. Yeah, because it would be 2.56 and then 25.656. So when we do 99x, we subtract them, we get 25.4, and then the recurring bit dies, which means 990x is equal to 254, which means x is equal to 254 over 990, and then divide both of these by 2, we get 125 plus 2 is 127, and then divide this by 2, it's 450 plus 45 is 495, which, yes, that's the thing that we wanted. That's good.
A small note on question 13. Landris pointed out that the scale factor should be negative 1/3, not negative 3.
Oh, yeah, very good point, because we've shrunk it. I knew I was going to make a mistake that all the way through that question, I was telling myself, don't forget about the negative, don't forget about the negative, don't forget about the negative. And then I forgot about the third. I was like, yeah, because, again, like I said, in large, the feeling is you make it bigger. So I was thinking, oh, we're going this way. That's why I don't actually like that term. I think it's, but then dilate in common parlance means to make, you don't say when your pupils dilate, they get bigger. Whereas, I think a dilation is what I would call that kind of that kind of transformation.
Yeah, embiggen is also suggested.
Embiggen.
Scale.
Yeah, scale. Yeah, scale in general, I think is it is just it is a scaling, but the scaling probably is the best the best suggestion there from Spoof. Yeah. So you would say that, would you? Is that like US? You would say scaling? I think that actually makes the most
I'd say
sense.
Scaling there.
Yeah.
I think naturally I'd go like, okay,
yeah,
you scale it up or you scale it down, or
because
you can even scale it by turning it around, So
yeah, definitely. So right, so 0 minus 5 lies on the curve, and then oh, sorry. Wow, that's bad. 0 minus 5 and 5, 0 lie on the curve. So that means that b is negative 5. We know that straight away. And then that means we need x plus... we need x subtract 5, and then another root to create... So it must be plus 1 there to create the minus 5 at the end. So that means that a is equal to minus 4. Oh, wait. The question is to find the turning point at the curve. Sorry. So x squared subtract 4x subtract 5. That is the equation. So to find the turning point, well, we don't know how to do calculus yet at this level, so let's do it the old-fashioned way, which is to complete the square. So it's that. So that means x equals 2, y equals negative 9, and that I can believe. Obviously, in grown-up maths, we would do this, so that x is equal to 2, and then substitute that back in. But this is it's not a bad way of doing it, really. It's just that it can be awkward when there's odd numbers and the coefficient of x squared is greater than 1, etc. Ooh, this looks cool. So the graph of y equals f of x is shown on the grid below. On the grid above, sketch, let's do it in pencil because I'll probably make a mess of this. Sketch the graph of f of x subtract 2. So that's a translation, positive 2 in the x direction, which means it's going to go through there, it's going to go through there, it's going to be at a turning point there. That point is going to slide over to there, that point is going to slide to the right. So it's going to look something. Gone a bit low there. Something like that. Now, on the grid graph, A is being reflected to grid graph B. So it's a reflection in the y-axis, which means it's g of negative x. You're making your x values negative and then evaluating. Or as I like to think of it, a reflection in the x direction, because inside the bracket it's always in the x direction. So in a reflection about the y-axis, but in the x direction. Okay. Yeah, in grown-up math they Google quadratic. Yeah, grown-up math they probably ask ChatGPT to do it, even though ChatGPT is horrendously bad at
I
maths.
wouldn't be asking
No.
ChatGPT for any of my mathematical queries.
Yeah, it's good at many things, but mathematics is not one of them.
The other day it proved to me that root 2 was rational. So
Yeah, that's not
very
great.
convincingly.
Yeah, it's always convincing. That's what we were chatting about this the other night, weren't we? And it was like, yeah, it always just, I hate the level of confidence it has. It just asserts things so confidently, and it can be so wrong.
I do wish that I was as confident as ChatGPT.
Yeah. Yeah, if only. So just turning the handle here, as we say. So this is x squared plus 2x plus 1, all subtract 2, which means that is actually going to cancel with that, which means we get 2, pull the x out, and we get an x plus 1. No, x plus 2, because it's creating a... Yeah, we're just pulling the x out, which is what we want there. That's good. Find g inverse of 7. Well, we could find the inverse function, but I'm wondering if there's a clever way of doing this. So g inverse of 7 is going to be something, which means that g inverse of 7 is just g of x, which is 7. So it is just 2x minus 7 is equal, x minus 1 is equal to 7. Which means x is equal to 7 over 2 plus 1 is equal to 9 over 2. I think the way is that is intended is to say, you go through this usual game of, rearrange like that. So g inverse of x is equal to of 7, sorry, is y is 7 plus 2 over 2, which is the same thing. But I like this way, bringing in a bit of the old group theory there, kind of. Okay, show that horrible expression can be written in that form, of course. So let's expand that top bit out there. So we get 18 plus 2 root 18 root 2. Root 18 times root 2 is actually root 36, so that's 12, so it's 32 up there, over root 8 minus 2. Just seeing it in the comment about Wolfram Alpha. Wolfram Alpha is actually remains very good for most things. I think because it knows its limitations. Like Wolfram Alpha, if it can't do something, it will tell you. It says, "Oh, I don't understand this. This is the best I can do." But it's very clear that it's not confident in the answer. Whereas ChatGPT is always like, it just says it exactly, and it's absolutely sure that it's the answer. So 8 root 8 plus 16. I think that's what we get there. What if there's another way of expanding? That's weird about that 32. It doesn't feel right to me. Root 18 is actually 3 root 2. So that numerator is just that, which is 4 root 2 all squared, which is 16 times... Yeah, it is 32. And then, for some reason, my brain, again, is just flagging that, are we sure about this? But I think it's right. Fine.
does it need to be factorized?
Oh, yes, we need the root 2 there, don't we? So root 8 is of course 2 root 2. So this whole thing is actually 16 root 2 plus 16. In other words, 16 1 plus root 2. So that's your A and that's your B. Yeah, thanks for the heads up on that. So looks like the last page, so last two questions. So 21. OAB is a triangle, I agree. OPM and APN are straight lines. M is the midpoint of AB. OA is the vector A, and OB is the vector B. The ratio OP to PM is 3 to 2. Work out the ratio of ON to NB. Right, these questions are actually quite often very, very complicated. Let me just think for a minute here. So, I'm going to say right. Because what my intuition is telling me here is usually the way to do these is you want to get to n in two different ways. So one way to get there is to take some multiple of b. And then the other way to get there, we need to somehow bring this information in, because the thing that defines n is the fact that it cuts the line OM in that ratio. So what is OM then? Let's get our hands on OM. Now OM is you go OA and then you go halfway from A to B. That's how I'm going to write that. OA is just A, kind of mixing up my arrows and underlines in my vector notation here, which I'm a little bit terrible for, but you'll have to just forgive me. And then AB, how do we get from A to B? Well, we go backwards along A and forwards along B, so that's just B minus A. So let's tidy that up actually. So that's half of A plus B. Oh, of course it is. It's the midpoint. Yeah. So yeah, because if you do A plus B, you get to that point there on the parallelogram. Half it. We're at M. Sorry. Yeah, that should have been a bit more obvious. And now OP, because we're in the ratio 3 to 2, is 3/5 of OM. So that's 3/10 of A plus B. And then why did I do this? Because I want ON to be that. And now I'm going to go to ON via a different route. I'm going to go to OP. And then, so another route to ON, which uses the fact that we've got this ratio, is to go to OP, which we know, and then add PN, which we don't know. So the question is now, what is PN? I'm usually really good at these. These are the sort of questions that I used to be really good at. I'm just struggling to see. Obviously, there's a ratio there. Pn. Well, I suppose Pn, we could go Pm plus Mb plus Bn. I don't know if this is the easiest way of doing it, but it's the only way I can kind of spot right now. So Pm is 2/5 of OM. MB is half of AB. And then Bn is it 1 minus lambda? Or 1 over lambda? If I'm saying, oh god, oh god, oh god, oh god. Lambda b is there, so that must be 1 minus lambda b, because we want to add them to, no, we want to add them to get, yeah, we want to add them to get b, so bm 1 minus lambda, so 2/5 of om, what was om? Half a plus b, plus half of ab. What was AB? It was B minus A. Plus plus Bn, which is 1 minus lambda of negative B, because we're going backwards along B. Right, and if I've done this right, hopefully this all won't kind of boil down to just lambda B, which I've got a really sick feeling in my stomach that that's what's going to happen. No, it shouldn't do. Because sometimes even if you go in two different ways, you've actually gone the same way, and it just all liquidizes down to 0. So this is 2/10 of A plus 2/10 of B plus half B, take half A, subtract B, plus lambda B. My god, I've really not done this the simplest way. Yeah, I really regret how I've gone about this. So half there, that's going to be minus 3/10 of A. So it deals with that, and it deals with that. 2/10 plus a half is 7/10. So minus 3/10 of B. And then we've still got that plus lambda B floating around. Oh, and this is exactly what I was worried about. Because now, O P to Pn, it is just gonna boil down, because if once I add that on, it's just gonna become lambda lambda b. Damn it. Okay. So
I think you're right. I think you do have to do it in two ways, right? You've got to figure out how to get AN in two different ways, and then do that comparison. Maybe
yeah.
something slightly earlier that's not quite right.
Well, yeah, there's probably a much simpler way of doing it. I mean, this is just way. I knew that was wrong. As soon as I started writing, I'm like, it's not going to be this complicated. AN. Did I ever find out what AP was? Sorry, yeah, AP. Because this might be the way in, because AP and N are all collinear. So I know that AN, for example, is some multiple of AP. So if I know what AP is, which I think I do know, AP is minus A and then along OP. Minus A plus 3/10 of A plus B. And now that I know AN, I know ON, which is A plus AN. So I think this is it, because I don't think everything's going to liquidize in here. Yeah, so because you want to get there, there's two things that define what N is. It's on OB, and it's on the line that's formed from a stretching out AP. You've got to. That's it. You've got to bring in both pieces of information. Well, let's not celebrate just yet though, because there's still a lot of messing around to do here. So if I do A plus all of that rubbish, I get mu of. So what's that? 7/10 of A plus 3/10 of B. Sorry, I'm writing quite small here, so apologies to the viewers. So that's 10 over 10. So this is going to be. I wonder if I should pull that 10th out. Should probably pull the 10th out. So this is a 10th. 10 plus 7 mu, lots of A, plus 3B. Still something I don't like about this. I've lost that mu. Let's just. I'm just gonna take my time here because I'm making mistakes. Plus 7a mu over 10 plus 3 mu b over 10. So I've got 70. No, I've got 10 plus 7 mu lots of a over 10 plus 3 mu b over 10, which is a 10th. 10 plus 7 mu lots of a plus 3 mu b. Okay, now what's the punchline? Well, that's ON. Let's not forget. And I also know that ON is just some multiple of B. So that means that 10 plus 7 mu is equal to 0, and it means that mu is minus 10 over 7. And I know that 3 mu is equal to that lambda. So if we times this by 3, I get that lambda is why is it negative? I've made a mistake somewhere because it really shouldn't be negative, should it? But there's nowhere. There's a minus a there, which I think got lost. Did it? No, because that's where the yes. So minus a plus 3/10 of a is minus 7/10 of a. Oh my god. So that is negative. That is negative. That is negative. That is negative. So that is positive, and that is. I knew that would happen. So lambda is 30 over 7, which again absolutely makes 0 sense, because it should be it should be like a lower amount of B. God, I'm really making a mess of this.
Yeah, I think that's
Can't possibly be.
no, that's not. Yeah, that's not
So,
right.
I'm tempted to just start this one again.
let,
I think so. I think yeah, because you have yeah, I think you like the first half was right? You've got your A. Yeah, yeah. James is coming in too.
Start again.
Yeah.
So, I think the approach is right. On is some multiple of B. I think we can all agree on that. And lambda must be less than 1. It's small. We're shrinking B to get from O to N. Now, On is also OA plus some multiple, a big multiple of AP. Must be OA and then AP. You stretch out that latter one and you will get to N. OA is A, and then we do mu lots of AP. Now, what is AP? Well, to get from A to P, you have to go backwards along A, and then you need to do 3/5 of OM. And what is that? That is mu minus A plus 3/5. Now, OM is just A plus B, as we worked out before. I'm confident that that's right. So this is A plus mu. I'm gonna really take my time here. Minus A plus 3/5 of A plus 3/5 of B. The numbers are different, which is a relief.
sorry, did you miss a half there? I might be wrong. Sorry. You mentioned OM was 1/2 AB,
Yeah.
A plus B.
No, you are. Yeah, you're absolutely right. Which now is filling my stomach with bile because now I'm getting. It's looking very similar to last time. Yeah, good point. But I didn't want to see this because it's gonna.
I think you're on the right track.
So the mistake must have been very late. I thought I made a very early mistake last time. So minus 10 plus 3 is minus 7/10 of A plus 3/10 of B. And now A plus minus 7/10 mu of A. I'm not seeing where anything is going to be different. Plus 3/10 B times mu. Ooh, this 3/10 maybe. No. It's 3/7. I bet you the answer is 3/7. Because I forgot about that 10th that I took out. I think the answer is going to be 3/7. But let's just carry on here. Whew. So what is this telling us? So this component must be 0A because it's just a multiple of B. So 1 subtract 7 mu over 10 is equal to 0. That means mu is equal to 10/7. And now 3 mu over 10 is equal to lambda. That's that. And 3/10 of 10/7 is 3/7. Holy moly. So, what was the actual question? It was the ratio ON to NB. So we've basically got this. We've got the N there. We're saying that that's 3/7 of the way along. We're saying that that's 4/7 of the way along, which means the ratio is 3 to 4. Oh my god, that was that was. I hope you agree that those questions are tough. Like even if you get the right, even if you know the correct method from the get go, it's not easy. And
Yeah,
and because I'm rushing, um, not quite my tempo, then I'm more prone to making silly mistakes. It was so frustrating that it was right at the end as well. I thought I'd made a quite an obvious error really early, and then that was going to carry forward. But actually, it was just I needed to divide it by 10.
yeah, it's John and Papa Christos that really picked out
Oh
that
right,
where it went wrong in the previous one
perfect.
to take 1 out of 10 outside the parentheses.
Yeah, yeah, that was it. So factoring out the tenth made it look a bit cleaner, but if you're cramming your answer into the bottom and you're not paying full attention, then mistakes happen. Right, yeah. So thanks for following along on that one, guys. That was yeah, made a pig's ear of that, as we say. So last question of the paper. There are only green pens and blue pens in a box. We all know that red is the best color of pen, so what monsters? There are 3 more blue pens than green pens, so that means the number of greens plus 3 is equal to blue. I'm just going to digest some of this. There are more than 12 pens in the box. Simon is going to take at random 2 pens from the box. The probability that Simon will pick 2 pens of the same color is that. Right. So you remember when I said before that the only way I know how to understand probabilities with a bit of a tree diagram sort of approach? So on the first, it's either going to be G or B, G or B, G or B. I think I know what's going to happen here. So the probability that you draw a green is number of greens divided by the total. And the probability that you then draw another green is G minus 1, because you've already picked out one of the greens. And your total is also decreased by 1 as well. And then for blue, similar sort of thing, where we'll have B minus 1 over G plus B minus 1. And we want GG, so P of GG plus the probability of blue. So G times G minus 1 all over G plus B times G plus B minus 1 plus B times B minus 1 over G plus B minus 1 times G plus B. What am I doing? I've just realized we never used this, which is really annoying, because now I reckon this question, the way I've set it up is actually not very good. Yeah, I wish I'd substituted that in earlier. Again, I'm going to start this one again, because so the total is well, B plus G, but if we can eliminate one of our variables early, that'll be easier. So the total is that. That's going to make the whole thing a lot easier. So it's still G times G minus 1 over 2G plus 3, the total, and then the total minus 1. That's the probability that you draw green. Now, G plus 3 is the number of blues, so we draw a blue, and then we have 1 fewer blues to draw from, all divided by 2G plus 3, 2G plus 2, add them, equals 27 over 55. It's probably an easier way to do this. Okay, let's just focus on the numerator. G squared minus G plus G squared plus 5G plus 6. What I'm hoping for is a bit of cancellation. So this is equal to G squared plus 4G. No cancellation. Come on, something must cancel. 2G. Okay, and let's take out the factor of 2, because I know what I'm going to do with that. I'm not going to forget about it this time. g squared plus 2g plus 3. Oh, still no cancellation. I really want to factorize it. Come on. This is just...
2g squared, people are shouting out.
I think that's been done.
All right.
Ah, yeah, 2g squared there. Yeah, that was a good point. I really wanted this to cancel. I really wanted it to factorize and cancel with one of these brackets down here. But it won't. Unless we don't take out the... Because what I want is I'm going to cancel that that 2 there. Because that'll become a g plus 1. But there's no factor of g plus 1 in there, so it doesn't factor with the entire bracket. Am I being stupid here, or what? 3g plus... it would have to be that. That's what the factorization would have to be. And does that work? 3g plus... Nope, that doesn't work. Or 2g plus 2. If we want some cancellation, it would have to be g plus 3, 2g... But yeah, okay, I need to just make peace with the fact that it's not going to cancel very nicely. So g squared plus 2g plus 3 over 2g plus 3 g plus 1, because that has cancelled with that, is equal to 27 over... This is a nightmare. It can't be right. This is awful. Well, the only thing that's given me a little bit of confidence is the fact that we've got 55 there, and 2 times 27 is 54. So the coefficient of g squared is going to become 1. That's the only thing that's given me any kind of hope at the moment. So 55 g squared plus 110g plus 165 is equal to 50... no, let's just... Come on. Don't do too many steps at once. 2g squared plus 7g plus 3, is it? Plus 3 plus 4 plus 3, yep. So that is 54g squared. Oh, for God's sake. 140 plus 49 is 189g. And then 27 times 3 is obviously 81. This is a nightmare. I've not got any confidence in anything of what I'm doing. 110 subtract 189 is 79? What is going on?
I think that's a negative.
Oh yeah, negative, yeah. 27 times 7 is 140 plus 40. Yeah, it is 189. And then...
The 7g should be 5g.
Yeah, yeah. This is better.
Thanks, Giovanni.
Yeah, thanks guys. I'm losing patience here because this...
All right, it only takes 70 people, 71 people, which are currently here, to answer this. We'll get there.
We'll get there. And now surely this factorizes. Please. So, what are we thinking? 12 and 7? Nope. 6 and 14? Nope. 3 and 28? Well, 3 and 28 would work, but... they've both got to be negative.
What's the next one?
Well, it would be 2 and 56, which we're getting further away there.
I think you've missed one.
Oh,
There's a-
4.
there's a
Yeah,
2.
yeah, there's a 4. Yeah. 4 and 20. Yeah, thank God. All right. So G minus 4, G minus 21 is 0. I'm going to take a break after this paper because I'm getting very, very rusty here. Right. Okay. And the punchline is the number of green pens in the box. However, we do have 2 options, so we're just going to be a bit careful. Is it 4 or is it 21? It must be 21 because if so G equals 4 implies that B is equal to 7, which implies that G plus B is equal to 11, which is not less than 12, therefore G is 21. Not easy. Not easy. That was hard. Last 2 questions of that were a nightmare. For saying that we did 3 GCSE papers before, and I was actually a little bit kind of miffed about how easy they were, but the last 2 questions of that were pretty. I wonder actually. The first paper, the
What was
first papers that we
what?
did. Sorry, Dan. 1 second. I just want to. So June 2018, and this was I think the November 2018, which is the same year. Because the June 2018, I think, was actually the first series of papers that was on the new spec, and the new spec is significantly more difficult than the old spec, as we'll see when we answer some GCSE papers in about 18 hours' time. So I'm wondering whether they were told you didn't step up the difficulty enough, because the goal. This is the Michael Gove years. The goal was to kind of make maths more academic again. Make it harder, make it more challenging. So the exam boards responded. I've got the feeling that between June and November, there was a step up in difficulty, because that was significantly harder than the first 3 papers that we did a couple of hours ago. So, or maybe it actually wasn't that hard, and I just missed some easier ways of doing it, which does sound a lot like something I would do. Okay, I'm going to take a short break here, maybe just about 15 minutes, or maybe just about 10 minutes, I don't know, because we've got an A-level paper coming up. So this is the exam sat at the end of what we call college and what the US might call high school. We're going to do an A-level paper. We're going to do an A-level further maths paper, because there's 2 different qualifications you can get at that level: the A-level maths and the A-level further maths. Further maths introduces just like a lot more sort of sophisticated maths. It introduces complex numbers and hyperbolic trig functions and all that kind of good stuff, matrices, etc. And then we'll do the degree level paper. So we're kind of halfway through our journey through mathematics. I hope you've been enjoying it. So I'll be back. Let's call it 5:10, and I'll leave you here to entertain, guys. I'll be back in a little while.
Right, no worries. Thank you very much.
Gents, I thought I'd hop on as well since we've got a bit of chair stream going on.
Oh, lovely.
Hello,
Hello, James.
hello, James.
Hello, folks. And just to say hello to our global audience, my name's James. I'm another former comrade of Alex back in our undergraduate days in Manchester. And yeah, what a pleasure and a privilege it is to be back again for the 3rd time. So yeah. I can see we've got some people in the chat who've joined recently. So if people aren't entirely sure what we're doing, well, Alex is doing 24 maths exams in 24 hours, and it's a mix. It's all British, so it's all, or I should say English. So we got some GCSEs, which are papers that people take at age 16. We got some A levels, which I think is what he's going to do next, which are for people at age 18 to take, and they're sort of university entrance papers is one way to think about them. And I think quite a lot later on we're going to get a couple of special papers as well. I think we're going to get a UK maths challenge paper towards the end, but I think we're some hours away from that. But yeah, making good time so far, don't you think, guys?
Yeah, absolutely, 100%. I'm interested actually. Those challenge papers. Who normally sits those kinds of papers?
Yeah, let's talk a little bit about that. So we've got a thing in the UK called the UK Mathematics Trust, the UKMT, and this is a charity, and it kind of exists to promote, kind of, math. It just exists to promote maths education, really. I think, and for very many years, they have set a number of papers called the Maths Challenge. So there's a few of them for different age groups. There's like the Junior Maths Challenge, Intermediate Maths Challenge, and so on. And they sort of function as feeder papers for the International Maths Olympiad, right? So they're really aimed at the kind of most able students. So typically, schools will enter maybe the top set, maybe the top two sets into this paper. But generally speaking, I mean, I don't know whether you guys did it when you were at school. I did, but you don't generally do any prep for it. I think it's fair to say.
I think I did it. That's in year 7 or year 8.
Yeah.
Yeah, is this the one where you have the format where you are coloring in the like A, B, C, D, and E?
That's right. Yes.
Yeah. I do remember those. I have fond memories of those. They were fun papers.
No, they're very fun papers. Yeah, I think it's going to be tomorrow morning. Tomorrow morning UK time.
Yes.
Before we get to that.
And a lot of the questions that you see reference the year in which you are taking the paper.
Yes.
I do remember that being quite fun. I think I must have done it in 2004, perhaps, showing my age. Yeah. But yeah, and there was lots of questions about that. Or it might have been, I think I remember, it might have been a prime year as well. I did one then.
And I think the thing is, like, we've just seen a lot of GCSE papers over the last few hours, and I think it's fair to say that GCSE is pretty dry. You know what I mean? It's not the most exciting rendition of maths that you can do, whereas the UKMT papers they're not easy by any means, they're difficult, but they're a lot more fun. And so I think it's really important that we have, and like I say, it's important to remember the UKMT is a charity, so, go and check them out. But I just think it's a really important thing to give secondary school students the sense that actually GCSE maths isn't the whole story of what maths is. Particularly with the exams the way they are at the moment.
Absolutely. I always really enjoyed the UK Maths Challenge as well. Yeah.
Good stuff. Do we know? Now, I've been telling people in the chat we're getting an undergrad paper today as well. Now, I'm not sure that's right, actually, is it? Do you guys know?
I think we do have one. I think that might be. Yeah, I think that might be towards the end.
It will be towards the end.
So after the A-level papers, I believe.
Yeah. We're going to get the A-level. And I saw that. I think we're doing an old A-level and a new A-level, right? So we're doing like old, we're doing like the 2010 era modular A-level. And then I think we're doing like a contemporary A-level as well. And I think we're going to do a couple of further maths papers too. It's quite interesting the way. So back around 2010, and I think for a good 10 years before that as well, we had a very, very modular system for A-levels in the UK. So most A-levels consisted of 6 modules, and you would sort of you'd take the papers twice a year. So you'd do papers in January, papers in June, papers in January, papers in June. But not long after 2010, they started to convert them into a much more synoptic format, where actually there would only be one exam session, and it's at the end. So rather than doing 4 exam sessions over the 2 years, you just have 1 exam session right at the end. And as part of that, they also reduced the number of modules. So originally, as I say, right in the 2010, sort of 2000 to 2010, you got these 6 modules, and I think nowadays, they have 4 papers, not 6. So it's quite different, really. And it's gone along with the sort of reduction in coursework as well. Although the maths A-level maths spec, I don't think ever did have coursework, but it's not just a change that affected maths. They did it across every subject at A-level. So it's going to be interesting to see the contrast and comparison, I think.
Especially in the way that the people go about taking these kinds of tests. It'd be interesting to see how Alex also takes these kinds of tests as well.
Oh yeah, well, I mean, the thing that always gets me about the way that Al does these is like how snappy his algebra is. Like very, very, very fluent manipulations, and I think we'll see that in the A-level papers.
Yeah, and that comes with a lot of experience. Like the more that you do of these things, the more intuition that you get of where this series of equations needs to go. Probably saw that quite a lot in the last paper where he was like, he wrote something down and he went, and he just knew that, oh no, this isn't going to work in about 3 lines time.
Yeah,
And
yeah.
it comes true just because you have that intuition.
Yeah, very, very snappy. Swashbuckling, almost, I would say, at times. What did you think? What's your pick of the questions we've had so far? I really like some of those Key Stage 3 questions.
Oh, that's a really good point. That's a really good question. I do kind of like those. The one which Alex actually got stuck on in recently, the one that was
The vectors one.
That little triangle.
Oh, I hate
the
those
little
questions.
triangle one.
Okay, you like those, do you? Okay.
I remember when I was going through those, like those ones were, like I really worked hard on them because the earlier questions you can kind of, I always felt like I could work out. Didn't need to study too hard on them. It was just about manipulating it into the right form. But those last, like the last couple questions on any UK maths paper, you really do have to know all your methods.
Yeah, absolutely. Those ones are the real discriminator for the upgrades for sure. I really liked the one that he was doing on the Key Stage 3 paper with the 4 quadrants. You know the one I'm talking about, where it was, it had the sort of Cartesian axes split into sort of 8, and it was sort of saying, write down the areas where x is greater than 0, write down the areas where xy is greater than 0, write down the areas where x is greater than y. Really like smart little question. Check your understanding of what's going on. I think I really like the questions on those old Key Stage 3 sats anyway. But that's a really nice one.
And just remember, everyone, that we are raising money for Mind. You will be able to see the links down in the description, as well as you can see the Tiltify QR code on the screen if you are comfortable to donate to Mind, which is a mental health charity.
Yeah, British mental health charity. Really great cause. Help a really significant number of people in the UK every year. So, great reason to be here. And thank you so much to everybody who has donated already. We're doing amazingly towards the goal this time. So thank you so much, everybody. It's hugely, hugely appreciated. Fantastic stuff. Okay.
And actually, this is probably a really good time for people in the chat. Like, I reckon when Alex will come back, you may just want to sit down and take stock. We'll follow up on any comments or questions that people have put forward. And so if you do have any questions, just drop it into the chat.
I'm interested to know what our overseas compatriots are making of some of these British papers, really.
That
Or
would be really
English. Sorry,
interesting.
I always get this wrong, of course, because the papers are completely different in Scotland. So you've got to remind myself to say English, not British.
Indeed.
And here we go. Right. Well, I'm going to say goodbye,
Oh,
and
hi,
I'll
James.
see. Hello. Well, I was just hopping on while we were having a bit of chair stream.
Yeah, keeping my seat warm.
But I'm going to hop off again now. So
Yeah, no
good
worries.
luck,
Yeah.
and yeah, see you later on.
Yeah, I'll see you in about 12 hours.
Yeah, see you in about 12 hours. All right, bye guys.
See you later. All right,
Alright.
so welcome back, everybody. I did realize actually I wrote 1610 on my board, but obviously I meant 1710. So apologies for that. I just it really doesn't bode well. Like the year 2013, Ollie.
Yes.
We actually thought you might have meant UTC, not BST.
Oh right. Well,
did.
yeah, that is true actually. Yeah, let's go with that. Okay, so now we move on to the A level paper, which is the most difficult paper that we've done so far. It can be quite hard, these, but the maths is more interesting. And then after this, we've got the further maths paper, which I'm dreading. Probably the paper that I'll find the most difficult out of all of them, because they are so messy. You know how the algebra gets. Did you want to say something? Sorry, Dan.
Oh, we had a question while you were on break. What kind of pen are you using?
This is a Lamy pen. It's a really good question, actually. I've got two Lamy pens. I've got this one, which I think is called the Lamy Studio. This is like the basic, the cheapest Lamy pen, but it's still like I've had it for about 5 years, and it's still perfectly serviceable. And this one, I think, might be the Lamy. It's not the Metra something. I think that's a different one. But yes, generally high quality entry level pens. You don't have to like. I got this one as a gift. That my dad got me this one for Christmas a few years ago, which I think was around the £50 sort of range. But it's very very good. I got into fountain pens maybe 6 7 years ago because I realized that they were the answer to my usual pen problem of I want a pen that writes with the minimum level of pressure. I don't want to have to press down hard because I'm a very light. I have a very light touch when I write, but I still like to write visibly and not totally faintly. So sorry, that was a very long answer, which basically came down to I'm not sure, but it is a Lamy. If you Google Lamy pens, you'll see it. Right. Any other questions? Any other insights while I was away?
Oh, I think we're ready to go.
We're ready to go. So let's crack on with the A level then. Let me just update
Just a quick reminder. Sorry, Alex. Just a quick reminder to up the exam count number.
Just just doing that. So.
And what paper are we on here?
You've got the mark schemes, haven't you? Because I think
I've got it open. Yeah.
yeah. So this is just it's 2021, the autumn season, but it is just in that file as paper one. I think I called it. So yeah.
Wonderful.
So this is A level. Basically, the exam taken at the end of what we call college, what the US calls high school. When you're about 18 years old, or sometimes 17. Sometimes on the day that you turned 18, which was usually the case for me because I have a June birthday. So, in terms of the journey through mathematics, the big thing that you encounter during A level is obviously calculus. So there'll be a lot of differentiation, integration here. What else will there be? There'll be like binomial theorem, summation notation, that kind of thing. Just increasing the level of sophistication, but still not the degree level proof and logic and rigor approach to mathematics. So still, it's still very much in the, learning the mechanical processes by which we solve problems, but still, it was getting more interesting. I was going to say something before we started, but I've forgotten what it is. I apologize. Let's just get into it. So, obviously we're using the factor theorem here. So x minus 1 is a factor if and only if f of 1 is equal to 0. So therefore a plus 10 minus 3a minus 4 is equal to 0. So that means that minus 2a is equal to minus 6, so a is equal to 3. So, not every question is particularly sophisticated. If I do get to the end and I've got a question incorrect, please just flag it up with me, because I think for these ones I do want to make sure I try and get them right. And there are fewer questions, at least. There's usually about between 10 and 15 questions on these A-level papers. So express f of x in that form. So this is completing the square, not f, x minus 2 all squared, minus 4 plus 5, so plus 1, sorry. And then b part 1. Now the curve with that equation meets the y-axis at the point P. So P is going to be 0, 5. That's what x equals 0. And it has a minimum... Wow, what a strange question to ask at the A-level stage, because there's nothing in there that couldn't have been a GCSE question. And it is assumed that you know everything from GCSE, but I don't know. Usually they like to step up the game a little bit. Sequence is defined, got a recursive thing here. Okay, show that. Alright, okay, we're getting into a little bit more interesting sort of territory now. So, let's do... So u2 is equal to k minus 24 over 2 is k minus 12, because u1 is 2, which is given. And then u3 is k subtract 24 over u2, which is k subtract 24 over k minus 12. And then we're given this. So u1 plus u2 plus u3 is equal to 0, implies 2u2. 2 plus 2k minus 12 plus k subtract 24 over k minus 12 is equal to 0. So I think we can just multiply through by k minus 12 here. So we've got 2k minus 12 squared plus, I'm going to rearrange it a little bit as we go, k minus 12. So that's that term, no, that's that term, that's that term. This term is just plus 2k minus 12. And then we've got the subtract 24. And hopefully this all tidies up to become that. So this is 2k squared subtract 24 plus 144 plus k squared minus 12k plus 2k minus 12k. Nope, just minus 24. And then subtract 24 is equal to 0. So how many k's have we got? We've got 2k squared plus k squared is equal to 3k squared. That should be a k there. And how many k's have we got? We've got minus 48 from that. Subtract 12. That's minus 60. Plus 2 is minus 58k. This is looking good. And then we've got 288, the constants now. And then subtract 48, we get 240. As required. Okay, and then part B. Find the value of k. So 3k, k is 0. Oh god. So what is that going to be? 24 times 10 seems like a sensible place to start. Could be 12 times 20. God, wow, I'm really bad at this today. Usually I'm just absolutely... I could just spot it. In fact, we can use a calculator on this paper. But where is it? I lost it before. I actually genuinely have no idea where it's gone. Where could it possibly be? Because I had it for those first few papers. It's like disappeared off the face of the earth. Wow, it was literally right in front of me. I just couldn't see it. That was absolutely bizarre. So, just really overlooking it there. So I'm thinking about 18. No, 18 doesn't go. I'm gonna cheat here. Students are expected to actually do this these days and use the calculator to solve these. So let's just do that. Oh, it is 40 over 3. Ah, yes. So 6. So minus 6. And what was the other one? 4. Oh, so all right, so it's 6 and 40. Yeah, because it's 40 and then lose another... minus 40, lose another 18. So yeah, k equals 6 because it has to be an integer. So that's the value of that. So then, find the value of u3. Well, we worked out u3 was just 6 subtract 24 over 6 minus 12. So that's 6 subtract 12 is minus 6. Okay, and then 24 divided by minus 6 is minus 4, 10. 10. Hi, Ghosty. Good to see you there. Yeah, so Ghosty Ocean, he's my blasphemous companion. Helps me to navigate. Basically performs the role that you did, Ollie, when I was playing Hollow Knight, helping me to navigate and things like that.
That's fantastic.
So, okay. I'm presuming because you've not said anything that they were correct so far.
So far, so good.
Okay, so let's just push forward. So show that alpha is a solution to that, and it has a single turning. So f of x has a turning point. Okay, so that means that f dash of alpha equals 0. Now f dash of x is 2x. So this is the calculus. This is the big step up of to A level. This is the really the big bulk of new content that's introduced. So 4x subtract 4 over x squared. 2x squared. Take 4x plus 5. And if it equals 0, then we get 0 is equal to 2x squared, take 4x plus 5, plus 4x minus 4, which is equal to 4x cubed. So that's our cubic term. The only quadratic term will be the minus 8x squared. That's that one. And then linear terms, 2x times 5 is 10x. That would be plus 14x. And then subtract 4, and there's a common 2, so we'll divide through by that. And hopefully, yeah, that's what we wanted. I do love the A level for that. The amount of times that it tells you what the answer is, so that you know what you have some confidence that you've got it right. And now the iterative formula can be used to find. God, we did this again. A funny question for the A level, really, considering that iteration has trickled down into the GCSE these days. Oh, hey, Mike. Thanks for joining the chat. So another one of our friends from university. We were in the same kind of study group together. That's how we met. Probably the first friend that I met at university, actually, having thought about it, at least on our course. So lovely to see you here as always. So what are we doing? Oh yeah, 0.3. That's x1, and then we're going to use 1/7 of 2 plus 4x squared take 4x cubed. That's x2.
And thanks to Anonymous for the £20 donation.
Oh, excellent. Thank you so much, whoever you are. That's absolutely fantastic. All goes to a fantastic cause. It all really helps. So thank you so much. Keep those donations coming in. While I find X3 here. So those are converging. Using a suitable interval and a suitable function that should be stated. Show that alpha is that to 3 decimal places. Oh, I see. So if I just let, I mean, this is a bit funny, but if I just let f of x equal, well, let's not use f. Let's say g of x because we've already used f. Let's say g of x is equal to that. Take 4x squared plus 7x take 2. If we want to show that this is 0.341 to 3 decimal places, if we find g of 0.3415 and g of 0.3405, then we're going to get a change in sign here. And because this is a continuous function, it means that there must be a root between them, which is the, what is it, the intermediate value theorem? In real analysis, I think that's what it is. Continuous function between 2 points, there must exist a value that goes up to that point. So, to that cubed, take 4 of that plus 7 of that took 2 is 0.0037, let's say, doesn't really matter. And then we'll do 0.305. Excuse me. And then we push that back into there, and we get negative 0.001. So change in sign. Just writing the letters down in the wrong order. Therefore, alpha is in the interval 0.3415. You get the idea.
I think you might need for BII. I think you're missing X4.
Oh yeah, yeah. So we would just stick that in the function again to find x4. I don't think I'm going to bother doing that because we get the idea. Should I do that? Oh, go on then. That's really weird that it asked me to find x2 and then x4. I bet so many students got caught out with that. Take 2 and cubed. So x4 is actually 0.3398. All right, thanks for the heads up on that. That was a silly mistake. Oh yeah. I forgot about this. They give you so much paper. I really wish I'd have, because I print them all off without looking, because I just download the files and then send them to the print shop. Because I don't even like to open them, because if I open them, I'd be tempted to like glance at the questions. I made the exact same mistake that I did last year, where I printed off all of the kind of answer paper, which makes me feel really bad actually, because it is really wasteful, but it is for charity. So the company made a profit of 20,000 in the first year of trading. Here we go, Dan. Another profitability question. A model for future trading predicts that the yearly profit will increase by 8% each year, so that the yearly profits will form a geometric... Oh, I was just about to say it's going to be a geometric sequence question. Show that the profit for year 3 will be that. So, if we do 20,000... So the profit... Oh, that's profit for year 1. So 20,000 profit year 1. And then to get the profit for year 2, we need to times by 1.08. So if we do 20,000 times 1.08 squared, that should give us the answer. So 20,000 times 1.08 squared is 23328. Fine. Nice one marker just to get you into the question. Find the first year when the yearly profit will exceed that. So this could be a GCSE question. However, the expectation is that you use logarithms here. That's something else that's introduced between GCSE and A level. So there's some year, well, let's call it n minus 1 actually, because I always make this mistake, because year 3 is when that is 2. So this will give us the year. So that the power for which this is greater than or equal to that is what we need. So if we do 65 divided by 20, 3.25, 1.08 to the n minus 1 greater than or equal to 3.25. When does that happen? Well, the log base 1.08 of 3.25 plus 1 is less than or equal to n. I think we swapped the inequalities around. So log base 1.08 of 3.25 and then add 1. So 17. So 16.3. So n is 17. So I claim that on the 16th year, which is when we do power 15, this will be less than 65,000, whereas on the next one, 16, yes. So this is right. I'm sure of it. And then find the total profit for the first 20 years of trading, giving your answer to the nearest 1,000. Oh god, yeah. So what's the formula for this again? SN is so I'm gonna actually use the formula book for this because I don't think this is anywhere near. I think it's actually A minus R for a start. Let me just get the formula book up because so
Yeah, I think it's A minus R.
yeah, but I'm still.
Oh no, yeah, not quite.
Yeah, I need to get the formula book anyway because I'm going to need it for the other papers because there's a lot of useful stuff in there. So A-level students, they do get like a formula booklet that's just got a lot of these little bits of things in there. So live stream formula book. Let me just get that up there because I'm going to need this. I really should know it. I think when I see it, I'm going to kick myself. Yeah, it's A times 1. That's it. Yeah, I told you I'd kick myself. Over 1 minus R. Yeah, just very, very wrong. So S20 is
Just to double check, is it r to the n or r to the n plus 1? I'm just not sure. I
yeah.
had some suggestions that it might be n plus 1, but they might be ahead of me.
Well, it's the question of like it's year, but the first 20 years is year 1 plus year 2 plus year 3. So I think this is fine. So 20,000, 1 minus 1.08 to the power of n, all divided by 1 minus 1.08. So 1 minus, sorry, 20. I can't type in n on my calculator. 1.08 to the power of 20 all over 1 minus 1.08 equals 915,239.29. Is that right?
And then just
I-
reread the question.
Oh, round it to the nearest bloody thousand. Yeah, okay, 915,000. Yeah.
Also, units. Also, sometimes nice to have.
I stuck the pound sign in there. Don't bring your financial maths in here. But thank you. Yeah, the pound sign is important. Okay, so bit of vectors now. Thank God, changing it from some profitability, some rubbish. No fellowship. Sorry, that was actually the pound sign, just written in a terrible way. It was that, but just yeah, written in a hurry. Right. So AC is going to be just well, we're going to go A to B plus B to C. And the first thing I always do in these questions, AB is minus 3, minus 4, minus 5. And BC is 1, 1, 4. Because who on earth has time for this I, J, and K nonsense? So when we add those, we get that. Minus 2, minus 3, minus 1. That's AC. And now question B. Show that the cosine of ABC is 9/10. Now, this is interesting. So the dot product is what I think we should use here. However, that isn't actually taught to students at this level. I think it's on the further maths spec. So what is it actually expecting me to do is to use the cosine rule. That's I think is what it will be expecting me to do. But I think I'm going to do it the dot product way. Well, it's actually not that much more or less work, is it? But so cos theta is A dot B over the length of A times the length of B. So I'm going to do it this way. So if it's AB and BC, so we know that BC is 114, and we know that BA is 345. So if we dot these things together, so I'm dotting this one and this one, then I get 3 plus 4 plus 20, all over, so the length of that one is 1 plus 1 plus 16 is root 18, and the length of that one is 3 squared plus, that's going to be root 50, that's 3, 4, 5 triangle. This doesn't look good, actually. What have I got wrong here? Because 18 times 50, oh, it is 900, which roots down to 30, that's good. I was scared I was going to get a root there. And then 20 plus 4 plus 3 is 27, which is, of course, 9/10. So, might not be the way, if you're looking in the mark scheme, it might not be the way that's advertised.
No, the mark scheme will give you, has that for the cosine rule. It also outlines the dot product as well.
Yeah, because at this stage, like, it's not actually on the A-level spec, but the great thing about the A-level is always that it's always like any valid method. So if you happen to know something that you're not supposed to know yet, you don't get punished for it. You can do whatever you want, which I think is the approach to mathematics that we should all take. Right, so find the coordinates of the center. Right, so we just need to complete the square here. So that's going to be y plus 2 all squared. And then we're going to get a minus 25. And then we're going to subtract 4. And then we're going to add 11. So this is equal to 18. So therefore r is equal to root 18. As a simplified, so it is 3 root 2. And the center is 5 minus 2. Kind of answered those questions in the wrong order, but who cares? Now, the line L has that equation. and L is tangent to C. Right, okay.
Oh, Rhinox, thank you very much for the £100 donation.
Oh, wow. Awesome. Rhinox, thank you. Thank you
That's
so
brilliant.
much. Yeah, that's absolutely fantastic. We're getting very close to this goal.
We are.
I reckon we're going to get there. But yeah, thanks so much for that. I really do appreciate it. We've had some like really amazing donations coming through after the stream started, which has been absolutely terrific. Okay, so I'm going to just draw a quick sketch of this. So how big is that? That's about 4. So it's going to be something like that. I always just like to visualize what's going on. Now y equals 3x. There's a steep gradient. So the reason it's asking for multiple answers is because there's actually 2 tangents with that gradient, that tangent to the circle. So we're basically asking to find that, and we're asking to find that. Right, so how on earth are we going to do that? Well, they meet the circle. So we can put in 3x plus k into there. That's how we'll do it. So x minus 5. In fact, let's get that re-expanded because we're going to bring that out in a second. So that's that, and then we've got plus 3x plus k plus 2 all squared is equal to 18. Okay. Might just do some work down here. So x squared minus 10x plus 25 plus 9x squared plus 3kx plus 6x plus 3kx plus k squared plus 2k plus 6x plus 2k plus 4. And that apparently is equal to 18. Almost got it all on one line. Right, so how much x squared have we got? We've got 10x squared. So that's that and that. Now, how much x have we got? So plus negative 10, 3k, a 6 and another 3k, and a 6. And now it should just be the constants. So I've got 25, a k squared, a 2k, that makes a 4k, and a 4, and a negative 18, and I'll set that equal to 0. Right, well, this is a bit horrible, isn't it? So what is going on? We've got 10x squared minus 10. Well, let's just use the calculator because I don't want to make mistakes at this stage. So this is 2 plus 6k. That's the coefficient of x, by the way. Yeah. And then plus sorry, I'm just looking back up at that, wondering if this was an easy way I could have done that. So 25 plus, plus 4 take 18 is 11. 11, are you joking? I don't want 11. Plus 4k plus k squared is equal to 0. Okay, now we can use the fact that because these are tangents, then we want there to be exactly one solution to this. And by that I mean exactly 2 values of k for which there is one solution, if that makes sense. So there'll be 2 situations. One value of k gives one solution. So there's going to be repeated roots, in other words. In other words, b squared minus 4ac is equal to 0. So we're going to get a quadratic within a quadratic here, because we're going to get 2 plus 6k is squared minus 4 minus 10 k squared plus 4k plus 11. This actually reminds me a little bit of my Fermat video that whole repeated root situation, which I didn't explain very clearly. I got a lot of comments about that, which I think was fair enough because I didn't really explain it very well. To be fair, I don't think Thermite explained it very well because I think what he was doing was a very bodge type of exercise. 24k plus 4 minus 40k minus 100 squared minus 160k 40 times 11 440 equals 0. Minus 4k squared 24 take 160 is minus 136. Oh, I wanted a multiple of 4 there, but it isn't, is it? Losing confidence in my answer. So 2k squared 68 plus 68k, that should be a k again, sorry, and 436, that's 218, plus 218 is equal to 0. Oh wait, that is a multiple of 4. Yeah, of course it is. So, k squared plus 39k, just a disgusting number, plus 109, even more disgusting, equals 0. Right, totally lost faith in my answers here. Giving your answers as simplified surds. So, we shouldn't have ever been expecting anything nice. So, let's use the calculator function, which is allowed in exams these days because it is basically just implementing the quadratic theorem. Although my calculator isn't clever enough to do that, so I'm going to need to do it the old-fashioned way. I really should update my calculator. A lot of my students keep laughing at me. So minus b plus the square root of 39 squared minus 4 times 109 all over 2. Why are you not giving it as a surd? You are better than this, calculator. 39 squared minus 4 lots of 109 is that. Oh my god.
Do you normally have to do shift equals on those kinds of calculators?
No, it should do, it gives surd first. I don't think I've done this right.
I think you're about there.
Yep. Yeah, your last line is good, so it's just getting the surd down.
Oh, 1085.
You might actually just have to write out the quadratic formula for this.
Minus 39 plus the square root of 1085 all over 2, and minus 39 subtract the square root of 1085. They are the answers?
I think you can factorize that down just a little bit more.
I don't know why my calculator is misbehaving.
Try the SD button. S to D button is the
No,
suggestion.
because it gives you surd first, and then you press SD to get it into the decimal. Why is my calculator like not? Because for example, if I typed in root 8, it would give it to me as 2 root 2. I think the number might just be too large. It's struggling.
Possibly. You should still be able to work that out though.
Yeah. Okay. So 1085. It's not a fact. 25 doesn't go in. Well, let's just get it. I'm sorry.
Doesn't 1085 go in? No.
25 doesn't know because it's 5 times 217, which looks pretty prime to me. It doesn't simplify.
It does. Mizard's right on it.
The show is working.
No, it doesn't. If this line is correct, then that doesn't simplify. So it must be the case that this line is wrong. Yes, it is wrong because that is not 39, it is 34. So I knew it. We must be making a mistake somewhere. So 39. Sorry. The square root of b squared minus 4 of 109 is 12 root 5. Right. So minus 39 plus 12 root 5 over 2. Oh, sorry, 34, isn't it? And then minus 34 plus 12 root 5 over 2. Right, so what I get is minus 34, sorry, minus 17 plus or minus 6 root 5. Yeah?
Yep.
Right, thank God. That was a lot of work for 5 marks, really. And I don't really think there was a quicker way of doing it.
No, the Inception music was like starting to creep up throughout the entire.
Yeah. I mean, I'm thinking about, could you have found this here and then said that these are perpendicular lines and done it that way? But I don't think you could, because it's not obvious what these. Or could we have differentiated this, found the point at which the gradient was 3, and said they are where it meets the line, and then, deducted the right amount to get the intercept. I think that might be another way of doing it.
It is. It's just as involved.
Yeah, I mean, I don't think it's. I mean, it's again, I'm giving you a lot of paper here. Right, so a scientist is studying the growth of 2 populations of bacteria. The number of bacteria n in the first population is modeled by that equation. Right, it's always bacteria, isn't it? Or it's like animals in a habitat. So there are 1,000. Okay, let's just get these initial. So t equals 0, n equals 1,000. It took exactly 5 hours for the population to double. So t equals 5, n is 2,000. Find a complete equation for the model. Okay, well, a equals 1,000. That's the initial. And then 2,000 is equal to 1,000 times e to the 5t. So e to the 5t is equal to 2. And that means t is equal to log 2 over 5. I wonder if they want this as a decimal. .139. Let's sorry, t. What am I saying? K. K is this. So the answer, n is 1,000. E to the 0.139 t. Let's just check that.
Either way is good.
139 times 5. Yeah, that's close enough to 2,000, isn't it? Okay, hence find the rate of increase in the number of bacteria in this population exactly 8 hours from the start of the study. So we want dn by dt at t equals 8. So dn by dt is 139 e to the minus 0.139 t, which is equal to 139 times that times 8, which is 422 to 2 significant figures. That is when t is equal to 8, by the way, and this is approximately to 2 sig figs 420. And there's another number that makes all the students laugh. Fantastic. Children. Alright, so the number of bacteria M in the second population is modeled by that, where K has the value found in part A, T is time hours, given that T hours after the start of the study, the number of bacteria in the 2 populations was the same. Right, so 1.4 times 0.139. Let's just get our heads around what that exponent is there. So what we're saying is 500 e to the 0.195 t is equal to 1000 e to the 0.139 t. I think that's what we're saying, isn't it? T equals big T here. I'm not going to write big T. I don't care. So if we choose to do this, and then if we do that, subtract 0.139, then we get 0.056. So e to the 0.056 t is equal to 2. And then again, log 2 over 0.056 is equal to t. So log 2 divided by that. 12.47 hours. I haven't forgotten my units this time, Dan.
Yeah, no, yeah, that is good.
Perfect.
Thank you, Anonymous, to the 40 for the £40.
Excellent work. Thank you very much. We are getting very, 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 very close. Thank you so much, whoever you are. Anonymous human. I'm really tempted to make that joke about the hacker group Anonymous again, but I don't think it was very funny the first time.
Well, I do think it's terrific that that hacking groups do support STEM charity work.
Yeah, mental health. Yeah. Right. This looks like a meaty question. This is going to be some heavy algebra stuff. Find the value of b and find the value of c, and then show that a is 0. Okay, so it's partial fractions time. 50x squared plus 38x plus 9 is equal to, now when we multiply up, we'll get a, 5x plus 2, 1 minus 2x, plus b, 1 minus 2x, plus c, 5x plus 2 all squared. Yes. Yes. My mind is spinning with trying to do this algebra in my head, but let's just be sensible. So minus 10x squared, take 4x plus 5x plus x plus 2 plus b minus 2bx. I can expand that out. Plus c, 25x squared plus 20x plus 4. So this is equal to, how much x squared have I got? I've got minus 10 and I've got 25. So let's just call that 15. No. That is minus 10a, and that is 25c. Lots of x squared. Now, how much x do I have? Well, I've got a of it from here. I've got minus 2b of it from there. And I've got 20c of it from here. Lots of x. And then the constants on the end, I've got a plus 2a plus b plus 4c. Did I account for that? Yeah, I did. I didn't take it off. b 4c. Okay, now what does this have to do with anything? I've got minus 10a plus 25c is equal to 50. In other words, we can simplify that a bit. That's minus 2a plus 5c is equal to 10. I've got the a minus 2b plus 20c is equal to 38. And then I've got 2a plus b plus 4c is equal to 9. Okay. Let's eliminate b from this pair. So if I've got 4a plus 2b plus 8c equals 18, and I add these together, I get 5a plus 28c is equal to 38 plus 18, which is 56. Yep. Which means that 10a plus 50, is that 56? God, I'm just doubting everything. 56c is equal to 112. And I've just done that because I'm going to use the original form of this. Minus 10a plus 25c. Ooh, this doesn't look nice. Equals 50. We add those together. 25 plus 56 is 81. Ah, yes. This is good because that 112 plus 50 is 162, which therefore means that c is equal to 2. I don't know who's trying to talk, but the comms are pretty garbled there. Sorry.
I don't think there was anyone.
All right. Well, I was hearing something. So if we plug c equals 2 into there, I get minus 2a plus 0. Sorry, plus 10 is equal to 10, and that implies that a equals 0. So we've done that part. Now, what about b? Well, I've got 0 minus 2b plus 40 is equal to 38. So b is equal to 1. Let's just check it on this one. So 0 plus 1 plus 8 is 9. Yeah, I think there's some crackling coming from somewhere. So B is 1, C is 2. Are you doing the washing up again, Ollie? Some
I am not.
That's usually what it is. All right, so again, a bit of a meal of a question. Oh, and we're still not done because it wants us now to. Oof.
Part A.
Oof, God. Yeah, this is a chunky question.
Part AI.
Mm-hmm. Yeah, we found B as 1, C as 2. Yeah, okay. Binomial expansion. So basically we just need to expand, this is B, this is 5x plus 2 to the minus 2. Let's just deal with this one first, and then we'll deal with the C case. So we need to expand that up to and including the term x squared. Okay. So this, the way I like to do it is like this. 5 over 2x plus 1 all to the power of negative 2, which is a quarter of 5 over 2x plus 1 all to the negative 2. And then we can invoke the binomial theorem on that. But it's not pretty, is it? It is not pretty. Well, I mean, that's just the way it is. So a quarter of. Oh God, what's the binomial theorem? Is it 1 plus 5x over 2 plus 5. Oh, I can't remember. 5 over 2. 5 over 2 take 1 x squared. This isn't right. What am I doing? No, this is so wrong. It's a quarter. 1 minus 2 5 over 2x plus minus 2 minus 3 over 2 factorial 5 over 2 x squared plus other terms of higher order that we don't need. Bit more confidence in this. Yeah, it's 1 plus nx plus n times n minus 1 over 2 factorial x squared plus n minus 1 n minus 2 over 3 factorial x cubed. Pretty sure this is right. So this is a quarter. 1 minus 5x. Let's just stick all this gubbins in the calculator. So 2 times 3 over 2 times 5 over 2 squared. What does that come out to be? Of course, it comes out to be something appalling. I was hoping that would come out to be something nice and plus higher order terms. And let's now fold that quarter back in there. Quarter, take 5x over 4 plus 75x squared over 16 plus some higher order terms. Okay, that's the first one. Now for the second one. Kill me now. So we've got 1 minus 2x. So C, so this is 1 minus 2x to the power of minus 1. Now this is actually, I'm actually just going to rewrite this a little bit, because I just, in my head, I want it that way. 2x minus 2x plus 1. Now it's already plus 1. The reason, if you don't know, we had to get the plus 1 there is because to invoke the binomial theorem says things about basically x plus 1 all to the power, and associated, this is the generalized binomial theorem, not the the usual kind of a plus b to the power of a positive integer. You need it in that form before you can invoke that theorem. So anyway, and this is all to the minus 1. So this is 2 of so 1 plus n x plus n minus 1 over 2 factorial x in inverted commas squared. So this is 2. Let's leave the 2 on the outside for the time being. This is going to come out to be something a little bit nicer. 1 plus 2x. So that whole term is just nothing. So that is just 1 times 2 divided by 2. And then that is 4x squared. That's a bit more well behaved than the other one. So this all in all is 2 plus 4x plus 8x squared plus some other terms. I was surprised to see all of the minus signs cancel, but it's usually alternating or they're all positive. Maybe all negative sometimes, I don't know. Yeah, there's probably situations in which they're all negative if both of these are negative. But yeah, I think that's always the case. It's either alternating or they're all the same sign. So now when we add, let's call this one alpha, and let's call this one beta, then alpha plus beta. So we get 2 plus a quarter is 9 quarters. And then 4 subtract 5 over 4. So plus 11x over 4. And then it's 8 plus 75 over 16. $203x squared over 16. Can I have a check on that, please?
That looks right to me.
Perfect. Thank God. I'm not doing it again. Well, you know what? It wasn't too bad, actually. There wasn't that much work there. I think there was less work that went into that. Oh, yeah, getting a couple of comments. Yeah, that's all 1, obviously. A 0 as in there's nothing there, but that's really not correct at all, is it? Yeah, I mean, when all said, I think there was more work that went into that circle question for fewer marks, whereas that isn't actually a huge amount of work for 7 marks. It probably took me about 7 minutes, which, is sort of the ballpark of what you should be aiming for. Solutions relying entirely on calculator technology are not acceptable.
Sorry, Alex. I think there was a part 2 to that the question.
Dan, what are you doing to me? Oh, okay. Well, maybe we didn't do quite enough work for 7 marks. Oh, Dan, I don't like you sometimes. But no, you are right. Thanks for keeping me honest.
There has to be someone here that's keeping you honest.
Yeah, yeah. Okay, yeah. Ollie has just realised that he's still on mute. That is That's classic, isn't it? Uh, so, oh, sorry, yeah. So for people who've just joined recently, the Australian sounding guy is Dan, and the
Hello.
guy that you can not hear is Ollie, which is a bit of an oxymoron,
Hello.
but yes, who is British but doesn't sound like me because he's from the south. I think you sound more stereotypically British than I do. Although I don't know actually. Having said that, I think Game of Thrones really did a lot to Game of Thrones and Sean Bean's career did a lot to kind of popularize how northern people sound. Um,
For sure.
I think there's a story actually. Apparently, when they were shooting Game of Thrones, they got all the actors together, and they asked like, "Oh, what accent should I do? Because I'm a Stark, I'm from the north, or anything like that." And apparently, they just looked at Sean Bean and said, "That guy. Follow him around and talk how he talks. That's how we want you to sound," which is just great. I love that story. Anyway, sorry.
Yeah, he really was made for that role. I think he was also told to tone down his Yorkshire accent for the show,
Yeah.
so that other audiences would be able to understand it.
Yeah, he's pretty broad at times.
Very broad.
Yeah, but so right, the range of values for which these are valid. So in other words, we have to have that 5x is less. Sorry, I always get this wrong. So in x plus 1, you have that mod x is less than 1. So I think mod 5x is less than 2 is what we're going to say. So that means 5x has to be between minus 2 and 2. Yeah, so mod x has to be less than 5 halves. I know some people can probably just look at this and do it in their head, but this is one of the things that when I was a student I always made mistakes on. So I always try and just make sure. And then mod 2x has to be less than 1 here, which I think is going to give a tighter constraint. So this implies minus 1 is less than minus 2x is less than 1, which implies that 1 is greater than 2x is greater than 1. So divide through by 2. Yeah, mod x is less than half. So that is my answer. The size of x has to be less than a half because that's more restrictive than this one.
I think the first one is not quite right because you've got the mod x needs to be divided by 5.
2 over 5, Jesus. Yeah, so this is my answer. This is the tighter constraint because 2/5 is less than a half. All right. All right, you happy now, Dan? Yeah.
Yes, you may now move on.
Thank you.
We are taskmasters.
Yeah. No, I mean it's good because honestly, if I'd have let that go, then it would have been comments for hours on. Oh well, you're not really doing 24 hours of 24 maths papers because you're not answering every question. So it is totally fair. Right. So we've got a trig identities question now. Now usually I'm pretty good at these. However, this looks pretty mealy. So what do we know? We know cos 2 theta is cos squared theta minus sine squared theta. And we know that sine 2 theta is equal to 2 sine theta cos theta. So, let's see what happens. We've got 1 minus... does anyone else do this, by the way? You want to open bracket and then write cos, but then your brain thinks, we've done the c for cos by using the open bracket thing. Maybe it's just me, I don't know. Minus sine squared theta plus.
I think I've just gained a complex.
Yeah, you're gonna do it forever now. 2 sine theta cos theta over 1 plus cos squared theta. Plus, minus sine squared theta plus 2 sine theta cos theta. Don't know why I'm switching the order in which I'm writing them. And what happens here? Well, we're going to use sine squared plus cos squared equals. I think I can see this. So 1 minus cos squared theta is actually sine squared theta. So That is going to become plus sine squared. So 2 sine squared theta plus. I think I've seen the answer already in my head, because we're going to factor out the sine, factor out the cos, divide, and that's going to be 10. 1 minus sine squared theta is cos squared theta. Add that one is 2 cos squared theta. Plus 2 sine theta cos theta. And now if we pull out a sine from the top, we get 2 sine theta plus 2 cos theta. And if we pull out a cos from the bottom, we get 2 cos theta. Hang on a minute, this doesn't look good. Oh yeah, plus 2 sine theta. So they are actually the same, written the other way around, which is of course tan theta. So QED. B, hence solve that. Right. So these things are the same, except theta is equal to 2x. And therefore that whole thing is just equal to tan 2x. So tan 2x is equal to 3 sine 2x. Sine over cos equals tan. That means sine over tan is equal to cos. So 1/3 is equal to cos 2x. And that means that 2x is equal to the following. Arc cos of 1/3. And I probably need to be in radians here. Oh no, sticking to degrees. So giving your answers to 1 decimal place. So let's do 70.53. I always need to draw a graph for this, just to get my head around the where these solutions are. So if we're at 1/3, we're about there, aren't we? So that's 70-ish, and that is 90, and that is 270. So if I find the difference between them, that distance there is about 19, which we shove over there, so add that on to 270. So this is, and I probably don't need this solution actually. Because now when I divide by 2, I'm going to get 35. So this one, I divide by 2, I get 35.3. And I think this one divided by 2 is not in the range. Oh, it is. Of course it is. What am I talking about? For some reason I was reading that as 389. So let's actually do it properly. 0.47. Sorry, a bit of a brain fart from me. 144.7. Happy?
Yep.
Thank God. God, it's a lot tenser knowing that there's someone who could actually just jump in. I mean, everybody in the chat has been pretty on it, to be fair.
Yeah, and I would just like to remind everybody that normally you wouldn't, if someone was taking an exam like this, there wouldn't normally be so many people watching.
Yeah, that is true.
Watching.
Yeah. Just a little comment about the outside of the range, because we're dividing by 2. That one actually enters the range because it is between 0 and on 180. Pictures in the background are the Cornetto trilogy, which is a series of films by Edgar Wright. They are absolutely amazing. They're like comedy films, but like Shaun of the Dead, the first one, is like it's like comedy horror because it's like a spoof of a zombie apocalypse. The Hot Fuzz is like a comedy action film. And The World's End is like a comedy sci-fi film. And so they're all like riffing on different genres. And they all have like, it's the same group of people that appear in each one. So the what you call spiritual sequels of each other. You know, same themes of, you know, people struggling to grow up. They're all incredibly funny, incredibly British. I just absolutely adore them. They are so good, and I adore these posters as well. They were like a limited run by this. I can't remember the artist's name, but God, it was a real chore to actually get my hands on them because I think there were only 70 ever printed, and I had to find. Luckily, someone was selling them on eBay, so I managed to get my hands on them. I just absolutely love them. Such good films. So good. Oh, it's the trapezium rule. I hate this. I hate it. I hate it. I hate it. We've already...
We believe in you. You can
Oh,
do this.
yeah. Right. So... Oh, I don't want to do it. It's so tedious. Right. So it's 0.5 over 2. And then what do you do here? Do you add the first two, the first and last together, plus 1.9218, and then add 2 of the rest of them? It's not 0.5 over 2, is it? I'll fix that in a second. Oh no, I think it is. Because your trapezium formula is that. So that's your h over 2, and then you've got all your a plus b's, but the middle ones, they double up. Because they'll appear twice if you added up all these trapezia individually. At least it's not like the old days where you'd actually need to sit there and compute these values first. They usually give them to you. It's just such a blag. Right, I might just check that trapezium rule formula. I think it's right. It makes sense to me, but I'm just before I go through all of the rigmarole of putting it in the calculator. So it's half h. Where h is b minus a over n, and we have got that's right, and then it's first and last plus 2 times the rest. Okay, so 0.5 over 2, it's obviously a quarter, but let's just 0.4805 plus 1.9218 plus 2 of 0.8396. Don't know why I'm reading the numbers out as I go. 1.5694 equals 2.41 to 3 sig figs. The really frustrating thing about the trapezium rule is I think y equals log x all squared. That's something that we could just use calculus to work out. The trapezium rule is used obviously if it's a function for which you don't know how to like integrate it. Oh yeah, and then the next question: use integration to find the exact area. So there we go. I do actually need a bit more paper for this one. I try and get the point is we're integrating the goal here is to integrate log x all squared dx from 2 to 4. So that's the integral that we're going to evaluate. So how are we going to do this then? Let's try a substitution of u equals log x. Then du by dx is 1 over x. And then therefore dx is equal to x du. And x is e to the power of u. So, and we've got I think this is going to work actually. I'm quite bad at deciding which method to use. I don't know if anyone else has this sort of experience. I think this is going to be by parts from here, and it's going to be by parts within by parts, which is telling me I didn't do it the right way. I think the right way to do this might have been to do by parts on log x times log x. That's usually a trick that can happen with by parts. So, let's do it this way. So if we do u equals u squared, terrible notation, I apologize. And then our dv is going to be e to the power u, and v is e to the power u, just for the sake of the by parts formula. So this, I'm going to just forget about the limits for the time being. This is u squared e to the power u, subtract the integral of 2u times e to the power of u du. And that's where the second by parts comes in. So u squared e to the power of u, subtract 2, lots of the integral u e to the power u du. Now, again, we let u equal u, du equal 1, v equals e to the power u, sorry, that's dv, and then v equals e to the power of u. And then this is u squared e to the power of u, subtract 2 lots of u times e to the power of u, subtract the integral of e to the power of u du. And that should give us the actual thing for which we'll plug in the limits. So take 2u e to the power of u plus 2 e to the power of u between 2 and 4. So 16 e to the fourth I've made a substitution here, so actually these limits change. And what I'm thinking actually is, I think maybe, just maybe, we'll actually put this back into log, because the final answer wants these logs involved. It doesn't want a decimal. So let's actually, this is incorrect. Let's actually put these back. So this is actually log x squared e to the power of u is x, take 2 log x plus 2x, which is looking pretty healthy, actually. I've got confidence in this. Watch me screw it up now. So this is log 4. Now this is between 4 and 2, because we've recovered the original variable. So log 4 squared times 4, subtract 2 log 4 times 4 plus 2 4s. I'll tidy it all up later. Subtract log 2 squared times 2. Take 2 log 2 times 2 plus 2 of 2. Right, so how many logs? Well, actually, oh, this question doesn't end because we're going to have to really think about this. So this is going to be 4. So this term first. Now this is log 4 squared, but I'm going to write that as 2 log 2 squared. Yep, that's fine. Minus, so 2 times 4 is 8. Another 2 will fall out to get 16 log 2. Plus, so I've dealt with that. 2 times 4 is 8. 2 times 2 is 4, so 12. That'll end up on the end. Now I'm subtracting 2 lots of log 2 squared. Subtract 4 log 2, and that deals with these two terms.
There may be a sign error in the substitution.
Oh yeah, 100%, because we're subtracting that, which means, yeah, good spot. Good time to get that in, because I usually like to get to the end, but actually this is a trivial matter, so that's actually going to be a plus 4 there. That'll be a subtract, and that'll be a plus. Yeah, that would have been a pain to fix back a little bit later, so thanks for pointing that one out when you did. So 2 squared is 4, times 4 is 16, subtract 2 is 14, so that's 14 log 2 squared. We've got minus 16 log 2, plus 4 is plus 12 log 2, plus 4. And how is that?
Yep, that is spot. Minus 12.
Oh, sorry. Yep, minus. Yeah, minus 16 plus 4 is minus 12. Yeah, okay. Nice. That was good, actually. I felt confident all the way through that. That was, yeah. Just seemed to know what I was doing. Sometimes, because calculus, you will probably become aware, people watching, calculus isn't really one of my strengths. Although, having said that, I've got a lot better at it since I started teaching, because you've got to do a lot of it. And you've got to also, if you want to get good at something, teach it to a class of 30 people, and then watch how they get it wrong in 30 different ways. And then you have to quickly analyze and diagnose where everybody is going wrong, and that you get really quick at stuff when you do that. Right, well, we've got a whole essay here. Yeah, so calculus isn't really one of my strengths, to be honest. I think both of you two are probably better at calculus than I am. So sometimes I get the complete wrong intuition with how to actually deal with this. And I still don't think this was the cleanest way of doing it, because you had to do a substitution, then a by parts, and then a by parts, which is a lot of work, really. I think there might have been a cleaner way of doing that.
No, this is an ugly one.
Yeah, a bit of a...
100%. For 5 marks, they're going to make you work for this.
Yeah, but 5. I had, there was 7 marks for that binomial expansion question. Well, this looks like a trajectory to me, and it is. A golf ball has been hit. Right. Well, this is interesting because this is like a mechanics question, but I wonder if we're going to do some calculus on it, because they don't really like to cross-pollinate the calculus with the mechanics all too much. So it's the trajectory of a golf ball. The vertical height, h meters of the ball above the ground, is being plotted against the horizontal distance traveled. The ball is modeled as a particle. Yep, it's hit from a platform 3 meters above the ground. I'm sorry, where are they hitting this golf ball? This is like a scene on a film, where they're playing golf off the rooftop or something like that, and they're just hitting it into the into an old abandoned industrial unit, like on Fight Club or something. Like, what's going on here? I don't really watch golf, so maybe this is what happens these days, but it reaches a maximal vertical height at 90. So this is the apex, and that's at 90. Its vertical height is 27 after it's gone 120. So let's get that in there. So that height is 27. H is a quadratic, which if you're neglecting air resistance, it is. Find H in terms of X. Right. Okay. Well, suppose this is fine. So we've got, where's my pen? Let's just try and, so obviously it's of the form ax squared plus bx plus c. This is h of x. And we know that the c is 3, so ax squared plus bx plus 3. And then we've got some conditions here. So we know that 27 is equal to, oh my god, 120 squared a plus 120 b plus 3. Do you want to make it more awkward, or are you alright? Actually, this is okay, because we get 24 there, and then we can actually divide through by 24, so maybe I spoke too soon. So 120 squared divided by 24 is 600 plus 5b. So that gives us one equation. And then what are we going to do? So we need to use the fact that we've got the apex. Oh yeah, of course. So the h dash of x equals 0 when x equals 90. So 2ax plus b gives us 180a plus b is equal to 0. Let's times that through by 5. 900a plus 5b is equal to 0. And then this other one was 600a plus 5b is equal to 1. And this gives us that 300a is equal to negative 1. Now, this is annoying because it's a big horrible fraction, but it's also good because we are expecting a to be negative here, because this is an inverted parabola, which means the coefficient of x squared must be negative. So a is minus 1 over 300, which is just kind of gross, but I guess we'll just have to make peace with that. And then if we put that into there, minus 2, so b equals 3/5, I think. Let's just check it against this one. If I do 180 divided by 300, and then yes, that's negative 3/5. Yeah, okay, so I'm happy with that. Okay, so that's the answer. So we've got minus 1 over 300 x squared plus 3/5 of x plus 3. That is our function of h. Right, now what's the next part of the question? Find the maximal vertical height of the ball above the ground. Well, that literally is just h dash of 9. No, it isn't. It's h of 90. Sorry if the paper's kind of sliding off screen. I'm kind of low on. I'll try and just move that to a good position there so you can see everything that's going on. I think that just about covers it. So if we stick 90 in there, that will give us the maximum height. So let's do 90 equals, and then we'll do minus 1 over 300 of that squared, plus 0.6 of that, plus 3, 30. Oh, and what a nice answer. That's nice. That gives me a bit of confidence. Okay, and then the horizontal distance traveled by the ball from where it was hit to when it first hits the ground, giving your answer to the nearest meter. So we're basically being asked to find the root. Well, there'll be 2 roots, but one of them will be negative. This, if we invoke the formula, so let's just do this. So minus 1 divided by 300, 0.63. We get x is 185 meters to the nearest meter, and minus 4, minus 5, let's say, which is good. I wanted one very big, and I wanted one very small, because down here, if you follow the curve there, that's a very small number, negative 5, and much bigger is 185. So I think 185, is that right? So from when, yeah, okay. Not too bad, really. And then C is just a wordy one. The possible effects of wind or air resistance are 2 limitations of the model. Give one other limitation of the model. Well, what have we assumed? We have assumed, well, the ball has been modeled, so a golf ball is not actually a particle. Let's say that. Usually, you just read the question again, find any point at which you've made an assumption, and just write that down. So, all right, correct on that one, guys?
All perfect.
Excellent. I enjoyed that one. That felt a lot like a mechanics question. However, question A, I suppose, was more of a pure question, really, because devoid of context, this is just, here is a quadratic with some conditions, derive its equation, which is quite pure. All right, thanks, Lucky Spades, for joining. Have a nice dinner. Well, I'm interested. What else did they write for 12C? Because I'm struggling to see what else I would have written for that.
We had the ground is unlikely to be horizontal.
Oh yeah, it might not be a vertical plane. It might actually skew from side to side as it flies.
Mm-hmm.
As it will spin.
Yeah. Well, that's the particle nature of it, I guess. That it's like it's a point object with no spin, but yeah, it will have the what is it, the Magnuson effect, where a spinning thing kind of arcs. Yeah. Any others?
Curvature of the Earth from the that's not one of the
I was gonna say.
But I mean, I'll take it.
Yeah. Also, you didn't take into effect the Coriolis force.
We also had H is not likely to be a quadratic function in X.
Ooh, that's. I mean, it's
just
true.
Like a bit of a meta.
Well, yeah, but because if you model without air resistance, it is quadratic. Because usually a trajectory looks a bit more like that. Actually, it's like an egg, like a half egg sort of shape. And that's why the theoretical maximum distance is at 45 degrees, but actually it's a little bit lower than that. I think it's something like 40 degrees, because you want to give it a little bit more horizontal oomph. That's the correct terminology, by the way. Yeah, that's a bit of a weird, because that's the whole. I suppose it is a limitation of the model, but yeah, it kind of feels like that's the same thing as the air resistance point. But never mind.
Yeah.
Right, so we've got some parametric equations. Now, usually I like these questions, but I don't like this one. Because usually I like doing the whole dy by dt business and all that kind of stuff. But this one looks a little bit nasty, actually. So, shall we see what we've got? I was going to jump in and rearrange this one, but my gut is telling me this is the wrong one. Even though it looks simpler, I don't think we can actually isolate t here because we've got a squared t and a linear t. Let me just write this down. We've got that, which you can't really. It's an implicit function in t, really. I don't think you can. But this looks even worse. But both of these are squared. So let's try it. Xt squared plus x is equal to t squared plus 5. So that means that t squared x minus 1 is equal to 5 minus x. If we whip that over there, and then t squared is equal to 5 minus x over x minus 1. And that means t is equal to, surely we don't want to start, as soon as you start rooting things, you're in trouble. So, let's square y, and then we get 16t squared over t squared plus 1 squared. I think that's the cleanest way of doing it to avoid the roots, and we are going to need y squared anyway. Although it looks quite complicated. Let's do this piece by piece then. So let's actually work out what t squared plus 1 is. So 5 minus x over x minus 1. And if we're adding 1, another word for 1 is x minus 1 over x minus 1. That's our old friend, the adding 1, like adding 0, adding 1, that type of thing. Actually, this is nice because the x's die, and then we get 5 subtract 1 is 4 over x minus 1. And then we need to do t squared plus 1 all squared, which is equal to 16 over x minus 1 squared. And I'm going to leave it at x minus 1 squared. I'm not going to expand it because I actually like where this is going, because we've got a 16 there. Why did I want 16? Why did that feel good? Oh, it's because we've got that 16 there. Okay, so let's put it together now. We've got 16. Sorry, I should say this is y squared is equal to 16 lots of 5 minus x over x minus 1 over 16 over x minus 1 squared. This is not looking too bad, actually, because now we get 16, 5 minus x, x minus 1 all squared, over 16 x minus 1, and now some fireworks. They go, and they go. We get that, which is minus x squared, plus 5x plus x is plus 6x, subtract 5, and that was y squared. So let's just put it all together. Yeah, this looks perfect, because we've got the plus 6x, which when we complete the square will become a minus 3. So y squared plus x squared minus 6x is equal to minus 5. Ooh. No, it's fine, because when we complete the square, another another number will pop out. So x minus 3 all squared, subtract 9, so add it onto the other side, and we get 4. Yeah, there we go. Oh, right, I actually I did end up enjoying that one. That was good. So, 14? Must be getting towards the end of this paper now. I feel like we've been doing it for ages.
I think this is the last one.
15, 2 more.
Oh no, there is a 15.
Yeah, there is a 15, unfortunately. Well, this looks pretty straightforward, actually, so that's fine. Although it looks like the font has changed. Anyone else feel like the font has changed there? What am I detecting? I feel like that 2 is a different 2 to the ones we've been seeing, and that 4 is different.
Looks more like...
And that is like a non-italicized... That's a backslash text X rather than a $X $. Whoever teched this up.
I'm going to try to just jump back in the video to see if there are any other 2s on the page.
Yeah, it's weird though, isn't it? Because I don't even know how you would do that. Because if you were to do this in tech, it's actually harder to create that than it is to just create it and it all looks properly. It all looks proper. It all looks proper. Is that the right way of saying it? I don't know. It sounds very northern. Anyway, so we're obviously going to use the quotient rule here. So if I do u equals x minus 4, and v is equal to 2 plus x to the half, then du equals 1, and v is equal to half x to the minus half. Okay, and then we do half x to the minus a half. That's our v times du, subtract u times v du, 2 plus x to the half, that's because I didn't label it properly up there, times du, which is 1, subtract u dv. All divided by v squared. 2 plus root x squared. Alright, and now it is tidy up time. So this is 2 plus root x, subtract. So x times x to the minus a half is just root x. But I am halving it. And then subtract 2 over root x all over 4 plus 4 root x plus x. This is becoming a little bit messy. How?
No, I think you're on the right track.
Yeah, is that 4? There's a 4 plus x down there that I don't want. I'm just thinking. I mean, that is the this is dy by dx, isn't it? So like, it must simplify somehow. Let's multiply through. I really don't like this. I'm just gonna check what I've done. U du v du subtract u dv. Can't see where I've gone wrong. I think I just need to stick with it. So 2 plus a half root x subtract 2 over root x. I think we're going to multiply up and down by root x at some point. And then this is 4 plus x plus 4 root x. I really don't like this. Everything in me is telling me that there's a mistake here. But Let's just stick with it. So 2 root x plus a half x minus 2. Oh, I know what's going to happen. I've spotted it. I know what's going to happen here. Let's write it this way. X plus 4 root x. Yeah, I've spotted it. This is a quadratic in disguise, as I call it. So this is now x plus 4 root x. Subtract 4. Just multiplying everything by 2 to get rid of that half up there. 2x plus 8 root x plus 8. Okay, now, if we were to factorize this into root x, still not going to... I've done something wrong.
I think you've dropped a sign. So it was minus 2 over root x.
Yep, that's that term, that's that term. I think that's fine. I think I've done the bottom wrong, though. It should be an... yeah, and again, I'm losing confidence in my... because I thought I'd spotted what was going to happen. So when I times through by root x... I didn't do this properly at the bottom. 4 root x root x plus 4x, which is just... I don't like any of this. Okay, and that is root x 4 plus 4 root x plus x. Okay, I think it is going to be the thing that I... Alright, so the point is, this is like a quadratic in root x. So that bottom is this. 2 root x, because I've times by 2, x plus 4 root x plus 4. You were right, Ollie. That is positive, that is positive, that is positive. So we don't actually need to factorize this. It actually just goes. So it is 1 over 2 root x. So what I was thinking was x plus 4 root x plus 4 becomes... you can do that as root x plus 2 root x plus 2. Because it's still... if you say like y squared plus 4y plus 4... like where y equals root x. That's why I call it a quadratic in disguise. It doesn't look like a quadratic, but you can treat it like one. But the same thing appears there and there, which I guess is what should have happened because all of the brackets sort of die. Yeah, I was getting worried there. I should have just like ignored what it said up here and just carried on. But I got a little bit too wrapped up in what I was actually shooting for and stressed myself out a little bit with that one. So the final question then, use proof by exhaustion, one of my favorite kinds of proof, to show that for all n less than or equal to 4. Oh, now this is going to cause arguments in the comments. I think we do consider the naturals to be the set containing the integers from 1 upwards, rather than starting from 0. In fact, that is definitely the case, because if we had n equals 0, then it would be 1 is greater than 1, which doesn't work. So they are considering n equals 1. So we need to check n equals 1, 2, 3, and 4. So that is 2, 3, 4, 5 cubed. And then on this side, we need to do 3 to the power 1, 3 to the power 2, 3 to the power 3, 3 to the power 4, which is 3, 9, 27, 81. And these are 8, 27, 64, 125. And yes, they all work. Now, given that that is odd, use by proof by contradiction to show, using algebra, that m is even. Okay, so assume m is odd. Therefore, m is equal to 2k plus 1 for an integer k. And therefore, m cubed plus 5 is equal to 2k plus 1 all cubed plus 5, which is equal to 8k cubed plus 12k squared plus 6k plus 1. Let's make that a plus 6 because we're bringing that 5 into play, which is equal to 2a for a in the integers. Therefore, m cubed plus 5 is even, and there is our contradiction. Therefore, m is even. And that's it. That is our first A-level paper.
Brilliant. Yeah, that was what do we think that was? That was 1 hour 30, 1 hour 35 perhaps.
Yeah, that seems about right. Well, I came back after not 16:10, but 17:10. So actually, yeah, and then we rambled for about 10 minutes. So yeah, about an hour 40, I think. That's yeah, a little bit longer than I would like actually. I'm usually between an hour and an hour and 20 on these A-level papers, but I'm pausing to kind of chat and check my answers and everything like that.
Yeah.
If I was rattling through it at top speed and probably making more mistakes, then I would probably do it a lot faster.
Bit of talk as well.
Yeah, a
Thanks,
bit
Baltic,
of
as
chatter.
well for the donation.
Baltic, yes, thank you ever so much. It all helps. Thank you so much. We really, really appreciate it.
And we're getting closer and closer to that £3,000 mark. That's really exciting.
It is exciting. Yeah, can't wait. Right, so it's the further maths paper next. Probably the paper that I'm dreading the most out of all of these, except possibly the other further maths paper that I've got, which I'm planning to do tomorrow morning. Now, further maths, the actual mathematics isn't any more complicated, but man, they love to throw some really hideous questions in there. So I am kind of dreading this one. It'll be good to get it out of the way. The other further maths paper I've got is so this is further pure 1. So in the UK, the exams are kind of separated into, there's the pure maths, there is statistics, there's mechanics, and there's something called decision maths, which is about kind of algorithms and a little basic graph theory and that sort of stuff. And we also now have the additional pure modules that you can do for further maths, which I really like because they bring in, a bit of group theory and a bit of combinatorial, a bit of stuff that you do learn when you do your degree, but you might not necessarily learn at the A-level stage, whereas now some of it's kind of trickled down. So I usually like those. That's why I think I'm dreading this one the most. But let's see how we do. So let's call this one. I'm just updating the exam counter here. So further maths A-level paper 1. Let's just call it A-level pure. Oh, and I'll do that there. That's fine, isn't it? Right then. So again, kind of dreading this one. So let's get into it. It'll probably start gentle like the other one did, but it gets tough. I'll warn you. It gets tough.
For those who do mathematics as either as a profession or as a sort of in-depth hobby, this is one to really consider for everyone. Like I'd say, get involved. You may need some help.
Yeah, yeah, absolutely. I mean, I'm kind of trusting that you're reading the chat and everything like that. If there's anything interesting on there, there is. because I'm kind of so engrossed in this that thanks for pointing out the
Yeah.
donations and everything like that. I find it quite hard to keep an eye on the chat as well. Not that I'm ignoring anyone. I do look up to to try and read for comments and things like that. But yeah, so yeah,
Trying
if
to solve, at the moment, we're trying to solve a different kind of birthday problem. So
right,
don't
okay.
worry. You are very welcome to
Yeah,
stay well engrossed into do the
yeah, do my job.
papers.
Yeah, so I noticed a few comments about the naturals. Yeah, I mean, I don't really have it. I used to stand that the naturals should start from 1, but I've changed my mind, and now I don't think there's a good option for where the naturals should start. Both are better in certain situations. There are situations in which it is really, really obvious that 1 is the best place to start, and there's many situations where it's really obvious that 0 is the clear best place to start. I should say we are still.
They should start at -4.
I know.
Yeah,
I just saw that. That's funny. Yeah.
one of the day, that one.
Yeah, maybe someone else chimes in. Naturals should start at tau, because that's the other fierce debate that we always have, don't we? Yeah, we still are kind of on our journey through mathematics here. Obviously, we've developed, so calculus was the main thing that we developed in the A level. I think there's quite a lot of calculus in that last one. Further maths. What's on further maths, Dan, that you don't see at A level? So obviously there's complex numbers that we just saw there. I think a bit of polar coordinates.
Matrices?
Yeah, a bit of matrices there, definitely on there. More vectors stuff, like a bit of light linear algebra. So yeah, matrices, vectors, that kind of thing. Proof by induction, I think, is on here actually. What else? There's all sorts of bits and pieces. Hyperbolic trigonometric functions. Yeah. Length of arc by integration, which is among the most difficult of the questions. But yes, let's get into it. So obviously the complex numbers here. So this is where we meet the complex numbers. It's kind of nice in a way, isn't it? Because at primary level you meet the naturals, and then a little bit in key stage 2 it was the integers. Key stage 3 we saw a lot of rational numbers, and I think we did see a couple of surds. But GCSE you start dealing with pi and all sorts of surds, and then at this level it's the complex numbers. Maybe on the degree level paper we'll see the quaternions. I don't know. They've changed the syllabus since we took that course, by the way, so it's actually a different course now. So I'm actually really hoping that it's broadly the same stuff. So we've got a quartic complex valued function. Show all roots of f of z equals 0 on a single Argand diagram. I wonder if anyone in the chat can actually tell me the difference. What is the difference between an Argand diagram and just generally the complex plane? Because I see Argand diagram all the time at A level, and then we never see it again. We just call it C. We just call it the complex plane. I've never really understood if there's a difference. So obviously we've got real and imaginary. And now, obviously, these roots, they have, so we've got -1 plus 2i, let's say it's there, and its conjugate will be a root, and then 3 minus I and its conjugate. So those, and then question B is to find the values of A, B, and C, and already my heart is sinking because I can already foresee that this is just going to be an algebraic nightmare. But let's do it. So why is it going to be an algebraic nightmare? Because we basically have the factor theorem that tells us that because these are roots, then the factorized version of that quartic is the following. So -1 plus 2i. In fact, I actually don't think this is as horrible as it's going to be now that I think about it, because if we do it in this order, -1 minus 2i, the conjugate, these will actually multiply together to give something a little bit more manageable. And similarly over here, so z minus 3 minus I, and z plus 3 minus, minus I, no, z minus 3 plus I. Sorry. Just a bit of a brain fart there. Now, let's do this. So, z subtract -1 plus 2i z. So that's those two. Subtract -1. I'm just thinking about which order to do it in. I don't know if there's a clever way of doing it. Plus, sorry, I'm kind of floundering a bit here just because I want to try and do it in a nice way. But now, because x plus iy, x minus iy is literally just x squared plus y squared. This is why this is a little bit nicer, because it just makes the expansion a bit easier here. So 1 plus 4. All right? Yeah. And then we're multiplying by... I'm going to actually just simplify this, because, again, this will simplify down a little bit more, because we're going to have z squared. Now, I think the imaginary parts will vanish here. So we've got plus 1 plus 2z, and then minus 2i plus 2i, so the imaginary parts die, and then we've just got the plus 5. So that, when all is said and done, is not too bad. And now let's deal with the other thing. So we've got z squared, 3iz, 3 plus I z. I could be doing this a bit quicker, but it's such a messy question. And then 9 plus 1. So z squared plus 2z plus 5. Z squared minus 3 minus 3 minus 6z. And then the i's cancel. And then we've got the plus 10. Okay, now we just got to expand this sucker. So z to the power of 4. And then how do we create a cubic? Well, we take minus 6 and then add 2. So minus 4z cubed. How do we create a quadratic? We've got 1. And then we've got, 10, because it's quadratic times linear, linear times quadratic, and then linear times linear. 2 times minus 6 is minus 12. I think I might have been saying the wrong words throughout all of that, but I think this is what I meant. So plus 3z plus 50. I think this is right. So that's A, minus 4. B is 3. I've forgotten something. That's squared. And I forgot about the linear term. So minus 30 is those two. And then plus 20. So minus 10z plus 50. How's that looking?
Looking good.
Excellent. Anyone give us an answer for the Argand diagram question?
So the Wikipedia has it down as that it is just another name for the complex plane, named after I think it's a French mathematician, Jean-Robert Argand, who was an amateur mathematician, who published the idea of geometrical interpretation of complex numbers.
Interesting.
Yeah, and is known for the first rigorous proof of the fundamental theorem of algebra.
Oh, right, okay. Yeah, I didn't know that, actually. There's loads of proofs of the fun theorem of algebra, as I call it, but
Well, it is.
it is fun. It is awesome, yeah. Yes. Definitely got that last one right. Just someone correcting.
Yeah.
Oh,
Yeah.
they're just discussing. Yeah, sorry. Okay, so yeah, and I'm sure someone will correct your pronunciation of Argand there. It's probably, I don't know. I'm not even gonna try because I'm not very good at this. The amount of research that I do for my videos is obviously quite a lot, but I think I spend a very long time researching how to actually pronounce people's names, because I do like to get that right. But it's for a typical British person who is quite ignorant of other languages and cultures, it's sometimes quite difficult. Google Translate is usually very good. But I've also got quite a lot of German speakers in my Patreon, which is really useful. Anyway, we've got this. Right, so this looks like it's time for some partial fractions. Yeah, let's partial fractions that, because we get that on the bottom there is a cubic, and you can't integrate linear over cubic because to log something you need you basically need it needs to be of the form f dash of x over f of x, and then that integrates to the log of f of x. So it's cubic on the bottom there. So I think it's going to be partial fractions. So let's set it up. We've got 8x minus 12 over all of this gubbins. 2x squared plus 3x plus 1. So this is a... Now, for differentiate, we'll get the linear. So I'm going to call that ax plus b over 2x squared plus 3 plus c over x plus 1. And now we times up ax plus b, x plus 1, plus c, 2x squared plus 3. And this is 8x minus 12 over here. Okay, let's just expand before we start to compare the coefficients. So I've got... Well, let's collect the coefficients together. So how much x squared do I have? I've got a of it, and I've got 2c of it. How much b do I have? I've got b. How much x do I have? I've got b plus a, lots of x, and then what numbers? I've got b plus 3c. And then this, because strictly speaking, I should be drawing an equivalence there, because this is true for all x, which means a plus 2c is equal to 0. It means a plus b is equal to 8. And it means that b plus 3c is equal to minus 12. So if I do this one, subtract this one, I get a minus 3c is equal to 20. And then if I do this one, subtract this one, I get 2 subtract minus 3 is 5c, 0 subtract 20 equals minus 20. C is equal to negative 4. And then that will unlock the rest of them. So a will equal 8. And then b will equal 0. Is that right? So b...
Lovely.
Yeah, good. Okay, nice to have the sanity check there.
Thank you, Lily, for the £50.
Oh, absolutely fantastic. Thank you so much, Lily. That's really, really appreciated. Inching ever so close to our £3,000 target there. Yeah, absolutely fantastic. £50, really, really generous donation. Thank you so much. So I feel sometimes a little bit callous, just like singing someone's praises for donating, then going straight back to it. But I do want to try and like remain focused. So I'm not being rude. I'm just really. I'm sure people understand. I'm just like, you know what I mean. I feel a bit conscious that it's just a bit weird. So 8x over. Let's call that I. And let's call this I. So I equals 8x over 2x squared plus 3. My voice is already starting to go, so this is not a good sign. X plus 1 dx. Okay, now the way I like to do this is to say this is 4x over 2x squared plus 3 integral of multiplied by 2. And the reason I've done that is because I want it in that form, f dash of x over f of x. I want the 4x there, dx. And then this is just minus 4, lots of the integral. Always pull your constants out, that's what I say. So that is actually what we've been tasked with. Okay, now, this is the limit, as h is the letter that we always seem to use, isn't it? H tends to infinity, of 2 log 4x squared plus 3 subtract 4 log x plus 1 between h and 0. That's how I'll set that up. I actually need to use some of the extra paper that they've given me this time. So let's just start a new piece of paper there. I'll just make sure that the previous line is on there. I don't want any. What did that lecturer used to call it? When you you get to the end of the paper of one, and then you turn the page, and then suddenly the answer looks more correct. It's like a proof by turning the page. And I actually marked a lot of undergraduate exams while I was a PhD student, and yeah, it happens. Always used to make me laugh, that one. So
You might have lost a factor of 2 somewhere. Someone says 2x squared.
Oh, I've not lost a factor of 2. I've gained one. So yeah, thanks for pointing that one out. It's good. I think for these complicated questions, yeah, please do step in and correct, because otherwise it's just like so annoying to actually trying to recover everything, if you know what I mean. So what are we gonna do here? I guess. So this is where we're going to use like log a over b is equal to log a minus log b, because we've got a subtraction here. So let's tidy up before we plug in, so to speak. So this is 2x squared plus 3 squared over x plus 1 to the 4th logged between h and 0. Limit as h tends to infinity. Don't want to forget that. So this is equal to the limit as h tends to infinity of. Let's just do another simplification before we put the limits in. So this is 4x to the 4th. 2 times 3 is 6 times 2 is 12. X squared plus 9 is equal to 14641. I think it is this one. Yep. So x to the 4th plus 4x cubed plus 6x squared plus 4x plus 1. Thank you, Pascal. Between h and 0. And this is the limit. Now, how do we want to negotiate this? This actually will approach 4 as it tends to infinity. Pretty sure. Because if you divide every term by x to the power 4, everything becomes 1 over x to the something, except for that which is a 4, except for that which is a 1. So this is the limit as h tends to infinity. I'll just be really, really clear on that. This is log 4, and I can hear thunder outside. That's because we've started the further maths paper. It's like foreboding. 1 plus 4 over x plus 6 over x squared plus 1 over x to the 4. If you've never seen this trick before, the motivation there... Oh, I've lost that. The motivation for this is when... when x blows up, if it's on the denominator, it's going to vanish to 0. So all of these are going to vanish to 0 because they're all... that's how they behave. So basically, what do we get? Although the kind of... So it's log 4. Subtract, and 0 into this form is 9. Log 9. So this is log of 4/9. Oh, please don't tell me that had to be an integer. I've got a really horrible feeling. A rational number.
Log 4/9. Sounds good.
Yeah.
Nice. I think it might be time to change the old ink in the pen. So a brief, a short recess just for the ink change. While
Which is, of course, a Lamy pen. This is another question that's just come out into the chat.
Again, yeah, I get a lot of questions about the pen. So I wish I could tell you which brand of ink I'm using.
I think there's a sponsorship deal here somewhere.
Oh yeah, absolutely. Yeah, yeah. If any representative of Lamy is watching this, I mean, how many representatives are there for a fountain pen company? But you know, if you do happen to be there, I would absolutely love to market your pens because I am a fan. I've also got a TWSBI pen, and I'm a fan of that one as well. Although I think it has broken in some way.
I think it depends who's paying more, right?
Yeah, kind of. Yeah, you can start haggling with each other to be advertised on a very niche maths channel.
Thank you very much to James Bullen for his £31 and 41 pence.
Nice, I like it. We had the old Pi versus Tau debate on my Discord, my Patreon Discord very recently. I'm, of course, on Team Pi. Not that we want to start that argument, so very much appreciate the donation. Although, if anyone from Team Tau does want to donate, that'll be double the amount, I guess. Depending on where you put the decimal point. But no, I really, really do appreciate that. I will say, if you do get this particular, and lots of Lamy pens actually, they come with like reusable cartridges. You need to buy what is called a cartridge converter, which is, yeah, sorry, this looks quite graphic, doesn't it? It's like it's bleeding everywhere. This, yeah, there we go. I don't know why I like red ink. I just think it looks really cool. Strictly speaking, I would score 0 on these exams because it has to be in blue or black ink. Yeah, so you have to buy it's what you call a piston filler, where you basically twist that up and down, and it's like a syringe. It pulls the ink up and down into the pen. Yeah, and it actually feels heavier as well, which is weird. Right, so we've got what on earth is this? A peanut? It's a table. It's a table, everybody. It's a table. Don't stress. It's just a table. So AB is 1.2. The area inside the closed curve is made of glass, and okay, that's made of wood. The perimeter of the glass. Yep. So that looks like a funky polar equation there. So, just because I struggle with my intuition on polar sometimes, I'm actually just going to put that dot, and I presume the initial line goes that way, because they don't always. Sometimes they do trip you up, especially in these sorts of modeling questions. I should have checked that really. Yeah, so that's the greatest distance, and that is when theta is 0. So I think that is the initial line. So I'm happy with that. Show that A is 0.2. Well, we know. Oh yeah. We know that 0.4 plus A cos 0 is equal to 0.6. That is just 1. So A is equal to 0.2. All right, easy. And then the 8 marks for the next question, so I shouldn't speak too soon. Find the area of the wooden part of the table top, giving your answer in meters squared. Right. So area of the wooden part is equal to area of the whole table, subtract the area of the glass peanut shape in the middle. Now area... Oh, it gives us that this is... why 60 centimeters when you've given me that in meters? Don't try and trip me up with that. What am I? So the area of the glass, obviously easy to calculate. We can even do that without calculus. We can just do 1.2 times 0.6, which is 0.72, is it? Yep. So that's 0.72. And then this area of the... 0.72 is the area of the table. The area of the glass is obviously significantly more difficult to calculate because we have to integrate this. Now, let me see if I remember the formula, and then I'll look it up. I think it's 2 pi times the integral of r squared d theta between 0 and 2 pi. Is that what we think it is? No, it's not 2 pi at all. I'm thinking of I think it's half. I think it's half. Let me just look that up because half times the integral of r squared d theta. Okay, yes, good. So this is the integral between 0 and 2 pi. Now, r squared, 0.4 plus 0.2 cos 2 theta squared is 0.4 squared is 0.16. 0.2 times 0.4 is 0.08 times 2 is 0.16 again. Is that right? 0.4 times 0.2 times 2. Yep. Plus 0.2 squared, 0.04. There's a cos 2 theta in there, sorry. And then this is cos squared 2 theta. So this is the integral of, let's do it this way around, 0.04 cos squared 2 theta plus 0.16 cos theta plus 0.16 d theta. Right, let's start a new page before we start dealing with that. Just realized my camera's gone a little bit out of line there. I don't know how that's happened. Or was it always like that? I don't know. Don't want you to not be able to see my face. Although that's debatable, isn't it? So how best to do this? I'm tempted actually here.
Should it be 0.16 cos 2 theta?
Yeah, good point. Thank you.
Shiru.
Yeah, thank you, Shiru. Yep, thanks. So what I'm thinking is, should I pull out that 0.04 because, 0.04 over 2 times the integral for, I don't like my constants just messing around in here. Cos squared 2 theta. Now, because we've multiplying through 0.04 times 4 is 0.16, so this becomes 4 cos 2 theta plus 4 d theta, which I think is just a little bit tidier. Obviously, this is 0.02 out here. So this is 0.2 times the integral, no it isn't, 0.02 times the integral from 0 to 2 pi of cos squared 2 theta d theta plus 4 times the integral of cos 2 theta plus 4. Let's fold that one in there. I think I'm splitting it up like this because this one's easy. This one, not so much. So let me see if I remember how you navigate this, because you do it using, so basically cos squared a minus sine squared a is equal to cos 2a. And also we know that this is, so cos squared a minus 1 minus cos squared a. So this is 2 cos squared a minus 1. So that means cos squared a is equal to cos 2a plus 1 over 2, where a is equal to 2 theta. So 0.01, if we pull that half out, times the integral of between 0 and 2 pi of cos 4 theta plus 1 plus 4 of these integrals. And I think now we're in a position to actually integrate. I've lost a d theta. Doesn't really matter. Okay, let's integrate. So 0.01. Now this is sine 4 theta over 4 plus theta between 2 pi and 0. It's good that we're getting sines, because 2 pi and 0, when we stick in there, they're just going to die. Plus 4 sine 2 theta over 2 plus, where's that 4 come from? Was that 1 a minute ago? 1. 1. Theta between 0 and 2 pi. Okay, so 0.01. So sine any multiple of 2 pi is just vanishes. So this is just 2 pi. Subtract 0 plus 4. Again, just disappears of 2 pi. Subtract 0. God, I hope this is right. So I've got pi 0.02 plus 8. This looks horrible. So 8.02 pi. Nowhere near correct, because the area of the whole.
Did you lose the 0.02 on the right term?
Well, because I factored out that 0.04.
Missed a big set of parentheses when pulling out the 0.02.
Yeah, that's it. Yeah. So, good. Well spotted.
Thanks, team.
So it's there, isn't it? Yeah, because I thought this is going to be nowhere near, because the whole area has an area. What was it? 0.72. So we're way off here. This is like 25. So that's what you get for. I mean, I do that a little bit too liberally, I think. Just always try and pull constants out. So it's 0.1 of that, and 0.1 of that, 0.1 of that. So 2 pi plus 8 pi, 0.01 times 10 pi, which is pi by 10, which is, well, it's 0.314, isn't it? So now that looks a little bit more sensible. It's about half, actually, which is, again, I would have expected it to be more than that. I'd like a check here. Is this right?
Not quite by the looks of it, unless I'm.
The problem is,
something.
if this isn't right, I think I've made some really big mistakes.
No, no, that is not correct.
God, I hate it when you don't get it right.
We're about a factor of 2 out somewhere, so.
I hate when you don't get it right, because now it's just impossible to find the actual mistake.
The right side is still by 0.02, not 0.01.
Right.
You drew a half from the left term.
Yeah, but isn't that taken into account here? Ah, yes. It was no, it was the left turn where the half came out. So yeah. Okay, I wondered about that when I was drawing these. Yeah, so God, I've really made a mess of this by pulling out too many factors. Just in an effort to try and make it neater, I've made it way more complicated. I should have just kept everything as ugly looking decimals all the way through. So, in fact, I think what will happen here is that all that will happen is that this term will be doubled. So I think it will be 0.01 times 18 pi. Is that right?
Yep.
Yeah, because it was the extra 2 on that side. I'm sorry. Pi which is, yeah, 0.565 5. And then, to finish the question, what did we say? It's 0.72 subtract 0.5655, and that will give us the answer. 0.72 subtract that, and we get 0.15. Yeah, that seems more sensible, because, yeah, the first answer that I got was obviously way wrong. The second answer I got seemed too small. Because it looked like about half of the area, and that doesn't feel like half of the whole thing, does it really? So it smelled wrong. Oh. All right, someone threw it in Wolfram. Yeah, looks good to me. Yeah, thanks everybody for your constantly checking me and trying to spot my mistakes, because it's just bound to happen. These, you know,
Certainly, these papers are like
ugly.
they're not just hard mathematically, but they are annoyingly tricky, and they really test one's
Patience.
algebra
Yeah.
manipulation.
Test your patience, and I don't have much of that, as you guys know. Oh, thanks, Emily. That's actually incredibly helpful. Uh, so, oh yeah, and somebody's saying, "Hey, look, it's the natural numbers." Yep, for the computer scientists and the logicians and the like. That's yeah. So
I'm glad they've specified it though.
yeah, I mean, it's totally unambiguous there, isn't it? Yeah. Sometimes the notation that is used, z greater than or well, actually just z greater than or equal to, or z plus, if you really mean literally the positive integers. But anyway, what on earth is going on here? Prove that. Right, I'm wondering. I've got a hunch that this is going to be one of those telescopic sums. Certainly not in its current form, though, because we don't have any negatives. Or is it an induction? Base case, certainly. If AB, if C is 1, and or is it another partial fraction? Partial fractions, I think, because hopefully we create a negative something or other. Because this really does stink of those, you know what I mean by a telescopic sum. Right. Well, I think this one's going to be pretty hairy again. So let's get into it. I think we'll do partial fractions on this, and then we'll do. So this is a over r minus 1. So let's just shortcut this. So a r plus 1, r plus 3, plus b. Let's say that's over r plus 2. So this is r plus 1, r plus 3, plus c, r plus 1, r plus 2. So 1 is equal to that. So 1 is equal to. Now, how much r squared do I have? I've got a plus b plus c of r squared. That's good. That necessarily introduces some negatives because they have to add up to 0. And unless they're all 0, which is obviously not true, that this will introduce some negatives. So I think I'm right in my hunch that this is going to be one of those telescopic sums. Okay, question is how much r have I got? Because I've got loads here. So 2r plus 3r is 5a. 1r plus 3r is 4b. And then 3c r. And then constants. I've got 6a plus 3b plus 2c. Oh god, this is messy. This is messy. So a plus b plus c equals 0. 5a plus 4b plus 3c equals 0. 6a, I really hope one of these turns out to be 0. That'll be nice, won't it? Plus 2c is equal to 1. Ugh. It's the nicest way of doing this. Let's do 6a plus 6b plus 6c equals 0. So if I call this, I don't know, 1, 2, 3, this is 1 times 6. I'm going to do 2 times 3. I'm going to do 3 times 2 times 2, sorry. Because I'm going to eliminate a, I think. So if I times it, so 10a plus 8b plus 6c is equal to 0. And then they come together to tell me that 4a plus 2b is equal to 0. And now, 18a plus 9b plus 6c is equal to 0. Now these two come together to tell me that 8a plus b is equal to 3. And now the top one is just saying, oh, this is good, because now look at that, b is going to be 1, isn't it? That one, subtract that one, b, 3b is equal to, oh, negative 3, excuse me, so b is negative 1, and that means a is equal to a half. It's never easy, is it? You know what I mean? This is classic further maths. We don't need to make it a fraction, but boy, are we gonna. And then c is equal to a half again, because they all need to add up to 0. So, gross. So, this is 1 over 2r plus 2, subtract 1 over r plus 2, plus 1 over 2r plus 6, sum from r equals 0 to n. Right, and hopefully something telescopic here. Can I possibly have a check on these?
You're correct.
Okay.
Yep, those are good.
All right. Because if I was on the wrong lines at this stage, then there's no point in even trying. So if we do, let's just. Well, I think if the first few terms here. So this is half. Subtract a half, and I'm not going to cancel that at this stage, because usually what happens is you want to marry up. So this plus the r equals 1. So this is 1 over 4, subtract 1 over 3, plus 1 over 8. Maybe we need a few more terms. R equals 2, so 2 times 2 is 4, plus 2 is 6. Subtract a quarter, plus 2 times 2 is 4, plus 6 is 10. The thing that's bothering me is this middle term. It's going to be a fifth and a sixth. It's just, ish. However, I might have spotted something. I don't know if this is the right way to do it, but I think a sixth plus a sixth minus a third is 0. because I think this is it. Because then we'll get an eighth. I reckon this term here will be an eighth. Is it? If I put 3 in there, 2 times 3 is 6 plus 2 is... It is. So I think it'll be that plus that minus that. They will cancel. And obviously nothing cancels with the first few. So end, middle, first. End, middle, first. End, and then we get that full cancellation. That's what I mean by a telescope. I don't know if that's a common phrase here. Do you know what I mean by telescopic, you two?
I've never heard of that before.
But you know what
I've
you've
not
seen
either.
you've seen this kind of thing
Sure.
because it's like it unfolds like a telescope, and then it collapses. You get the lens at the start, and you get the lens at the end. I guess that's where it comes from. Right. Question is, what happens at the end? So when r equals, let's just do n minus 2, n minus 1, n. We're going to get 3 things. We're going to get 3 things. We're going to get 3 things. Then when the telescope type thing comes along, what was it? It was first, middle, last. No, last, middle, first. So last, middle, first. Last, middle, first. Last, middle, first. Which is like symmetric with the start here. So when all is said and done, we get this term at r equals n minus 1, and then we get these two when r equals n. So a half take a half is 0 plus a quarter. We just get that from the start, and then we're going to add 1 over 2 n minus 1 plus 6. God, this is horrible. And then this term here is a subtract 1 over n plus 2. And then we're going to add a 1 over 2n plus 6. And what kind of form does it... Was it in that form? Holy moly. My God.
Yeah. Looks just about right. Probably needs a little bit of cleanup, but...
Yeah. I'll start the cleanup. So 1 over n plus 2. I'll just write this down, and then we'll start on a new page. I wonder if there's a clever...
2n plus 4?
Yeah, because it's 2n... Yeah. Okay, let's start on a new page. This is... God, I was quite happy when I spotted it was a telescopic thing. That comes up on Further Maths quite a lot, actually. But it was a bit... it's turned a bit uglier than I expected it. Why am I not using a calculator? Because I can't put in these variables like a calculator. Can you?
You also need to get the method marks. So the particular mark scheme specifies that you have to show the working.
Yeah. I mean, I've already said. I mean, that is true, but I've already said I'm not really showing my whole working out here, because you know.
I think he did finish that comment with a /s for sarcasm.
Oh right. Oh sorry.
Ah.
I wasn't aware that /s meant sarcasm. And I really characterize myself as an internet denizen, but I haven't really seen that before.
I do like that Clofat has used the sarcasm symbol, because I speak fluent sarcasm, and yet whenever I write emails or text messages, sarcasm never comes across as well as it should.
Yeah. It's difficult, isn't it?
Mm. Good on you, Clofat. Appreciate that.
I'm not gonna factor out, because obviously these factorize. I'm not gonna do that. I've lost confidence with my ability to keep track of the constants because of how badly the last question went. So let's just add these, and then we'll worry about it later. So 2n plus 4, 2n plus 6. Have you seen the interrobang? That went around the internet a while ago, didn't it? As a means of indicating sarcasm.
Yeah, but it's more of like an exclaimed question. That's how I always read it.
Yeah, I had the same kind of feeling. It didn't really feel like capital S sarcasm. It's only sarcasm in the sense that, like, oh well, that was good, that kind of that kind of sarcasm.
I tend to put all the words in italics if I'm being sarcastic. It's like a comment that doesn't contribute to the conversation.
Yeah. Or you can strike through. A few of my patrons do that actually. If you write it in strike through.
Oh, that's nice.
You removed two from the top and bottom. Oh yeah, that makes sense. Yeah.
Yeah, and I'm regretting it actually because there's a 4 over there, which means actually what I'm going to do is I'm going to forget about that and I'm going to do 1 over 4 plus. I'm sorry. I'm kind of doing more work than is necessary here because I'm so frightened that I'm going to mess it up. N plus 3. That's how I'm going to write it because now I just need to fix this one. So now it's just n plus 2, n plus 3, subtract 1 all over 4, n plus 2, n plus 3. Right, are we anywhere near? Ugh, kind of. So this is what we're aiming for here, this form here, which we're not a million miles away.
You're not too far away, but I think you may be on the wrong track. I feel like there may have been a mistake earlier on.
No, you tell me now.
I
Yeah, because this doesn't
think
factorize,
that's
does
still
it?
good.
Oh, that was supposed to be a 2, which means that's a 4. Ah, yes. And then n plus 1, n plus 4. Yeah, so that top, expand it. That's that 2 there that I almost lost. That becomes, so it's n plus 1, n plus 4, all over 4, n plus 2, n plus 3. Please, please.
Correct. Ding, ding, ding.
Don't leave me in suspense, Dan. Come on.
That's correct.
I know, but you gave a dramatic pause there. I was like, just enough time to have a mild heart attack. Again, I mean, it's classic further maths, this, isn't it? Like, this is the new bit of mathematics. This is just faffing around. Like, who cares? It's just glorified juggling. Okay, and we've got a differential equation here. Thank God it's only first order, because I'm notoriously terrible with the second order, so this actually gives me a little bit of hope. Now that the first order equations come up here, it's unlikely that you're going to get a second order paper on the same, a second order equation on the same paper. So, blah, 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 blah. So, it's probably just like boring. A tank at a chemical plant has a capacity of 250 liters and 100 liters of pure water. Yes, pure water, not just water. I'm sure that'll be important. Salt water, oh, it is actually important. Salt water enters the tank at a rate of 3 liters per minute. Sorry, I shouldn't have been so sarcastic about that. Each liter of salt water entering the tank contains a gram of salt. Right. It is assumed that the salt water mixes instantly with the contents of the tank upon entry. At the instant when the salt water begins to enter the tank, a valve is open at the bottom of the tank and the solution in the tank flows out at a rate of 2 liters per minute. Oh my god. There are S grams of salt. Okay, so S grams of salt. The actual thing we're tracking is the number of grams of salt. Oh god, my god. Usually this is the easy part, but I think this is quite difficult to untangle because what's happening here is 3 liters go in each, so 3 grams go in. This is all taking place in 1 minute, and then the question is how many grams leave, because the amount of water, so water is equal to, starts with 100 liters, and then we add 3 liters every minute. However, we drain 2 liters every minute. So 100 plus T, oh that's good, we've got 100 plus T somewhere. And now, how much grams of salt? So I'm just imagining, like, if you've got your, on the first minute, 103 liters, and then you remove 2 liters of water, how much salt have you left? Have you actually got rid of? I suppose it's that fraction of 3. But in general, that's the capacity, that's the volume of water. That's 2. That's the amount of salt. I think that's where that comes from. So going out, there'll be 2 over the actual volume. That's the concentration of salt that's going out. So the change in salt over time will be 3 minus 2s over 100 plus t. God, that was hard. That was actually really hard to unpick what was actually going on there. And I'm not going to lie, I kind of looked at what the answer was and read backwards. Hence, find the number of grams of salt in the tank after 10 minutes. In other words, solve the ODE. So, now, this is, I've already recognized what type of ODE this is, which is, thank God, because there's quite a few different types, and I'm way more confident with some rather than others. So, this is of the form, I'll just use different variables here, plus p of x, y equals q of x. I was teaching this to a student a few months ago. So this is the integrating factor. We're going to multiply through by e to the integral of p of x dx, and that will... In fact, I don't even think this is right, because, oh no, yeah, I think, yeah, if we do ds by dt plus 2 over 100 plus t s is equal to 3, that is our p of t, I should say, and then q of t. Yeah, it's in this form, isn't it? What do you call this form? Is this the homogeneous or of homogeneous type? I remember Matthias Heil going through them all with us.
I don't remember. Dan?
Pass from me. In the chat, what is what's that form? The one in the top right.
Yeah, I'm sure it's of. There's ones that there's a homogeneous one, which I think might just be the basic dy by dx equals x over y or something, and then there's a homogeneous type, which I think might be this one. I can't quite remember. This is one of the easier kind. You don't need the characteristic equation to solve this, which is when it gets really awkward, and I'm really relieved that that isn't on there, because I do not have a good intuition with those. So this is e times 2 log 100 plus t, which is just 100 plus t squared. So that is our integrating factor. That's what you call that. Now we multiply through by that 100 plus t, and then we're going to apply the what I call the reverse product rule. Well, it's not what I call it. I think it is. That's what we call it. Equals this 100 plus t squared. And now, oh, I've lost ds by dt. I'll just put an s dash in there. So integrate. We get with respect to t. We get s times 100 plus t all squared. Because if you did the product rule on this, if you differentiated it, it would be this one times ds by dt, and then this one times d by dt of that one, and the 2 would come down. Yeah, this is right. And then this is equal to 3, and then chain rule here. So 100 plus t all cubed divided by 3, and multiply by the derivative of the thing in the bracket, which is just 1. So that's fine. Nice bit of cancellation there. Nice bit of cancellation there. So S is just... Oh, hang on a minute. No. Plus C. So S is 100 plus T all squared, and that is equal to 100. I thought that was a bit too easy. Plus C.
And thank you very much to Macronenser for the £20. Thank you for the super chat.
Oh, super chat, yes, thank you ever so much. We've got a couple of super chats now, which means we're probably getting, we might have actually already, no, I think we had a £20 and another like £20 or so we'll be close to that target. But yes, thank you very much for that. I know it's easier if you've already got your Google login and everything like that. I know it's probably easier for some people to donate on here. I actually didn't realize that you could link this like a YouTube live stream to a fundraiser, which is really annoying. So what I promise I will do this, is I will add up all of the super chats and I will just donate myself. So I will make sure that does go to the charity. But yeah, I really appreciate that. Thank you very, very much. Now, what do we know about C? What are the initial conditions? So what was it? Initially it was just pure water, which I unfairly derided the question for stating pure water. It actually really does matter. I can't believe I did that. So S equals 0 when T equals 0. So C is just minus 100 cubed. Or minus a million, I guess. But I might actually just write that as 100 cubed. That seems a much easier, or even minus 10 to the 6. Because I doubt we'll really need to do much with that. Right, now what's the actual question? Find the number of grams of salt in the tank after 10 minutes. So I'm actually just going to write this as a function of, so I'm going to write S as a function of T. So if I divide through by 100 plus T all squared, then I get my 100 plus T, subtract 10 to the 6th over 100 plus T squared. Okay, time for the calculator. So what was it, 10 minutes? 10 minutes. What do we think the answer is going to be here? I always like to kind of see, so, because we're gaining 3 grams and losing a bit, I reckon it's going to be close to 30. It's going to be 25, 20, I don't know, some high 20s. 100 plus 10, subtract 10 to the 6 over 110 squared. Yes, 27 point, what is it to the nearest, well, whatever, let's do 27.4 grams. What do we think about that, guys?
Lovely.
Nice. Thank God. So I would start on a new page. I'm just going to write on here what we actually, because I think we're going to need this. So S equals 100 plus T, subtract 10 to the power 6 over 100 plus T squared. So when the concentration of salt in the tank reaches 0.9 grams per liter, the valve at the bottom of the tank must be closed. Right. Find the nearest minute when it will be close. So grams per liter. So the number of grams we've already said is S. And then the total amount of water we said was 100 plus T, didn't we? So when that is equal to 9/10. So we want the value of T for which that happens. This doesn't feel right. Yeah, when that... I think this is right. I just... let's do S is equal to 90 plus 0.9 T. And I guess we just solve. So 90 plus 0.9 T is equal to 100 plus T minus 10 to the 6th over 100 plus T squared. Hopefully we get a bit of tidy up that can happen here, although it doesn't look like it. So throw the 90 over there, throw the 0.9 over there, equals 0. Subtract that, and then we'll multiply... Oh my god. I'm not sure about this. Can't see where I might have gone wrong. So 10 plus 0.1 T multiplied by 100 plus T squared, subtract a million, equals 0. Right. Couldn't just make it a nice question to finish off, could you? 100 squared is 10,000 plus 200 T plus T squared. Subtract a million is 0. Oh, for God's sake, this is just, this is... There's a lot going on here. I don't really... This can't be right. I'm very fast losing confidence in this. I don't know how you avoid getting a cubic, because I don't want a cubic.
You're gonna need to get a cubic.
I know, but I don't want one. Let's multiply... yeah, yeah, I know, but I'm gonna multiply through by 10 before I expand that. Plus 200 T plus T squared minus 10 to the 7th. And then we expand. So 10, 0, 0, 0, 0, 0. Take 200, 0, 0, T plus 100 T squared. That says 100, I promise. Plus 10,000 T. Take 200 T squared plus T cubed. Subtract 10 to the 7th equals 0. T cubed. And then I've got the 100T squared. Take 200T squared is subtract 100T squared. This can't be the way to do it. Sorry, Dan. I don't believe you. 10,000 subtract 20,000 is obviously minus 10,000. Why am I doing that in the calculator? So I've dealt with that, I've dealt with that, I've dealt with that, I've dealt with that. So minus 10,000 T. What number is that? That's a million. So and what on earth is that? This is what I was afraid of.
I feel like you've missed a factor of 3 somewhere.
No.
t-squares all good?
That's 100. Take 200 is minus 100.
Did you drop? Oh no, I was gonna say, did you drop a plus sign? But I think I'm getting confused with a bracket. Yeah.
Oh yeah, that is a yeah. Um,
Is that meant to be a plus?
that is meant to be a plus, yeah.
Right, right. So I don't think that filters through on the next line. You've got
Okay.
minus 200,
God,
20,000.
so plus.
That should be plus 20. That should be plus 30,000.
Yeah, so plus 30,000 there, yeah.
Yep, and same again for the 100 t squared minus 100 t squared.
So we actually should get plus 200. Yeah, it's there. And then yeah, I see what you mean, Ollie, now about the factor of 3. Sorry. So yeah, it's that. How on earth are we going to solve that? This is not right.
Are the signs on those two still correct?
Oh,
yeah,
no,
no,
they
they
should be
all
positive now,
positive.
shouldn't they? Yeah, but I still don't believe that this is right. This is ridiculous. So the only thing I can think of is,
Well, the factors of 9 million.
well, it's not even that because it's a cubic. There's no solution to this. I want to start again. I'm not convinced. I mean, it
No,
must be right because you're looking at the
you're
mark scheme,
correct.
but this is not solvable. I'm sorry, it just isn't. I think my calculator can do it actually.
Yeah, give that a go.
But because yeah, I think the
Elliot math is correct.
the expectation is that students have them.
Well, remember that in further maths, you tend, like, everyone has had those big graphical calculators.
Yeah, well, you're not allowed. You're actually not allowed, yeah, and then we get two complex answers.
Oh.
So that's right.
Really, really good point there, Spoof. Every cubic does have a root.
Every cubic does have a root. Yeah, I wasn't disputing that a solution exists. I was disputing the fact that we were able to find it. So you must have to use the calculator. You must have to use calculator.
Yeah.
Because I mean that isn't even that. I mean it's yeah. So it's two complex roots. So you can't even factorize it very well. God,
Yeah.
what a rotten way to end the question, because I don't like the fact that it relied on the calculator there. I'm sure there must be another way of doing it.
No, that's pretty much it.
At yeah, it's true at GCSE you'd lose many marks for this, but actually at GCSE you would never get a cubic.
Yeah.
You would never ever get a cubic. The only cubic that you might get at GCSE is one of this form, where you can always pull the x out and get a quadratic. So that's the only type of cubic that you get there, which is it is a cubic, but it's a much nicer kind. So D, evaluate the model. Well, I don't friggin' know. What do you want me to say about that? Well, unlikely that the water will instantly mix, because that was an assumption that we made. It is assumed that the salt water so unlikely instant mix, let's say. What were the other evaluations of the model that you... yeah, thanks for that, guys, by the way, because I was really doubting myself there. I thought, because the expectations is because so many students started using because calculators have now developed to the point where, yeah, you can just use them to solve a quadratic, you can just use them to solve a cubic. Like now,
Yeah.
I guess the questions have shifted to accommodate for that, but it still feels a little bit of a cheat. So someone is telling me, so Shiru, because I did wonder about this, because if you put the what number is that? 9 million. Which I don't even think is right. I think it should be
9 million's right.
well, whatever. Yeah, if you put that over there, that is a cube number, but I couldn't spot that it is just yeah, it's the third root of 2 to the power 7. Yeah, very, very well spotted. Very well spotted. Yeah, it is, It is. Yeah, I never spotted that.
So just some of the other answers for D. So we've got it's unlikely that mixing is instantaneous, of course, but the model is only valid when the tank is not full.
Oh
When
yeah,
the
because
valve is
because we
yeah
never actually used the fact that it was a 200, was it a 250 liter tank?
yeah.
We never used that, which is interesting because it's not often that you get redundant information in the question.
When the valve is closed, the model isn't valid,
Oop. Uh,
and it's unlikely that the concentration of salt water entering the tank will remain exactly the same.
right, yeah, yeah, all fine. Um, I almost skipped a question there, by the way. So question 6. I think these further maths papers tend to be short. Well, I say shorter in the way that there's fewer questions, but the questions are harder. So there's 8 questions. So
Boring.
three questions to go. Prove by induction. Everybody's best friend. This is going to be. I'm not going to say it. I'm not going to say it. I was going to say it's going to be easy, but so for all positive integers n, again, totally unambiguous there. So base case n is equal to 1. So 3 to the power of 6 subtract 2 to the power of 2. Well, what is that? Is that 343? No, I think it's no, it's the next one. It's 729. 3 to the power of 6, 729. Yeah. Subtract 4, which is 725, which is a multiple of 5. It is 145, I believe. So, yep, works. Now, assume 3 to the power of 2k plus 4, subtract 2 to the power of 2 to the k, is equal to 5. Well, not n, not k. What letter should we use, Dan? Okay,
Let's go for
A. Uh, since you didn't respond there. Well, I don't want to use M because then you end up with the N and N, and no one can really. No,
E.
not E. No. So for some integer A, and then what
I
happens?
tried, Emily.
So. Oh, she wanted capital E. Well, capital E is a little bit more forgivable. Lowercase e, and then it's like, well, it's not Euler's number because it's an integer, but yeah. So 2k plus 1 plus 4 subtract 2 to the power of 2 times k plus 1. So let's tidy this up. 2k plus 2 plus 4 is 6, and then subtract 2 to the power of 2k plus 2. Right, now, let's try. We've got to get this involved somehow. So this is 3 to the power of 2 to the k times 3 to the power 6 subtract 2 to the power of 2 to the k multiplied by 2 squared. Wow, that thunder outside is really ominous. And, ooh, what are we going to do with that?
A good time to be inside doing maths papers, I believe.
There's never a good time not to be doing that. But, absolutely. How are we going to get our thing here involved? I've expanded this, right? So 2k plus 2 plus 4, 2k, yep. Because I like the 3 to the 6. Sorry, the. Wait, what am I doing? I'm thinking about this. I want to get the yeah. I want to. Sorry. Let's think. Sorry. I want 3 to the power of 2k plus 4 times 3 squared. and then I need to subtract. So this is 2 to the power of 2 to the k times 2 squared. So that's 9, that's 4. It's almost there, isn't it? I don't know if this is the right thing to do, but I'm struggling, so let's just try something. This is this. Subtract 2, which I can then write as 3 to the k plus 2 times 3 plus 2 to the k times 2. This is just, no, this is not right. This is not right. So, oh God.
Thank you very much to Jezriggs for the £10 super chat. Thank you very much.
Yes, awesome. Thank you very much for that. That's perfect. Excellent. Thank you so much. I think I recognized him from a comment actually recently that I might have responded to. Yeah, thank you very much. All helps. And thank you.
And Christoph.
And Christoph as well. I just noticed that. Yeah, thank you ever so much. That's absolutely fantastic. Keep them coming. All goes to a fantastic cause, which is Mind. We're so close to our target now. I'd love to be able to get there. I really shouldn't have said that this one was going to be easy. You're absolutely right. I'm sure it'll pop out. I just need to. The point is, there's something fishy about the fact that we're getting 9 and 4. Because they have a difference of 5. I really want to be able to use that. But I can't quite spot it.
Thank you, Bongo 50.
Must be
for
from
the
there.
donation.
Bongo 50, excellent. Thank you very, very much.
Plenty of suggestions in the chat.
I'm not looking. I'm not looking. I refuse. I'll get it. Because I enjoy these questions. I don't want to. If I'm really struggling, I will look. It's got to be something to do with this. I mean, it's almost there. It's just not. It's not right because this is not some multiple of that, and I really want it to be.
Hey, let's just take a pause for a moment because we've just had a £90 anonymous donation, which has just tipped us over that £3,000 mark.
Yes,
you did it.
Yes, awesome. Thank you very much, anonymous donor, whoever you are. You have successfully brought us into our. Sorry, I'm completely lost for words because I'm half thinking about this question. Yeah, thank you, really. Honestly, thank you so much. It's really fantastic that we've managed to achieve that target. So thank you so much, whoever you may be. I've just glanced at the chat. I've seen someone mention modular arithmetic. I really don't want to do that because that's really not in the spirit of the question. Because we definitely should not know that at this level. So I'm also not sure how easy it is. Again. So, oh yeah, and I should say as well, yeah, we've met the target. That's absolutely fantastic, and it obviously calls for celebration. But it's all about how high can we push it because obviously, like I said, it all goes to a really fantastic cause. So any way we can support that charity, it will be great. So right. What about if we take that? What can we do with this? So this means that 3 2 to the power k plus 4 is equal to a multiple of 5 plus 2 times 2k, 2 to the power of 2k. And then this is what we've got. So let's times everything by 9. So 3 squared, 3 to the power 2k plus 4, 45k. Oh, I think I might be onto something. So plus 9 times 2 to the power k. Okay. And now, another way to say that is we've got 5 of them, and we've got 4 of them. Therefore, yeah, I knew there was something in this. Let me rephrase this now that I know what to do. We'll go, because I'm kind of starting from the end here, which is not really a valid way to write the proofs. So if I go from here now, I've got 9 of that and 4 of that. So actually, let's make it so that I've got 9 of this, which is, oh yeah, it's actually really obvious now that I've spotted it. So we're going to subtract 9 of that, but we actually have got 4 there, so we need to add in another 5. So this is 5 times 2 to the k. So this is equal to 9 of 5a. Sorry, I'm dropping my 2k's here. Because this is by induction. 2 to the power, 3 to the 2k plus 4 minus 2 to the power, so it's 9 of 5a. This is by induction. Always say when you use the inductive step, plus 5 times 2 to the power 2 to the k. So this is equal to 5, 9a plus 2 to the power of 2k, which is a multiple of 5. Therefore, it's a multiple of 5 for all integers n. Okay. So, but the chat was going crazy with, it's not actually that complicated. I knew it was the fact that there was a difference of 5 there. That was really fishy. I just couldn't figure out how to spin it into the proof. And then classic, if you get stuck, look at where you're trying to get and see if you can get there. I knew I'd get it. Because I really enjoy those. So I didn't want to just like look at the chat, and if I was really stuck, I'm happy for people to help me. But there's an element of like, I do want to kind of get there some of the time. Right, okay, so this is where we have a little bit of linear algebra by the looks of things. So L1 has that equation. Oh God, I love linear algebra, right? I really, really, really like it. It was one of my favorite things to do in first year. This is just, I don't like it. When you learn vectors and you really get your head around vectors, it makes so much more sense to do it that way. But anyway, we can convert between them easily enough. So L2 has that equation, right? So let's get our hands on the vector equation of each of these. So again, I've always just got to imagine what's actually going on here. So x, y, z is equal to 2 minus 1, 3 t plus minus 1, 1 minus 4. I think that's right, isn't it? X, no. Um, yeah, flip those signs. Yeah, it's been a while since I've done this actually, because I just hate the Cartesian form of the equation of a line in 3 space. So this is L1. So let's call it R1 is equal to 2 minus 1, 3. Let's stick with T plus 1 minus 1, 4. And let's say R2, let's get it in column form. 1, 0, 3 plus, oh, they've used T there. Let's not use T there then. What should we use? R? No, S. Where was I? 1 minus 1, 2 times T. Okay, show that L1 and L2 lie in the same plane. Well, they lie, if we kind of imagine a plane here, they lie in the same plane, so they're embedded in there, if any point on the plane is perpendicular, so any kind of any expression of that, if they're both perpendicular to the same thing, that's how I think I want to do it, which means they'll dot to 0. So if we can do 2s plus 1 minus s minus 1, 3s plus 4 dot. There might be a way to do this using the cross product actually, but I think you might have to assume that they're already in the same plane. But I think there might be a way of doing this using cross product, and I actually don't know whether that is taught at this level. Oh god, seriously?
It's taught in Further Pure 2.
Right, so it probably is taught at this level.
Sorry, I just want to triple check that first expression, the 2 minus 1, 3, plus 1 minus 1 plus 4 is the
Oh yeah, sorry.
plus 4.
Where did that come from? Yeah, I think I was looking at that one there. Oh yeah, it is 4.
Okay.
Yeah, plus 1 minus 1 plus, yeah, it is 4. Yeah. But thanks for checking. I don't like what I'm doing here, because this is just going to be a nightmare. What am I doing? Let's find where they meet. So let's do that, because sorry, I am getting tired here. I've been at it for quite a while now. I'm starting to show signs of running out of steam. I might need another break in a second. I would love to push through and do that degree level paper first though. So let's find where they intersect, and we get 3 plus 2t. Right, how many simultaneous equations are we going to solve today? So this is telling me 2s minus t is equal to 0, whereas this one is telling me that minus s plus t is equal to 1, which means that s is equal to 1. And it also means that 2 plus 1 is equal to 1 plus t, so t is equal to 2. And then is that consistent with the third one? 3 plus 4 is 7. 3 plus 4 is 7. Okay, so they do have a point of intersection. So that's good. I mean, if they didn't intersect, they wouldn't lie in the same plane. And now, to show that they both lie in the same plane, I think if we find the normal vector and show that both of them are perpendicular to that normal vector, that kind of locks them into the same plane. Yeah, okay, so let's take that point of intersection actually, because I think it is pretty arbitrary. Let's take 2 minus 1, 3, plus 1 minus 1 plus 4. So 3 minus 2, 7. And if we do 3 minus 2, 7 dot something, then it will equal 0. So if we do 3x minus 2y plus 7z is equal to 0, and then obviously we've got a free variable here, so let's do, if x is 3, y is 1, z is negative 1. So 3, 1 minus 1 is normal to L1. Why didn't I just dot it with the direction vector? Sorry guys, I'm struggling here. I'm really struggling. I'm really losing energy. I've all of a sudden becomes really tired. Plus 4z is equal to 0. So wait a minute. If they meet, what am I doing? Yeah, if they meet, then they line it in the same plane. There's actually no other way for this to be, because if they, yeah, there's a line wherever the second one goes. Yeah, it describes a plane. So I actually think this is sufficient.
Yeah, I mean, if you can show that if the lines intersects at a point, then the line
They
then the
they
line
ne
lies in
they,
plane.
they
That's all you need
necessarily
for.
lie in the. What on earth am I doing? I think what I'm trying to do is question B, which is to write down a vector equation for the plane containing L1 and L2. And for some reason, for the life of me, I cannot find this normal vector. I don't know what I'm doing wrong. It's just not coming out. I need a vector.
Yeah. Do you need to?
Yeah, for the second one, write down a vector equation for the plane containing L1 and L. Well, I suppose you don't have to, because okay, yeah, let's do it that way. If you're a point in this plane, then the plane is spanned by the two direction vectors here plus the position vector of one of them. So you've basically got position vector of L1 and then some direction. So let's call this position vector 1 and then D1, and then you've got position vector 2 and then D2. If you start on P1, you can travel some way along D1 and some way along D2, then you can get to that position, because yeah, so if we do it that way, then if we say, and obviously two variables in there, so if we say, I'll tell you what I'm doing wrong. I know now why I was making so many mistakes over here. It's because I've written this the wrong way around. And in my tiredness, I just, yeah, I'm completely, it's that position vector first and then the direction vector. Just really, really stupid stuff. Starting to, I think I do need to take a quick break after this one. I'm getting frustrated. So
We also need just as a note, we also need to swap to
yeah,
the
yeah.
second stream.
So we'll finish this question. We'll do question 8, and then we'll switch to the next stream because YouTube has a thing about I think 12 hours is the limit. Otherwise, it doesn't save the video. So as long as we switch over before midnight, it's fine. But yeah, if we try to keep them at 8 hours each, it's fine.
Question 8 looks fun. So.
Oh, thank God. So let's take the position vector 1, -1, 4. I can't believe how much of a meal I made out of that first one. For some reason, I think I was anticipating what the question was going to be, which is kind of what I was doing here. 1, -1, 2, and I actually want to. So this isn't usually how I would do it. So ST in R. That is the vector equation of a plane. If we call that RP, I don't know. Then that is fine. And then find to the nearest degree the angle between L1 and L2. Well, we basically just need to find the angle between the direction vectors. It doesn't matter where they start. So direction. So 2, -1, 3, and 1, -1, 2. I think we find the angle between those two. So if we dot them, this is 2 + 1 + 6 over the length of that one, which is root 4 + 1 + 9 is 14. And then the root of this one, 1 + 1 + 4 is 6. So 9 over root 14 root 6. And that is the cosine of the angle, obviously. So if we do that, put it in the calculator. It's really, really bad about that whole. I'm really quite embarrassed about that first question. It's like really basic stuff, but in my current state, I just all of a sudden become 10.9 degrees. Is that right?
Yep.
That's correct. Yep.
Oh, thank God. Let's put that question away and never look at it again. So
When I said that question 8 was fun, I did mean it like I would find it fun.
oh no. Well, Dan, what do you find fun? Is it like, automating the question? Like Factorio or something like that?
Yeah, I mean, I love the factorization of questions. But...
I really didn't think this would come up. I can't believe this. They've put a first order ODE and a second order ODE. You are just the worst. You know that. I can't believe you're going to say it was fun. I thought it was going to be some nice proof question or something like that. Oh, this is horrible. I don't want to do this. I think I know how to do it. I think I know. I mean, I know how to do it. It's just the execution. Let's just read it. So, a scientist is studying the effect of introducing a population of white-clawed crayfish into a population of signal crayfish. Where do they get the context for these questions? At time t, the number of white-clawed crayfish W and the number of signal crayfish S are modeled by these two differential equations. So, show that we can find a second-order ODE. So, ODE, I should say, is ordinary differential equation for those not in the know, as opposed to a partial differential equation, which is just the absolute worst. So we differentiate this one. Let's rewrite this as 5 over 2w subtract 5 over 2s. In fact, no, let's do 2 over 5 dw by dt is equal to w minus s. And then 2/5 of w second derivative is equal to that. And then we can substitute in, this is 2/5 of w minus 90 e to the minus t. I don't know why I'm writing that down again. So this is equal to w dash subtract 2/5 of w minus 90 e to the power of t. Okay, let's times through by 5, and that's good because we're going to create a 450, so we're on the right path here. So 2 times w dash dash, subtract 5 of w dash when I take that over there, plus 2, no, subtract, yeah, plus 2w, and then that becomes positive 450, so it'll be negative when I take, oh no, it wants it on that side, so equals 450 e to the power t as required. Now, usually that is the easy step. Right, find the general solution for the number of white-clawed crayfish at time t. So we need to solve this now. Right. So let me just write it down again just so you can all see it. And I'll write it down. So this is d2w by dt squared, 2 of them. Take 5 dw by dt plus 2w is equal to 450 e to the minus t. So that's what we've got. Right, so we need the characteristic polynomial 2 lambda squared. Usually use lambda here, don't we? Plus 2 is equal to 0. Please factorize. Come on. So this looks like minus 2 minus 1. So lambda equals half. Lambda equals 2. And therefore, our general solution is going to be of the form a e to the half t plus b e to the 2t plus some particular integral. Oh god, how do you do that? How do you do that bit? How do you do that bit? Well, it's equal. Okay, I do remember this. I do remember this. So our ansatz, if you will, for the particular integral is e to the minus kt. Do we need a constant out here? I don't think so, because it's particular. It's particular, so I don't think we need to worry about that. Ansatz, by the way, for those who don't know, that's a German term that means how did Matthias describe it? An educated guess.
Yeah, I always think about it as like it's like an answer schema.
Yeah.
Like
Yeah.
it's a way to solve this. You know that it's going to be in that form, but it's you don't know what those terms are going to be necessarily.
I also don't need k because it's why have I got any constants involved?
Although if there are any German speakers, it'd be really interesting to hear what Ansatz translates directly into English.
Yeah, I don't think there is like a very like an actual specific direct translation. But yeah, it'd be interesting to know what the closest is. What am I doing? I think I do need a constant there, don't I?
But yeah, before the e.
I think that's what we do. That's what we do. Yeah, because it does have to match up with the 450. So that's why we use an ansatz, because now we realize what are you talking about. So that is equal to minus a e to the minus t, and then differentiate again, we get a e to the minus t. So shoving that in there, we get 2a plus 5a plus 2a equals 450. I've divided through by e to the minus t because they've all got them. So that is 9a. Oh, this is nice. So a is 50. Yeah, so our particular integral will be 50 e to the minus t. So our characteristic function plus the particular integral equals the general solution. W. Oh, it's almost like I know what I'm talking about. Don't speak too soon, Alex, because there's a long way to go yet. Because what are the initial conditions? A general scientist is studying the effect of introducing a population. Anyone see any conditions on here? Oh wait, we just want the general solution. Sorry. So that's the answer. That's it. That's my answer.
Lovely.
Bit of bad notation. I've used capital A twice, but who cares? Okay. Now question C. That wasn't too bad actually. That was easier than I expected it to be. I think because it's an E, the exponentials generally I think they're the easiest to derive the particular integral. Trig is a little bit harder. I think E's better because you differentiate it, it doesn't change. Really. Okay, now find the general solution for the number of signal crayfish. Sorry, I should try and keep the questions on here. So let me just try and keep those on. So we're on C now. So we want a general solution for the number of signal crayfish. So we know ds by dt is equal to 2/5 of w minus 90 e to the minus t. That's given in the question, and now we actually know what w is. So we know this is 2/5 a e to the half t plus b e to the 2t plus 50 e to the minus t. Subtract 90 e to the minus t. And that's pretty much it, really, isn't it? Is that the whole question? 2 marks for that? I suppose I can tidy this up. So that is 2a e to the half t over 5 plus 2b e to the 2t over 5. How much are you betting that the next question is, here are some initial conditions, now find the specific solution? So that's 10, 20, so subtract 70 e to the minus t. Okay, and here we go. The model predicts...
So there, so your A and B are off a little bit for some reason compared to the answer here.
Oh.
We've got 4/5 and 1/5.
4/5 and 1/5. What? Oh, because yeah, this is ds by dt. The question asks for s. God, yeah, no wonder I wasn't getting 2 marks. I did wonder, like, why I wasn't getting the marks. So s now is equal to, so we just need to integrate this. So if I divide this by a half, I get 4a e to the half t. That's where the 4/5 of a comes from. And then if I divide this by 2, oh yeah, thanks for the heads up there, Ollie. I was about to completely blunder through the rest of that. And then plus 70 e to the minus t. And then, do we introduce another constant here? Or is it all kind of wrapped up in the rest of it?
I think it's good.
I think plus c is fine. Okay, now, the model predicts that at time t years, the population of white-clawed crayfish, that's W, will die out when t is equal to big T. Given, okay, so new piece of paper, because now we have some initial conditions. So TWS is equal to 0, 65, 85. Find the value of, oh god, 6 marks. I thought it was going to be a nice question just to round it off, but I think it's going to be quite a chunky one. So let me just copy over what I've got here. I don't think we need that plus C on S, do we? Right, well, I've got W is A e to the half t plus B e to the 2t plus 450. Sorry, plus 50 e to the minus t. I've got S is equal to 4/5 of A to the half t plus a fifth. I'm writing it like this because I think be just a little bit clearer. No, I actually don't really like how I've written this. Plus 70 e to the minus t. Now it's basically asking us to use this information to find the values of a and b. So top one tells me that 65 is equal to a plus b plus 50. In other words, a plus b is equal to 15. Simultaneous equations again. That's a real theme today. And then 85 is equal to 4/5 of a plus a fifth of b plus 70. So if we do 85 subtract 70 is 15 times by 5 is 75 is equal to 4a plus b. So subtracting, we get 3a is equal to 60. We get a is equal to 20. Therefore, b is equal to -5. And we want the time at which w equals 0 now that we know what a and b are. So let's do 0 is equal to 20 e to the half t minus 5 e to the 2t plus 50 e to the minus t. Divide by 5 firstly. So 0 is equal to 4 e to the, let's write that as t over 2 now. Subtract e to the power of 2t plus, what did I divide by? 5? Yeah. And then, don't like that, so let's times through by e to the power t. So, I get 0 is equal to 4 e to the 3t over 2. I know what's going to happen here. I think I know what's going to happen here, because now I get 3t here plus 10. It's another one of our disguised quadratics here. You'll see what I mean in a second. 3t subtract 4 e to the 3t over 2 subtract 10 equals 0. So if we let, this is basically x squared take 4x take 10 equals 0, where x is basically e to the 3t over 2, and now x. Oh, come on! Why? A classic further maths again, isn't it? Why can't you just, like... Do you know what I'm saying? There's no need for this. Why couldn't you just have a nice answer at the end? Just to give you a bit of... So, I'm going to do it this is my favourite way to actually solve a quadratic. So we get subtract 4, so... it's not even... yeah, so subtract 4, subtract 10, so this is 14. So x is equal to 2 plus or minus the square root of 14. Now, I suspect that there's a reason we don't want to subtract root 14. So 2 subtract root 14 is negative. And why is that bad? Well, because e to the 3t over 2 is greater than 0 for all real t. So we reject that one, and we'll take 2 plus root 14. So e to the power of 3t over 2 is equal to 2 plus the square root of 14. Log. So t is equal to log of 2 plus root 14 multiplied by 2 divided by 3. To 3 decimal places it wants it. So, fingers crossed.
I don't understand the factorization step, sorry.
Which step, sorry? This.
The x squared minus 4x minus 10 step.
Yeah, so this is like, if you complete the square, you get x minus 2 all squared, subtract 4, subtract 10, take everything over to the other side, and then you square root it, and then you add 2.
actually, yeah. Okay, I'm with it.
Yeah, so I did that a bit quick because if you've got even coefficient of x, completing the square is like a rapid way of getting your irrational solutions. So equals 1.17. Oh no, 165 to 3 decimal. That is very small. Oh, t is in years though, so 1.165 years. That seems plausible. Right, please tell me this is right.
Is that your
It's
final
right.
answer?
That's my final answer. Yes, million pound question. Yeah. Okay. So, right, and then suggest a limitation of the model. Just because this paper refuses to end. Right, a limitation of the model. So, what assumptions have we made here? I suppose I don't know. We've assumed that it's a continuous relationship, or maybe sometimes if you like, what happens if you take t to infinity? Like, I suppose beyond this, the number of white-clawed crayfish will go negative, which can't happen. But that doesn't really fit with the model. Oh, I know. Once the white-clawed crayfish has died out, then the signals probably won't have the same relationship because now they're in like uncontested waters. Something like that.
Both of those are good.
Not realistic beyond 1.165 years. I'm just going to say that. I think I've verbalized my answers for that. What else did they put for that?
That is, both of the points that you made are absolutely correct, and I really like Dave's answer of why there are no other populations that might influence the other creatures.
Yeah, that's true.
Like that one. That
Yeah.
one's not in the mark scheme, but I really like it.
Yeah, because you don't know what's going to happen. You know, this is kind of influencing them, but once one starts to go down, there might be another predator that's going to come in and take advantage of. You can't just assume that it's always going to be that way. So I think that's a good answer there. Right. Well, God, that was
interesting one.
That was as tough as I expected it to be. Actually, that was sorry. I'm just getting over the fact that we've done this. But yeah, that was tough. That was tough.
Interesting question. Why is a pure maths exam asking population modeling questions?
Well, yeah, it is a good question. I think because at this level, this is pre-specialization in some way. Because obviously, you get to university, it clearly divides into, you've got your pure, you've got your applied, and you've got your stats. And then there's further divisions there. So applied usually devolves into, so you've got your fluids, you've got your classical, you've got I was going to say numerical methods. Is that would you say that's applied? Probably not actually, but yeah. And then your pure broadly like separates into algebra, analysis, and geometry. Number theory is a bit of one that straddles a few areas. So obviously, the further you go, the more specialized you get. I think at this stage, it's sufficiently unspecialized that you can, the pure element to that is the differential equation. But I think you know what I mean. Am I making sense here? Like it's before the fields have diverged, so I think you're justified in having that on a pure question. Although I do agree with the principle that no one likes to answer those questions. Because it's not pure maths.
I also think that it's probably good to have it on these papers. Like us mathematicians, we've got quite a lot of power in our model building, so we should be able to describe like where the limitations are.
Yeah. I think it's anybody who's actually going to be doing this in practice needs to know some mathematics and absolutely needs to know the limitations. So I think it's training that kind of thought, isn't it? So yeah, I think that's a good point as well, Dan. Yeah. So I think at this stage we've done that paper. We've done 9 papers in 9 hours. So I'm on par at the moment. We did do a further maths paper, which took a lot of time, but we also did the key stage 1, 2, and 3 papers, which took up very little time. So par is actually bad for me right now. I would have preferred to be ahead of time. Anyway, it is time to switch over to part 2. So in the description, you will. Oh my god, another flash of lightning outside. Sorry. In the description, you will find a link to part 2. So what I'm going to do is in 30 seconds or so, I'll stop this stream and I'll start the next one. So if you could all join me over there, that would be absolutely fantastic. Just because of the YouTube limitation. Even better, Dan. Thank you very much for that. Yeah, that's far more sensible. Thank you. What would I do without you? So let me turn this one off, and we'll start the next one.